All right, hello, good morning. Thank you all for coming to the first talk of the morning. It's often the hardest talk to come and see. So I'm going to talk today about how to build safe bridges and how privacy properties that are involved in components of bridges can affect each other and the overall safety of the system. It should be at a pretty high level, so we won't go too deep into anything necessarily, but we could certainly do so during questions. Oh man, this was just working. Hang on a sec. We'll make this work. All right, there we go. So I am the research engineering lead at Alpen Labs, which is working to build a safe and functional and reduced trust bridging system. And I'll talk a little bit about what we're doing throughout this talk. And as usual, while some of the stuff has been reviewed, not all of it has. And as always, not professional or legal advice. So the question we really want to address today is, does privacy matter when building a modern bridge? I'll give you kind of like a spoiler. The answer is yes, but as most things in cryptography, it's kind of complicated and subtle. Maybe a more important question is like, how does it matter when we're building a modern bridge? So we'll talk very briefly about the context for this, which is Strata, which is what Alpen builds. So Alpen is building Strata, which is a Bitcoin bridge design that is focused on reduced trust. Used to kind of like the term trust minimized, but a minimum for trust is 0, and there's always some trust in these systems. But we do want to reduce it to the extent possible. There's been some talk already, if you were here and saw Liam's talk yesterday on Argo, which deals with some garbled circuit-based designs. That's kind of related to some of the things that we're doing and shares some of the ancestral work to it. The core cryptography behind Strata, this bridge design, is kind of two interrelated components, one of which is called Glock, one of which is called Mosaic. Liam Egan wrote the Glock preprint while affiliated with Alpen. You can see it's linked over there if you want. And Mosaic is kind of some technical stuff that we built out that handles malicious security, which is needed for these systems. And together what these do is they work together to build this cryptographic primitive called a garbled circuit lock, which tries to do sort of what like a hash lock or a time lock does, but in a more complex way that lets us enable expressive, optimistic computation for Bitcoin, but with very low on-chain footprint. And our design in particular is built to extend to multiple off-chain L2, we call them execution environments. Initially, building out, as some do, an EVM-compatible environment. But I also think that there are some more interesting ones technically. EVM stuff is, of course, very interesting, but cryptographically, there's also more interesting approaches that we can take later on that we'll talk about. So let's briefly talk about the bridge roles here. This is a little bit simplified. If you're familiar with bridges, some of this may be very familiar to you already. So we can think about users, and users lock funds on-chain, on Bitcoin, which then triggers, via the bridge mechanism, off-chain minting over on the L2. Stuff can happen on the L2, that's the point of having an L2 in the first place, and then later, another set of entities, the operators, well, the way that they'll handle this is when the user on the L2 ends up burning the funds in a very carefully controlled way, they're going to want to unlock corresponding funds over on L1. Operators actually front the funds to that user for unlocking, and then the operators will attempt to claim the original funds on L1. So there's a fronting process, and then the operators try to claim the original funds back again to get paid for what they're doing, and also can receive a fee for their services. But those claims might be incorrect, inaccurate. The operator might be evil. This is optimistic, so we also introduce another set of entities called watchtowers who will examine those claims, kind of in an optimistic sense, and they will, through cryptographic mechanisms that are enabled by this Glock and Mosaic design, slash evil operators. But they should not be able to slash honest operators. And what's cool about this is that withdrawal happens if at least one operator is available to do this fronting and service the withdrawal, and it's safe if at least one watchtower is honest in the event of an evil operator. So trust reducing, but still some trust, of course, involved. This is a very simplified look at the way withdrawal works. In practice, this is done via some covenant emulation, which is done via this pre-signing process. It's not particularly relevant for our purposes, but the idea is that we can build kind of a graph of transactions on Bitcoin that through this covenant emulation process ensures that only certain logical paths can be taken through this graph to execute the logic of the bridge. Things can't just happen unilaterally if evil users decide to just make random transactions and pull funds everywhere. The idea on the left is that the operator makes a claim. And that claim is effectively a proof asserting that it is able to receive the funds back via this unlock process. And I'll talk more about what that means in a little bit. The watchtowers, if they believe that that operator claim is invalid, can issue what's called a counterproof, which says, I, the watchtower, am asserting that the operator is evil and is not eligible to receive this. The claim is invalid. If the watchtowers don't do that, we can take that top path over there, which eventually will just let the operator, who is presumably honest in this case, to receive its payout, its reimbursement. In the event that the watchtower issues a counterproof, we're on the lower path there. And the way that this Glock mosaic bridge system works is that counterproof goes into this garbled circuit cryptographic mechanism that we'll talk a little bit about, which will then evaluate, not the operator claim, but it will evaluate and reason about that counterproof and whether or not the watchtower is correct and honest about its assertion that the operator is evil. Well, one of two things can happen. It could be the case that the watchtower is evil. In that case, the operator is honest and the operator can receive its payout. But in the event that the watchtower was honest and the operator was evil, then that will allow for slashing via a mechanism we'll talk about. So there's several components that I've kind of briefly hinted at here that go into building this bridge. And each of these is going to have privacy properties that we may or may not care about. So several of the components are, well, we talked about the operator claim. For that, we need a cryptographic proving system. In practice, we need it to be succinct in a few ways. We need it to be simple. We need it to be small to reduce on-chain footprint. But you'll notice that I didn't include the word zero knowledge in there, and this is an important thing we'll talk about. Similarly, the watchtower counterproof also needs to be a succinct proving system. Interestingly, it doesn't have to be the same one, but in practice, it often is. And for similar reasons, we want it to be small, fast, and have other properties. We talked about the garbled circuit. The garbled circuit needs to reason about the counterproof. So in practice, what we do is we take whatever the logic of counterproof verification is via that proving system, and we encode it into this garbled circuit in some pretty cool ways. So those are kind of the fundamental bridge components that go into that graph that I showed. But we also have kind of an open set of related but non-directly bridge components. And those are these L2 execution environments on the other side of the bridge. The bridge, of course, connects an L1 to multiple L2s. So what about the L2 environments? Those can execute all sorts of things. They could be EVM compatible. They could have other privacy-related properties or other functionality we might care about. So there's kind of this big open space of what properties do we need or want from the L2 environments. And how should we think about privacy properties? Well, let's first talk about the proving systems. So proving systems allow us to reason about computation in ideally efficient ways with cool properties. And these proving systems that we care about, there's many different ways over the years that people have constructed these. It's a really cool area of research that is still ongoing. The ones we care about might have a functionality that's called wrapping, sometimes called compression, depending on who you ask and who you talk to. Alpin right now uses one called SP1. And what SP1 is, at the end of the day, it gives you a so-called Groth16 proof, which is one of the older proving systems, but it's very small and it's very fast to verify. For that reason, we tend to like it. It has other consequences and trade-offs that we can talk a little bit about later. And what this wrapping does, the Groth16 wrapping actually shows a proof of correct execution of some fixed but arbitrary program. And we can control what this program is reasoning about. But at the end of the day, we end up with like this wrapping of a proof inside a proof. It's like proofs all the way down. It's actually very interesting, but it can kind of mess with your head a little bit. And this paradigm is sometimes, not the wrapping necessarily, but this program execution paradigm is often called a ZKVM. Basically, roughly speaking, asserting a program was correctly executed, in theory, with what's called witness hiding. We'll talk a little bit about what this means in a second. But the idea is that we may want to hide or kind of imply certain parts of this reasoning for various purposes. But there's letters Z and K in there, and the question is, do we need these proving systems, which are often a ZKVM, to be zero knowledge or not? Well, okay, what about ZK? So I said proving systems let us reason about computational relations that are expressed in very formal terms. And there's kind of two parts you can think about it, a statement and a witness. And there's a relation between the statement and the witness. The statement is often considered like public data. It's the public input that has to be given. In our case, we want to keep that as small as possible because it has implications in our bridge design for the on-chain footprint. However, the witness is basically implied. It's often considered to be secret, but it does not need to be secret. The idea is that it is not directly given, but it's implied and kind of connected to the statement via this computational relationship that we build. For this reason, it's often very helpful to take big, complicated, expensive data and kind of pack it into the witness because the proof just kind of takes care of it. We don't have to worry about on-chain footprint with that. So it happens to have a really nice benefit for size scaling for us. And the question we want to answer to know if we really need ZK for this proving system is kind of the very rough question, is the witness secret? There's a technical definition for what ZK means involving proof simulators that we don't care about, but in practice it means, is the witness secret? If the witness data needs to be secret and not revealed to the verifiers of this, then you need 3 properties. Formally, you need completeness and soundness, which means that you can't cheat the proving system, but you also need the proving system to be ZK. If you don't need the witness to be secret, you need the first 2 things. They're very important, but you don't need the third. So what do these witnesses actually look like for the proofs that we deal with? We said that there were 2, the claim that the operator originally makes, asserting that it's eligible and able to process this withdrawal and receive reimbursement, and the watchtower counterproof, which may or may not be issued, asserting that the operator was invalid in some way. So turns out there's a lot of stuff that we can bake into the witness to keep things very small on chain. The operator claim, for example, and I'm not going to go to the details of this, but very roughly speaking, what it does is it basically says that there exists some off-chain L2 state that we eventually got to, on which there was a valid burn. That means that the user wants to go and unlock on L1. We need to ensure that the operator actually issued a valid payout, the fronting process, to the user on L1 to be eligible for the reimbursement. It makes a claim about an allegedly canonical Bitcoin chain on which this happened. We need to care about malicious forks or just kind of made up data. So it's a claim of a canonical chain. And the operator needs to show that it actually has the authority from L2 to be processing this specific withdrawal based on whatever algorithm might be chosen. The watchtower counterproof, on the other hand, it reasons about a couple of things, one of which is the operator claim itself. So the watchtower counterproof reasons about the existence of a signed operator claim, which it's claiming is invalid. Maybe the proof itself is invalid, or maybe what it's reasoning about is invalid. And the watchtower counterproof can also reason about an allegedly more canonical chain if the operator was lying. And if you sit in a dark room for long enough and think about this with your favorite beverage, it may come to you that none of this stuff is actually secret. This is all publicly known and publicly reasonable information, either on L2 or on L1. And because of that, neither of these currently actually need these proving systems that are used for the claim proof and the counterproof to be zero knowledge. The answer to the question back here of is the witness secret is the bottom path. It's no. So we need the proving system to be complete and sound, and also ideally very small and succinct, but we don't need it to be ZK. I'm now going to get up onto a soapbox for a moment and just say one thing about ZK VMs, then I will get off the soapbox. Not all ZK VMs are ZK. We just said we don't need that, but for some use cases, you may care very much about this question. ZK VM is unfortunately kind of morphed into this odd marketing-y term in some senses, where you might not actually get ZK. You might have a proving system that has other properties that you really like, maybe complete, sound, succinct in certain ways, but it might not be ZK. This actually came up at Alpin, for example. We were working on another project that was kind of related, but not directly related to this, and we did need a ZK proving system when we were kind of surveying the landscape, and unfortunately found that we were interested. I'm just giving 2 examples here, just because they were relevant in my mind. Binius and Stu Cairo, for example, which people will often refer to them as ZK VMs, but unfortunately don't yet have this property. There are techniques you can use to make these proving systems ZK if you need that. But in our case, we don't need it, and they haven't done it yet. So caveat prover, let the prover beware. There are definitely circumstances where you do want to be ZK, and you should make sure that you know what you're getting. I would very much like it if we would stop using this terminology. So thank you for coming to my TED Talk. I'm going to get off my soapbox now. So we talked about proving systems and talked about some privacy properties that we don't necessarily need for this use case. But let's talk about the garbled circuit. So there are a lot of ways to discuss garbled circuits, but in its classical sense, this stuff was invented in the 80s. It's so cool that it's becoming useful now. This makes me very happy. But classically, garbled circuits use secret inputs from 2 parties, a garbler and an evaluator, shown up there. In our case, the garbler is actually the watchtower, and the evaluator is the operator. Different bridge designs may use this differently. And the idea is that they want to perform a joint computation together. The classical example is they both are rich people, and they want to see who's richer without showing how much money they have. This is the prototypical example of this. And they want to perform this joint computation together with secret inputs. Well, it turns out we can kind of overload this process and this concept to do what's called conditional disclosure of secrets, where once they put their inputs into this garbled circuit, depending on the result of the computation, you might get a predetermined secret that is previously unknown to this evaluator out. Turns out we actually care about this very, very much. Because if we're very clever about it, which we think we are, we can actually tie this secret to like a signature unlock on Bitcoin. And that's actually what like allows this garbled circuit lock to be unlocked. It's very cool. Come talk to me about it later if you want to know more. But the question is, can we relax this privacy requirement on the secrecy of those inputs? We do need the secret at like the bottom to be secret. That's like very, very important, crucially important. But can we relax the privacy requirement at the top? Short answer, yep, we can. If you went to Liam's talk, he mentioned the term authenticity. I'm going to mention it again. It turns out we don't need a particular privacy property for these inputs. We need the inputs to be what's called authentic or authenticated. We need authenticity, which effectively means that while the inputs are known and public, they can't be faked. We can't just throw arbitrary data in and claim that the other party threw an input that the other party did not authorize. This is also very crucially important for the system to work for the bridge application that we care about. Why do we not need privacy? Well, in our case, the garbler, that is the watchtower, input to this garbled circuit is only its public counterproof. Well, that counterproof is public, so we don't care about privacy for it. It's a proof. We just need to verify it. There's a couple other small things that go into it as well that aren't relevant here. And the other party, the evaluator, who is the operator, it turns out has no input whatsoever. It's kind of like a one-sided computation in some sense. So we don't need privacy at all. And this is actually very crucially beneficial to the practicality of the system. There's many different ways that you can garble a circuit, as we say, different schemes that have come up over the years, some of which are very old from the 80s, some of which are newer, some of which are like unbelievably new, like this year new. It's wild. And it turns out that for the Groth16 verifier circuit that Alpin uses, well, a couple options we could use. Like the original old school kind of naive method, Yao came up with it, so we sometimes just call it Yao garbling. It turns out that if you were to do this garbled circuit thing, the off-chain data that you would have to maintain for these different parties is like 800 gigabytes. Yao garbling is private, so we thought, can we do something else? Turns out, yes, we can. There's other options, one of which is called free XOR, which is still private, but a little bit more clever. That gets you down to 200 gigabytes. Yeah, still kind of big. The technique that Alpin uses right now is called privacy-free half-gate garbling. Privacy-free should tell you that it's not, in fact, private. That actually gets us better efficiency as well, down to 50 gigabytes, which that's a reasonable amount. But it turns out there's some very recent work that's being done on some specific garbling schemes that target different kinds of operations, one of which you may have heard about from a previous talk called Argo, which is designed to work with certain group operations. Another one, so Argo is being done by Liam Egan and his colleagues at Ideal Group. Another one called Babe that recently came out. That is a collaboration between our friends at Babylon and some folks at Berkeley. That's specifically designed for Groth16. And then some other work that's in joint collaboration with Alpin Labs, UCLA, and UIUC, called duty-free bits, or DFB. And with some of these techniques, they're not inherently private. You can get down to probably like a megabyte. So we're like this curve just keeps getting smaller and smaller. And if you don't like 50 gigabytes, hopefully you like a megabyte. So everyone's kind of looking into this space, but there's a lot of options you have. And I put an asterisk there because like we haven't really looked into the idea of like what if you were to like add privacy back into these newer schemes. You could probably do it. You might have like some marginal added complexity and size. And we already established that we don't need it anyway, so I don't know. If you want to academically go look at that, please go do it. Have fun with it. So we talked about garbled circuits and privacy requirements, some of the proving systems. If you remember back to the previous slide in your head, we talked about the privacy-related properties of these L2 execution environments on the other side of the bridge. So there's many different transaction protocols you might want to put on an L2, and they can provide, or not provide, depending on your use case, certain privacy-related properties that mostly stem from the idea of like data and metadata protection. Things like Bitcoin, for example, offer like almost none of these, although folks can try to emulate that using certain techniques. Indistinguishability is kind of one primary goal here, where ideally all your transactions, if you want to provide some meaningful definition of privacy, should kind of be like as much of a uniform blob of the same nothing as possible, some kind of uniformity of structure, and that can help with many different things. It can mitigate censorship, it can kind of thwart adversarial analysis, which is getting very good depending on the transactions. Related to these, you might want spend ambiguity, the idea of which is to make it unclear to an outside observer which assets are like consumed or spent in a transaction, or you can think of it as like what user actually authorized the transaction to take place. Recipient hiding can protect the destination user of generated assets, and things like value protection can keep the value of assets in the transaction unknown and protected, while also simultaneously ensuring that transactions balance so you can't just mint free money. These all kind of like are somewhat related, and you can define them formally in different ways. Interestingly, we do need these, being an L2, to be compatible with this minting and burning process, where when you lock funds on the L1, like Bitcoin, you end up minting funds, and then when you burn them later on the L2, then there's a corresponding unlock process. They may seem to be at odds with this idea of indistinguishability, spend ambiguity, recipient hiding, maybe even value protection. And it turns out like, you can often build or modify privacy-focused transaction protocols with mints and burns in mind, but there's all sorts of like caveats you have to worry about. And like the dragons kind of live there in some of these protocols. Some examples that I like, there's a ton of examples. I just gave 3 that like I think are very cool, that I think would be cool to investigate for this L2 purpose. You have something like the Monero protocol, the Zcash protocols, and shielded CSV. It's kind of a cool Bitcoin-focused one. All these use different approaches toward their different privacy goals and can provide different practical and theoretical privacy depending on how they're used. Monero, for example, currently uses techniques like linkable ring signatures, proposals to move those to more general zero-knowledge proving systems, diversified addresses for recipient hiding, and then commitments for its value. Zcash is actually kind of a collection of different shielded type protocols that all kind of interact with the same transparent layer. You can kind of think of it as like multiple shielded protocols in a trench coat or something, is one way to think about it. They use different flavors of ZKPs, another form of diversified addresses that depends on the protocol, value commitments, and then shielded CSV kind of takes a totally different approach that tries to minimize the actual like on-chain consensus, uses kind of an account system, some cool like proof-carrying data techniques, and does a lot more kind of peer-to-peer between senders and recipients as opposed to being on-chain. It's really cool. Monero, of course, like exists as its own like separate like deployed chain and project, as does Zcash. I know some folks are working on shielded CSV, but all of these can also be thought of as protocols that one might want to like modify, build, or deploy elsewhere on L2s. And as I said, each of these has different trade-offs and techniques. There's a whole lot in the literature about this. It's really fascinating. But I think they can all have value for different execution environments, and I would like to see them investigated. But the question is, if we have these protocols, all of which have like kind of privacy-focused goals in mind, does this require bridge privacy, which I'm putting in quotes, by which I mean, does this require the bridge components that underlie the bridge to those L2s to have those privacy properties? I argue not necessarily, which I think is like an interesting discussion to have. So we talked about the idea that on these bridge-related proving systems, provided that we're able to keep the witness data public, which we are right now, you likely could in the future with these other L2s, it means you don't really need ZKVMs. And again, what does ZKVM mean? It depends who you ask, but realistically, you don't need ZKVMs. In theory, you can get away with VMs or whatever, a term that I just coined, whatever. And the garbled circuits, we said, only operate on public data, and they kind of minimize that public data as well, so that inherently doesn't need privacy at all. So we do have options for what we can choose for these different proving systems, and as we saw, we can play around with the efficiency of garbled circuits to a huge extent based on this observation. I would argue, however, that it still could be useful for like future kinds of bridge designs and L2 support and different ways you could build and implement a bridge system to still consider the benefit of like a proper ZK VM anyway. You could come up with examples in your head about like where you might not be able to keep all the witness data public and where you might want some of it to be private. What's nice is that we do have proper ZK VMs now, and there's work underway to take those that might not be, but have other neat properties, and give this property to them. And I want to see more work continue in this space. But there are other considerations when you're looking at different ZK VMs, some of which are trust assumptions. Groth 16, if you know much about it, you know that it has this kind of trusted setup process, which you can make distributed, but is a trust assumption that you may not be happy with. Other ZK VMs and VMs don't necessarily have this property and are more trustless in their setup. Because the watchtower counterproof needs to be represented in this garbled circuit in some way, we might care about like what it actually means to execute the verifier of that proving system. So there's some that are much more complex. I mean, the Groth one is quite big and complicated in and of itself. Currently, this privacy-free half-gate version of it still is like 50 gigabytes, but it's still doable. Other ones, we might have to be a little bit more careful and clever about how we consider the complexity of the verifier circuit. And related to that, we need to make sure that we have like compatibility of this particular verification scheme with whatever garbling scheme we want to use for the garbled circuit. For example, Argo is specifically tailored to certain group operations. Babe is tailored specifically to Groth16, whereas the other like YAO and privacy for Fgate are a bit more general, but with higher cost. And finally, everyone's been using the Q word, so I'll use the Q word now, post-quantum security. It's a very interesting question about which proving systems you should choose or not choose based on what you want or maybe don't care about with post-quantum security. Groth16, for example, and other discrete log and pairing-based proving systems are typically vulnerable to cryptographically relevant quantum computers, whereas some other designs, like hash-based operations, are considered not to be vulnerable. So there are definitely trade-offs here. And I think the overall lesson here to keep in mind is that bridge privacy and L2 privacy are not the same thing. They don't necessarily imply each other in like a very clean way. But as we saw, privacy properties do affect the bridge components, like these proving systems, the garbled circuit, and the L2 transaction components, which you could have many of, in different ways. But we saw that optimizing the properties at the bridge level can be done safely and in many cases like with great efficiency benefits. However, retaining those things and those privacy properties at the bridge level where it makes sense can give you a broader design space, which I think is beneficial in and of itself. So this is a really cool area of research. I hope it does continue. I'm excited to be able to work on it. So thank you very much for listening. I don't know where the moderator went. I assume there's time for questions? I think we do. Oh, yes, a thumbs up. We do have time for questions. Thank you. That's okay. I blew you all away. Oh, I think there's one there. They probably want you to use the microphone.
I can speak really loudly if that works.
Okay, I'll just repeat the question for the recorded audience.
You were mentioning that there's a lot of dragons once you start to get into some of the where you're seeing
Yeah, so I mentioned out at the bottom here that like you can, yeah, so the question for the audience was like, what are the dragons that I mentioned down here? And I said that it's generally possible to build or to modify more privacy-focused transaction protocols with things like mints and burns that could be compatible with the bridge in mind. Yep. And there's different ways you could do this, and I look forward to like researching this more, like once this bridge is like fully built and deployed with an EVM environment. But a good example for this, I think, is Zcash. You can consider Zcash to be several shielded protocols that interact with a common kind of transparent layer, which is roughly speaking Bitcoin-ish. Originally was actually based on Bitcoin codebase. And when you perform these kind of like shielding or de-shielding operations, shielding means that you take these transparent, visible assets and move them up into the shielded pool to have your way with them. And then eventually you may want to, depending on your use case, bring those shielded assets back down to the transparent layer. That does leave metadata footprints. And that metadata can be very useful. I mean, there have been some analysis on like some early Zcash work. I don't know the extent to which this practice extends nowadays, but I'd like to know, that kind of looked at metadata of funds going into a particular shielded pool and then later coming back out again and wondered, can we heuristically try to link those together and, I don't know, like remove some of the guarantees that users maybe thought that they were getting. And heuristically, again, only heuristic, if I remember right, linked like 30% of the funds or something. So, you know, people who were doing these kind of transitions perhaps were not getting all the privacy properties that they thought. So I think that is, again, I think there's an analogy between that and like this mint and burn process where you leave metadata footprints. And so I think you have to be really careful about how you do that. There's ways to mitigate this kind of heuristic analysis. Other folks would say just like keep your funds shielded at all times and then you don't have to worry about it. But part of a bridge is that you might want to come back down again. So I think it's an area where like research can be very useful, especially on the bridge side. But yeah, that's an example of such a dragon, and there'll be others. Oh, another question.
It's very important for this kind of technology. I use four-dimension data model. What do you use the data model?
The question's on like the data model that we're using. Like, I'm not sure I like know the exact context that you mean by that.
You use the metadata.
Oh, are you talking about like when I am, like on this slide, for example, when I talk about like transaction data and metadata? Oh, okay. I'm using the term fairly generally, and so I may not be using it in the way that you're thinking of. What I mean, for example, is even if you have like a transaction in like a privacy-focused protocol, like a Monero or a Zcash, for example, right? Those do protect a lot of data, things like spend ambiguity, recipient ambiguity. But for example, some kind of metadata that might be leaked from certain versions of these is like the number of outputs the transaction has. That can be like a very useful piece of metadata. Does it actually directly reveal like where those funds are going? Like not necessarily inherently, but that can unlock a lot of analysis. So like different aspects of a transaction that aren't necessarily what we might think of as like its core data, like sender, recipient, memo, value, can still provide footprints that can be used for adversarial analysis. That's kind of the metadata that I'm meaning. So I'm not sure that maybe what you're referring to as like the data model is maybe the same thing that I'm implying here. I'm using a term like very vaguely and generally, but we can certainly talk about it afterwards too if you had other things in mind. Oh, yes. You should, yes. yes, timing. I mean, yeah, there's so much that we could talk about in here for analysis. There's like network-related metadata. Timing metadata can be timing metadata can actually be used to your advantage, for example. Like one way to do certain operations that involve kind of transparent interactions in these protocols might involve, for example, users trying to like coordinate around like the same times in order to kind of give like more of like an anonymity pool. But at the same time, timing data can give away information like location. It can give away information about transactions that may be linked or related together if they're done in rapid succession. Yeah, it's, as much as we would love for all transactions to just be like a uniform blob of perfect nothingness, like no one has accomplished this. There's been a lot of really good work into it, but like it's really hard not to leave metadata footprints. But that's another talk. Okay, do we have time for more? Oh, cool. I think that we're probably done. So please come find me afterwards if there's other questions. I'll be like out in the back. So thank you again for coming to my talk.
Awesome. Excellent. So, thank you, Aaron. Making plumbing sexy is a difficult thing to do, so we very much appreciate it. Keeping the infrastructure theme going, we're going to upgrade from sort of the pipes in the walls to more of the heavy-duty industrial. If Aaron showed us how to make the plumbing private, our next guest, Misha, is going to talk more about making those pipes programmable without actually waiting for Godot to show up or for like a 3-year debate on the mailing list. So wanted to introduce Misha, if you could come on down and give us a talk about Bitcoin Pipes V2. So thank you very much and looking forward to it. Thank you, guys.
The plumbing topic, huh? Like, hey, it's me, Mario. Alright. That work? Okay. Didn't work. What have I done wrong? Ah. Yeah, just do that. Okay, good. All right. So, plumbing topic. Let's go for it. Should have brought an orange plumbing pipe, like whatever. Anyway, so Bitcoin pipes. Yeah, let's start with that. I'll start with a fairly obvious, I would say, statement that we are in a state of governance paralysis. We are ossified. We will not see significant protocol changes in future. This, though, even given recent post-quantum conversation, et cetera, as you might have guessed, affects not only kind of adoption evolution, but like it starts affecting a little bit security as well. So we're going to be talking about, can we bypass the governance paralysis somehow, instead of arguing about soft forks and changes all the time and playing politics and doing camps and all that stuff? Can we bypass it somehow? Can we do something without changes? So, and like the thing which we kind of there are limits to what you can do without putting together a governance vote or without putting together any kind of consensus. And well, again, there are solutions to post-quantum. There are solutions to like whatever covenants and never-ending arguments about should we add that opcode or this opcode, or like should we enable covenants somehow? Should we put them somehow here or there, anyhow, right? So pipes focus primarily on Bitcoin pipes like is a concept which focuses primarily on introducing governance to Bitcoin without putting together a governance vote or without putting together any kind of consensus. And the goal is to try to kind of outsource as much as possible and to emulate as much as possible outside of the consensus, outside of the protocol, while kind of trying to while trying to not to introduce new trust assumptions or new interactivity or anything like this. Obviously, this sounds a little bit like utopia, but well, 2 years ago it sounded not just like utopia. 2 years ago it sounded like complete insanity. Well, honestly, year and a half later, I think we're ready to talk about something which sounds more realistic, and this is called Bitcoin Pipes v2. So what happened, right? Like, first of all, yes, like kind of the whole goal stays the same. We enable kind of we enable, unless kind of pipes enable arbitrary spending conditions. We'll talk about how different they are, what they can enable, what they cannot enable at this point, like just the current state of research, right? But pipes do enable arbitrary spending conditions. It's based now of witness encryption. I mean, because some of you might remember, like some time ago, kind of the general view, kind of this futuristic view that ideal scenario would have been if we had functional encryption, though something more down to earth. We were able to make, to make sense of, and we were able to make it work, is witness encryption based thing. So. Yeah, so it's based on witness encryption. The witness encryption itself is instantiated of the paper we have released and published recently as well. It's called the Arithmetic Affine Determinant Programs from basically Garuda Verifier. So as you might have noticed, it does implement Garuda inside of this very weird construction. Saying just in case, this presentation is not supposed to explain all the internals of the witness encryption. I try to keep it a little bit kind of high level, because, I mean, it takes quite some time and effort to do like proper seminar witness encryption. So if you want to catch me up or like hit me up like after the preso, this one is more like kind of Bitcoin oriented and what does it mean for Bitcoin. So yeah, and yeah, so Bitcoin Pipes v1, kind of that was this futuristic view about can we actually do something outside of Bitcoin. It was published in October 2024, and it was like basically, again, as I said, based on functional encryption. V2 published, we have published it just now. We'll talk about how it works, like in particular, in the next slides. We've published it literally just now. As I said, it's based on the ADP witness encryption scheme we've put together a bit, like over the last many months, I guess, at this point. Since this is witness encryption, I mean, again, kind of everybody kind of understands, I think, the overall workflow. Like you create a key, you lock it somehow, right? Like as a committee, nobody knows the key. There is like whatever one of trust assumption that one member of a committee is supposed to be honest. That's the thing. You lock the key there. Nobody knows this key. Afterwards, the public key corresponding to the secret one can be used as, well, basically UTXO related to that can be used as like a deposit address for being able to make the off-chain logic, make the non-consensus logic to be able to work with people's Bitcoin, with your Bitcoin, like you yourself basically do that, right? So after that, you do some computation off-chain, you prove it, you unlock the pipe, as we say, you decrypt the key, you sign the data, you sign the witness you used to decrypt the ciphertext. You sign that, you submit that to Bitcoin just to show that, hey, I decrypted it with this particular witness, and this results into effectively being able to use that data further inside of Bitcoin script, kind of in whatever you want to do with it, kind of further. It's like a two-transaction interaction. It's like, but anyway, this gets you kind of results verifiable on Bitcoin, which you would have never been able to compute inside Bitcoin script otherwise. That's the thing. And yes, like if the computation was not performed correctly, you will never get your secret key. No secret key means no attestation transaction. No attestation transaction means you have never done the computation correctly. So it's like you cannot cheat that. As I said, you just sign the stuff after you have done the decryption. You got your key, and like that's basically what it is. The benefit of this is the footprint is kind of stays similar to what the standard transaction is. Like it's just a signature verification. Plus, if you or in your app or in your protocol, in whatever you do with Bitcoin script, want to use the witness, which you use to decrypt the ciphertext, well, it's the size of this witness. But it's up to you. Like it's up to the developer. So yeah, like the general workflow stays in general the same. Like the developer creates the key, encrypts it, like the committee does some MPC stuff, nobody knows the key. Yeah, like as I said, you lock that, you prepare some witness, some ZKVM or circuit compiler or anything like this, you define that, you evaluate that, decrypt, sign, submit, you're good, standard transactions. So what can you do and what you cannot do with this, right? So this gets you certain type of covenants in comparison to Pipes v1, which which were able and which are able to like introduce, I would say, and to give you arbitrary spending conditions, like arbitrary, right? Like you want a non-consensus logic like CTV. Sure, you can do that. You want non-consensus logic, like, everybody hates that now, but like you want a cat. Sure. You want something else. Sure. Unfortunately, or, fortunately or unfortunately, whatever, we got to be honest about this, witness encryption, it does not give you predicates, does not give you the attestation of stuff which isn't resulting or which doesn't result into kind of binary result, in like something binary, right? So all the predicates you can define with like witness encryption and with Pipes v2 effectively are binary. So this means you can do only certain stuff. So this kind of introduces an interesting split between kind of covenants we have. We have pre-covenants, which kind of define, kind of how your transaction is processed before being submitted and what should be done before it's submitted, and post covenants, which define effectively the full transaction, which define the template of the transaction, if you want to call it this way. So V2 directly on Bitcoin L1 are capable of emulating pre-covenants, what we call kind of binary predicate covenants. CSFS, sure. Upvolt, I know it's deprecated, right? But like, it's a binary covenant. It's a bit of a binary covenant. So that's what it is. Indirect emulation of all of the stuff which does not result into a binary result is into something binary is kind of also possible, though that's more complicated because, of course, you can put together a bunch of non-consensus opcodes into a large predicate, right? And you can evaluate it, and you can make this predicate basically a closure which gets you 0 or 1 in the end. So it's just a more sophisticated stuff, and then you can attest all of that to Bitcoin within a single transaction. So that is also kind of possible, but that's a little bit of indirect way of doing stuff, I would say. So depends. So there is like a lot of discourse, I would say, in terms of, since we're talking about like ZKP's verification, there's a lot of discourse about, hey, we can already do ZKPs on Bitcoin, right? We can just, kind of try to kind of disprove whoever claims something to Bitcoin script. Usually this kind of stuff, kind of is employed within BitVM, within constructions like BitVM, within kind of optimistic verification stuff, and it all works. I mean, it works fine. There is always a little bit of a thing about that. There is a disproof transaction. There is a dispute period. There is an on-chain cost to it. There is an on-chain footprint, and there is interaction. There is always interaction. If you want to build a bridge with that, you're kind of getting constrained by liquidity, liquidity collateral on the operator side. So you cannot really put through, I don't know, like million Bitcoin through that, right? Because simply nobody has million Bitcoin. No operator will ever have a million Bitcoin in their disposal. I'm just telling you, no bridge operator will ever have that. So this kind of constrains a lot of stuff. And so, yeah, like pipes are, as they like to say, more about pessimistic ZKPs. Sure, there are questions about kind of, probabilistic finality. Yes, it's all known. It's, we're working on it. There might be a way to like, yeah. So, but in general, yeah, that gets you kind of pessimistic verification. So, yeah, we will also be, yeah, okay, so what does it get you, honestly? Okay, I switched to the slide a little bit preliminarily, but let's talk about that. Hear me out. Consensus verified meta protocols. Sounds like oxymoron. It sounds like a little bit, something weird. But since you have pessimistic verification, you have a single transaction verification, and sure, there are nuances with probabilistic finality, which you gotta bypass. You gotta make people wait. You gotta enforce this wait time. You gotta make sure that people don't submit stuff too early, so probably some VDF is required there. But once you have a single transaction verification on Bitcoin, you result effectively into being able to put actual Bitcoin to work inside of meta protocols. I mean, think of non-consensus logic, which gets emulated by this, like non-consensus state, like for example, the state of non-consensus CSFS, or like there's still a little bit of a state, that is like state, the signature you gotta check. It's your state. So you generalize this a little bit, and you result with what's called consensus verified meta protocols, which is, again, as I said, oxymoron, but the signature for the verification is verified by consensus. So it's, fair. I would be honestly also interested to know your opinions about this term, because we don't know how to call this stuff. So if anybody has something against it, please tell me. But that's kind of cool. That's kind of cool, because meta protocols, we expect that meta protocols could get a new spin, like a new life. Well, exactly because of it all, Bitcoin now can be used inside of those. So interesting to see what people will do with those. Yeah, no multi-sigs. Well, no multi-sigs is true. What haven't I said? Yeah, bridging all in one. Yeah, bridging, just in case, like just to be completely precise in here, when we're talking about bridging, like we're saying no bridging means no bridging to external state space. Like no bridging to external L2s, no bridging to external L1s, no bridging to external consensus. All stays on Bitcoin. Kind of, it's meta protocol, so come on. Yeah, so what's next? And maybe I will talk a little bit like kind of just myself about like what's the limitations, what is, you know, kind of, what's the limitations of, because it's witness encryption, so it's highly experimental. There are limitations to it. Yeah, so obviously kind of witness encryption itself implies that there is always a lot of security questions. There is always a lot of, you know, kind of, there is always a lot of like practicality questions. So, you know, we have, you know, kind of this, you know, the link to the paper, whatever, and you will find the, you will find the ADP witness encryption paper somewhere nearby as well, somewhere nearby the link as well. Is based off 6-year-old at this point ADP construction by Bartosek, Ishai, and many others. Well, stands unbroken for so many years, relies on assumptions which are, well, not the most commonly widespread, I would say, but, you know, we believe there might be a way to reduce them to at least something known in the literature. So that's the thing. The security is heuristic. We're doing a lot of cryptanalysis. A lot of cryptanalysis obviously implies, I mean, we're literally going around and like talking to people about this. A lot of cryptanalysis implies obviously open challenges, collaboration with like, you know, kind of all the willing parties. We will be doing open challenges. It will be announced that you're crypto enrolled this year. So if you want to take a spin on like cracking witness encryption and whatever, get yourself some Bitcoin out of it, please do it. Like reach out or like, you know, catch me somewhere. Performance, yes, obviously, again, it's witness encryption. So like the current construction we have published implies the ciphertext size of like 338 terabytes per key. But like, first of all, just want to say, come on, guys, all the other witness encryption stuff is like UB-bytes. You gotta have like a Dyson sphere to run them, right? It's just, you cannot do that. This one you can at least run. And this one you can at least kind of, you know, kind of just parallelize, and it takes about 50 CPUs to get that decrypted within 10 minutes. So you can actually decrypt it real time in comparison to like Bitcoin block time. We're working on a little bit of optimization, as this slide says. The optimizations will result probably, I mean, still not published, so we will. The optimizations we see might bring the ciphertext down to like whatever hundreds of gigabytes, maybe less. Trying to not overpromise here, but that will make it already a little bit more interesting, and batching is possible. So you can put more keys into one ciphertext than you can put more keys into one ciphertext than just one key. So if you want to like decrypt 128 keys out of a single ciphertext, also doable. So it's not like you got to run whatever terabytes of data just for the sake of, you know, kind of doing one covenant or something like this. It actually results into being pretty cheap once it's all optimized and implemented. Yeah, and of course we're working on the implementation. It's, you know, been a while, but we're still doing that, and you know, again, we'll keep you posted. What does it result to? What does this result into in terms of like the broader vision, the broader side, the broader stuff? I mean, obviously, besides just covenants and opcodes, et cetera, that gives you a lot of kind of improvements to the Lightning protocol, for example, when you always have these kind of, you know, issues with the liquidity fragmentation, effectively, with liquidity on the kind of on the recipient side. You gotta have like this state. You gotta have this payment channel exit liquidity and all that stuff, and vice versa. So it's all pretty messy. So having upvolt or like having some kind of vaulting mechanism would help that, which effectively pipes implement. We have a piece coming up about how upvolt or vaulting mechanisms can be implemented with pipes. So that's pretty fun. Peer-to-peer bridges would obviously benefit from pipes as well. I mean, like the absence of interactivity, the absence of operators, the absence of watchtowers, the absence of like liquidity collateral stuff. Again, explicitly saying there is a bunch of questions about probabilistic finality, but that's kind of everybody has that. It's it's a common problem for us. That's the thing. And yeah, well, as I said, meta protocols again. Tell me if you have something against the term consensus verified meta protocols, because formally it's correct, but it's kind of fun. Never had that before. Yeah, so I guess that's what it is. I try to keep it a little bit high level. If you want to talk about witness encryption and all that stuff in depth, catch me afterwards. We'll do a little bit of whiteboarding. Questions? No questions. Or yeah, okay, questions. Let's go for it.
Oh, this is super cool. I didn't know about any of this, so thank you for presenting. Can you walk me through an op vault example? And I'm specifically interested in what does data availability look like, and how long do you need to hold on to that data?
Okay, so let's talk about the op vault example. Well, the op vault, again, like the op vault itself, like the op vault, the BIP itself was introduced to like mitigate potential loss of key or like this kind of stuff, security issue, when you basically just kind of was trying to get people to be able to delay the malicious attacker or whatever, like the withdrawal from like something from some address, the key to which was lost. So that's the thing. I would say that in here it's all about that. Well, can you instantiate a vault with pipes? Yes, like absolutely. Can you lock some Bitcoin behind? Can you lock some Bitcoin like in the UTXO behind the key which nobody knows? Yes. So it's that thing. Now, how do you make people wait for? Now, how do you make people wait until well? How do you make this timeout? Like, how do you introduce a timeout? Well, you introduce a VDF2 circuit for the decryption, and you just make people wait for the decryption. So here goes your op vault. You get your delay. So that's pretty, that's kind of the most trivial, I would say, construction with this stuff. You just make the decryptor wait. Like even if something went south, that kind of gives you the op vault. Like again, if you want to we can catch after the talk. I'll just send you like a precise write-up we have about that. Like it's a little bit of a draft, but we will publish it anyway. So who cares? That's the thing. It's pretty fun. The second question was, oh, you got something about Vault? Just tell me.
Well, so Vault gives the spender the option to revoke the spend of sorts. How do you, if you just wait for the decryption, like that's a binary output that doesn't give the user optionality, does it? I don't understand how that works.
Oh, okay, yeah, that's true. That's true. So how do we introduce the revocability? We introduce the revocability somehow. Like again, as I said, we have a write-up about this. If you want to, I can show it to you. I just don't remember like out of my head right now how we introduce the revocability.
My other question was around data availability.
Yeah, data availability. You mean like for ciphertext?
Specifically the op vault example. So do you need this? You said there were like gigabytes of data.
Yeah.
To prove this.
Yeah.
Like who holds onto that, and for how long do you need to hold onto that?
Okay. So yeah. So basically ciphertext data availability. Yes, you're right. Cool. So formally speaking, the ideal scenario would have been if we were able to just store this somehow or like put this somehow onto Bitcoin itself. But that would have been honestly like the bad idea, honestly, because it's, even if ciphertexts were quite small, like, no thank you, Like one more spam discussion, I'm not ready for it. So that's the thing. What resulted effectively with like understanding pretty much the same level as, for example, this garbled circuits, garbling that VM people do. When you just gotta have that ciphertext somehow, like just populate it all over. You can store it anywhere. Like nothing harmless happens if you just write it on the wall. So as long as you have the ciphertext, you can decrypt the key. So it's kind of basically that. But like you should not hide it. It's not something you should like keep under your pillow or whatever. You can write it on the wall. So it's a little bit of that. It's like a black box you can just throw out and whatever. So until you want your key, it's better for the ciphertext somewhere to exist, at least somewhere. So that's that. Yeah, I mean, again, it's pretty much similar to what garbling people do a little bit. So, and there was a third question. What was that? Who holds on to those ciphertexts? Yeah. Well, I mean, obviously interested parties. Obviously anybody who would operate such a vault. I mean, who would operate a protocol employing pipes. Obviously, I would expect users, maybe depositors or somebody like this to hold it. It's pretty much similar, I guess, to how people hold the state of Bitcoin node itself. Like whoever wants the state to exist, whoever wants to, yeah. I bet there will be miners who will be interested to store it, like in storing this, because, well, decryption and all of that stuff might, with large demand, might get quite resource heavy. So probably miners will take on the part of that job. Again, it's similar to storing Bitcoin node state itself, I would say. It's like until you want the state to persist, just store it somewhere.
You mentioned there's some issues with like introspection if you were doing like vaults or other covenants with this technique. I know there was previous work on like zero knowledge light client proving validity of some UTXO and like ZK. Is that relevant at all for this setup or?
Yeah, okay, let's talk about that. Introspection opcodes. Well, introspection opcodes. Okay, just to be completely precise, we would benefit a lot, and the vault construction a lot would benefit from introspection opcodes, from like block hash opcode or like TX hash or something like that. Not TX hash, but like that's the block hash opcode, right? That was the thing. I don't think that's kind of happening, honestly. I mean, because yeah, there has been a discussion about trying to include this, but it's not happening. So, but if you prove the light client of all of it, can you emulate that with? Yeah, I mean there might be something. Like you might be able to provide like the last chain tip there, just to kind of understand that if this, but yeah, it doesn't save you from like the private fork attack though. It doesn't save you from private forks, and it doesn't save you from like this, probabilistic finality issues. But does it give you? Can it give you maybe certain form of introspection if you condition that on like the light client proof? Might be. Gotta look into that. Might be. Yeah, might be. Because we would benefit a lot from that, honestly. So yeah, it's a good idea. Maybe there might be something there. Yeah. Okay. So we're out of time. We're done. Okay. Cool. Perfect. Yeah, thanks.
Thank you, guys. We are going to take a quick 5-minute break, so go grab coffee, snack, and we will reconvene in about 5. Thank you.
Feeling pretty good. How about yourself? Huh? Okay. This one's not okay.
I mean, you can use this one?
Yeah, it's fine.
You sure? All right. Then you just, when you plug in, you will get a pop-up. Just click on the red button at the top left. Okay. Once you do full screen, they will be able to see it and they will pop up.
Yeah, it should be fine.
All right. So then, at the 20-minute mark, you will just raise a Bitcoin number that will let you know more or less that you have 5 more minutes and then finish. All right. Awesome. Thank you.
Test. Ooh. Yeah, this should pick up fine. Like.
Yep. Yeah. If you don't want to laugh, don't worry about it. When you plug this in, it'll get like a keyboard prompt.
Okay.
Just hit X out of that, and then make sure you're mirroring when you do plug in.
Got it.
Check that.
Just closing out of unrelated stuff. I guess they have that new presenter view thing. Allow or don't allow? Probably allow first.
Yeah, allow that, and then. Justin.
Okay.
I was just, yeah. Or if you just want to hop in, you can do that. Either way, whatever you'd like to do, man.
Did we end the break formally out there? Or?
Good? Yeah. I was just letting him know to call people in. Good. All right, now people are coming in. I'm just going to kick us off here. I still want you to yell that. All right, we'll shorten this up. All right, everybody. Thank you very much. Welcome back. We're jumping back in. Our next speaker is a man of legendary, if not accidental generosity. He has been intimately involved with the MIT Bitcoin Club in support, and also was one of the co-founders of the MIT Bitcoin project, which, if you don't know, is officially the world's most expensive college giveaway, where Jeremy got $100 in Bitcoin and gave it to every single MIT undergrad. And amazingly, he has not moved off into an island somewhere, but rather is continuing to contribute to the community, co-founding Judica, and now with Char Network. So, ladies and gentlemen, Jeremy Rubin.
Thank you very much. So today I want to talk to you all about the sequencer that we're building and give a rundown of some of the trade-offs of trust, control, and decentralization. So I think you've seen a lot of different presenters over the weekend, and I think it's more or less safe to say that Bitcoin layerization is happening. There's numerous developments. We've been hearing about it, obviously, now probably since like 2014 of Bitcoin's going to have layers. We saw Lightning, but now we're seeing a different beast of Bitcoin layers emerging, and it feels a little bit more tangible than theoretical. And I think that in the broader context, part of why we're seeing this is that there were really two roads that Bitcoin development seemed to be going down. The first road is the road to simplicity, where I remember first hearing about simplicity as like this is the future for Bitcoin in 2017 or something like that, where we're going to have we're going to invent a programming paradigm that's going to replace Bitcoin script and is going to be the most powerful, provable, best framework of all time, and here's the pathway that we're going to take to get there over the next several decades or something like that. And it turns out that nerds are cracked and have a lot of cool ideas and will exploit any surface that they can exploit. And so we've maybe gone down this other road, less traveled, where we figured out how, even without any changes, we're able to also extract computing paradigms and implement things that we'd like to implement against them. This is a lot weirder and more bizarre of a path because it's not how you would build it maybe from first principle, but we're building it nonetheless. And obviously many of the speakers you've heard here today have given different bits and pieces of, well, we could do this and we could do that. Now, across all of these things that are being wrought into existence out of the dark and spooky forest of tricks that we come up with, something that happens across the board is that coordination actually really matters. Bitcoin, fundamentally as proof of work mechanism, solves for this coordination problem by giving a work-hardened version of history. But when you're doing a protocol where you have participants who are able to freely come and go, and there is no authoritative record built, sometimes you run into difficulties, oftentimes you run into difficulties where the consistency of the protocol and how people participate can't really be guaranteed. And these sort of malleabilities or sequencing issues are sort of inherent, and that points to maybe there needing to be some additional consensus primitives that would be available to help build some of these other protocols. So the core example that we'll focus on, because it's one of the most potent ones that I think a lot of the community is focused on bringing into existence, is Validium rollups. This is a particular type of rollup. There's many types of rollup that people talk about, or layer 2, or different things, but this is a clean-cut example. So all this is Validium's like a fancy and cool sounding thing, but it's relatively simple. Is onto Bitcoin, you post a state diff, which is just some kind of list of transactions, and a proof, which is some list of transaction witnesses, and maybe you apply some compression on top of this. So maybe your diff is just a list of account balance updates, and your proof could be a ZK proof compressed down, maybe using Groth to just a few points that says, hey, I knew some arguments that would make this a valid state transition. Then, following that, you scan the chain for these bundles, and then you apply anything that validates against the last one that you validated. That's the first half of what a Validium is, and that gives you a consistent view using Bitcoin's proof of work of the state of some replicated state machine. The next side of it is, well, how do you get Bitcoin to and from that thing? This is where a lot of the effort has gone over the last couple of years with BitVM, is to build a framework that allows you to bridge back and forth between this roll-up environment and Bitcoin. And the way that those typically are working is that a bridge will optimistically process a withdrawal to a user, like an end user will say, I have $5 and I can prove it, and please give it to me here. And then later, the withdrawal provider can provide some kind of refund to themselves by saying, well, I did all these withdrawals, and now I should claim something from the bridge for that work. What I want to focus on in particular is pre-commits. And pre-commits are something that is where the coordination comes in. And instead of doing just a proof as a list of transactions in their witnesses, is that you actually break it up into bundles of transactions with bundle-wide commitments. And then breaking it up into that, you have sort of a lower latency experience, because rather than just waiting for something to get checkpointed on a Bitcoin block, which could take some amount of time, could sit in a mempool or something, you can have these pre-committed bundles that could sort of get aggregated up happen with much less than the layer 1 block rate latency. So you can have like sort of a real-time app experience, like a tap to pay, and you get a confirmation, and that's pretty cool. These have a number of other sort of benefits that show up. Another is like reorg tolerance. If you just have a commitment that goes on chain, but it can get by Bitcoin's proof of work unwound and reorged back and forth, then the transactions could be malleated underneath. But if you have a commitment architecture where you have these are attested to by some party, then just a reorg happening on the proof of work layer doesn't necessarily upset the underlying execution of those transactions. You get more reorg tolerance, which is also good for applications that want faster guarantees of finality. And then there's sort of a trade-off between the frequency of on-chain commitment and bigger batching. So the longer you wait for things that maybe cancel out, the more things that have the opportunity to cancel out. So waiting longer decreases data, but also you're posting less frequently. So that can also be a win. And without some sort of commitment or pre-commitment architecture, you really want to post as frequently as possible. But with pre-commitments, you can say, if I trust my pre-commitment to be good for, let's say, a week, then maybe I'm posting twice a week, and I'm living well within the safety bounds of that pre-commitment's validity window. So these are all benefits of pre-commits. I think that if you really don't like pre-commits and you say, well, I still want to post every block, they still give you a benefit because they still increase your reorg safety. So it's still a good idea, even if you don't necessarily like the idea of having any sort of faster than block latency. The main con is really, and this is like the million-dollar question, is who makes the pre-commits? Where are these actually coming from? So the simplest pre-commit architecture that you can use is just some random guy. And in the validation of a pre-commit, all you're checking is, did Bob sign off on this transaction bundle? And if it's signed, then it's good. Because it's a pre-commit, there's a bounded trust time, so you're only relying on Bob until you post the actual commitment. After that, it's guaranteed by Bitcoin proof of work. You can't forge an underlying transaction. So if I send some money to someone and Bob can't go and change who I'm sending the money to. So the underlying transactions are also still fine. But Bob can censor transactions, so that's not good. Bob could say, you're not allowed to send money to someone. And Bob can also insert transactions that benefit Bob. So at the end of the day, we kind of don't like Bob. And even if you say, well, what's the harm if my transactions can't be changed? Imagine that you're building like an EVM-like system, and you have something like Uniswap, where you can trade between two different assets. Then what Bob can do is Bob can see that the price of one of those assets in the trading pair you have is going down, and then see that you're requesting, please let me withdraw my liquidity. Bob can say, nope, you're going to market make this thing all the way to the bottom, and I'm going to trade against you the whole time. And so it'd be a little bit like playing blackjack against a dealer who can insert cards before they withdraw or draw their own hand, and they would always win. So the idea of a centralized single-party sequencer basically is an unbounded profit opportunity. The more complex sophisticated your layer 2 transaction is. So it's really a big problem if we don't have high quality, high trust Bobs that you're willing to work with. At Char, we're taking a different approach. Rather than trying to improve Bob, we're trying to get rid of Bob altogether. and we have built a native to Bitcoin proof of stake system. So it's not a pure proof of stake. It's not proof of stake backed by proof of stake. It's proof of stake on top of proof of work, so it still resolves ultimately to the proof of work network. It has an open membership staking committee. Anybody can just deposit on Bitcoin to a special formatted address that it gets picked up as a stake deposit. And if you equivocate or do like a bad action, basically for the consensus of the network, you lose your Bitcoin. So there's a very strong incentive or a very strong disincentive against doing malicious behavior that would lead to confused outcomes. So as soon as you see really a value that's finalized by this network, you can compute an exact amount of Bitcoin that would be able to be confiscated, basically released as a mining fee in the event that there were to be a different result ever certified. And in theory, if you think about, let's say Bitcoin gives you 6 blocks of confirmations and you think the transaction's good, you can also tabulate, okay, well, how much did the miners pay in electricity? How much reward did they get? And how much would it cost to bribe them to undo that? So you actually do end up getting a sort of similar guarantee to Bitcoin proof of work because you're getting a specific amount of how much would it cost to change this thing. And that's an amount represented in Bitcoin, and Bitcoin also fundamentally, at the end of the day, maps back to a thermodynamic, like you have to burn this much energy. So the security of it can be rather good. We presented on this before, so we're not going to fully go into all of the technical details, but I want to give an update on what's really fundamentally new here. So we're really close to our open source release. I know we've been in stealth and maybe mocked a little bit in the community for that. Part of the reason why we've been in stealth is not because we don't have anything to show, but rather because we don't really want to be in the business of making a bunch of like spurious claims of like, oh, we're going to solve this, and getting lots of marketing or whatever. I don't really have a use for that. When we're good enough in a space where we feel like we can make sound claims against what we're able to do, which is relatively soon, we'll release and people can see what we've been working on and evaluate it. So that will be hopefully sometime this month. We'll be able to share an open source release of our code. The other exciting, I'm seeing the engineers I work with in the audience getting very nervous. So yeah, you guys wear your laptops, you should be typing. So right now, recently we've also been working on revamping our consensus mechanism using eVRFs. I think that's something of interest for this audience as well. It's pretty cool, so I'm going to give some details on that and how that's impacted since we last presented on this, our consensus protocol. So if you're not familiar with a VRF, it's a verifiable random function. An eVRF is an exponent verifiable random function. So the classic VRF is basically a hash function, which is V, keyed to Alice's pub key, that Alice can produce a proof for. So for example, Alice can make the hash of banana, and they get a commitment, like a normal hash. But in order to verify that commitment, you also get a proof. So in a normal hash function, the proof is the preimage. If you want to check the hash, you hash the preimage, and then you know that the commitment was the commitment. But in a VRF, you actually can't publicly reevaluate that. It gets split in half. So there's a proof that you can check to check that this string, C banana, was actually Alice's hash of banana. And that's the only way to do it. And learning Alice's banana and Alice's proof of banana does not give you the ability to compute Alice's value for orange or for apple. So that's a VRF in the sort of classic context. Importantly, this commitment banana has no real relevant structure. It's just a random bit string. And it is not really actually that useful. I mean, it's useful. People use these for like really great and fantastic things. But it's a public parameter. So everybody learns this result. It can't be used as a secret. eVRFs are maybe a relatively recent addition to what you can do with a VRF. And what that allows is for the result to be a curve point where Alice knows the secret key and the proof is against the public key. So what this lets you do is it lets you publish a verifiable hash onto a curve where Alice is able to do like a signing operation against that point. We have an implementation of eVRF, which independent of char is of interest and has a lot of great use cases. So this is called Purify, It's originally specified in the MUSIG DN deterministic nonce paper. It should be fully compatible with SecP 256K1. There aren't really like many exotic crypto assumptions. So some VRF schemes, maybe you're assuming pairing or something, and people don't necessarily like that. This is a relatively benign set of assumptions. It's the same as a normal signature. Unfortunately, Purify was kind of forgotten about. It doesn't have any kind of production implementation. Our implementation is based on adapting a bunch of research code. And hopefully we fix that. It's obviously rule number 1, don't roll your own crypto. But we've tried to do a good job with it and make it secure. So it also has some formal assurances of correctness that we're going to look to upstream as well to SecP itself, because they're also of independent intrigue. But it does need review. So if you're interested in crypto libraries, this is kind of a cool one to check out. It has a lot of use cases. That's why it's not just something that helps us. You can use it for MUSIG DN, which solves some of the challenges with using MUSIG in multi-party contexts. It's also really useful for hardware wallets, because if you have a hardware wallet, one of the main risks is that it could generate the nonces in a biased way and secretly leak out bits of your key. And this actually completely prevents that. If you use this type of seed, it's impossible to, or if you use this type of signing algorithm and export these proofs, it would be impossible for an evil hardware signing device to exfiltrate your key by signing something you requested. So that's kind of cool. And classically in the literature, this is used for sort of like leadership election or unbiased will protocols. This is also still usable for that. And we use it in particular for proof of stake equivocation contracts. And so I'll get into that now. This is a slide from our old protocol implementation. And one of the things that without EVRFs we had to do was we have to create cryptographic nonces. Now a nonce is exactly a curve point that the signer knows the secret key for, or the discrete log of, to be more formal and precise. And for every message that gets signed by our staking network, we have to have a pre-registered nonce somewhere, because we need to tell the network, this is the nonce I'm going to use. And so what that led to is a design where across all history, you have to chain all previously signed messages together. And so this basically means that if you're doing some sort of sync, you have to download all previous messages to know that there hasn't been an equivocation. So that's a like O of n history download just to get this property, which is not great, but it's something that we more or less have to do. You have to register these nonces somewhere. But then, so just to complete the protocol, you can take an equivocation on that chain, which is seen at height n+2, and you can plug in the relevant details, and then it either leaks their key out. This is a classic Schnorr nonce reuse attack. You can use it as a gadget, and then you can use that for like a collateralized contract. Now, in our new protocol, anytime you see two messages that are at the same index, I, they end up using the same EVRF of I, which is the exact same proof, the exact same nonce, and you get a signature of two different messages against the same nonce, which then allows you to, in the same way, extract. And so this basically, as you can see, like the difference between this version, where you have to track all the history throughout time from for all future and past. This actually gives you a relatively like stateless ability to detect punishments, which is a huge improvement against the like prior status quo. Dramatically simpler protocol. And these simpler protocols actually, it's not just that it's easier to implement like a node that validates these, but for the BitVM context that people are building bridges, they need to be able to ingest this data as well. And this makes the proofs that they produce over these certificates of consensus much simpler, because they don't have to have a historical data dependency either. Any knowledge of an attestation claiming to be for a certain index it has a bounded amount of history that it needs, the bounded being O of 1. Yeah, it just ends up with a more scalable system. Now, as sort of like just like a last topic in sort of some of the principles that we've been applying as we've been engineering this is we're really trying to not hide any trusted party in our stack. We're trying to build the simplest possible version of Bitcoin layer 1 proof of stake consensus, such that we preserve some of the really necessary properties. Because sometimes if you try to fake these properties because it's nicer to do it on paper, or you say that on the happy path we're going to add features to Bitcoin, you end up not getting them. And it's better to maybe just make the best of what you have available. So I'll just give a quick example is covenant emulation, which is a useful thing in some contexts. You can use it to pretend you have more advanced scripting functionalities than you actually have if you have a trusted party. And sometimes this is used in Bitcoin proof of stake systems to stake slashing and unstaking operations and make them work nicer. But when it's embedded inside of consensus that you have a federation, what that means is that you really don't have an open membership network. And an open membership network is actually the thing that makes something like this able to prevent hostile takeovers. If the federation decides, hey, no new stake allowed except for the ones that we own, then in a very short amount of time, they'll own the whole network. And so adding a trusted intermediary in any part of that, especially for layer 2s that want to use this as bedrock fundamental infrastructure, is definitely inappropriate, even if there are other trade-offs to make as a result. And the trade-off that we make is that without a covenant emulator, we're stuck with fixed duration staking. So stakes have to be rolled on some frequency, and maybe you stake for a month and you're stuck for a month, or maybe you stake for a year and you're stuck for a year staking, versus a more flexible thing that could allow you to unstake at any time with a delay. And punishment is maybe a little bit weaker. With covenants, you can enforce the punishment conditions are more likely to lead to your funds getting slashed. But it's not always a clear drawback when you have a drawback. On the upside is that if you have a fixed duration for staking, you have a better protocol predictability horizon. If you can look out over the next 6 months and see exactly how much stake is going to be still available, that's better than saying, well, in a week it could all be gone, which other systems make that trade-off where you don't know week over week if the stake network will be there at all. So it's maybe a little bit better for like planning if people are able to target longer term horizons. And I think at the end of the day, for something like punishment, even though it would be great to say the expected value of doing a cheating action is always clearly very negative, even in light of some amount of collusion, ultimately the punishment itself is still always relatively probabilistic, even probabilistic against like maybe the price of Bitcoin just goes down. And so I think that well, the expected value of punishment matters in theory. The max punishment, especially in zero-sum repeated games, where at the end of the day, if you have Bitcoin slashed, you may never be able to recover that Bitcoin again because there's not new Bitcoin getting minted. That can actually dominate over the short term. Like maybe at a certain point in time, punishment is a little bit less probable. If you ever lose Bitcoin, you may never be able to get that Bitcoin back again because somebody else will have it, they may not sell it. And so in a deflationary system, these risks are actually a lot higher than in an inflationary one. So I'll wrap there because I know I maybe have a little bit of time for questions. I'll just sort of end with a plug of, we're getting this network out and getting it open source, and we're really looking forward to being able to bring in more contributors. So if you're interested and think these problems are fun to work on, definitely drop us a line. We're based in Miami, but for special people, we'll consider other arrangements. Thank you.
So I have two questions. One is there a separation between, like in Ethereum, they call it the proposer and the builder, right? In Char, so like I guess the sequencers, are they both sequencing the order of the transactions and performing the submission? Can these be separated? And then my second question is, so if an entity that is performing the sequencing equivocates, it can be slashed, but what happens if they just do not submit whatsoever? They just do nothing?
Yeah, so two good questions. I'll repeat them just so I don't forget them. So the first question was, can you remind me real quick?
The difference between like the proposer and
the
builder?
So for proposer builder separation, for Char, our goal is to be kind of like a dumb pipe of committed sequenced data. and the actual transaction ordering, if there is a requirement of that in the system, should be handled natively by an application running it. So there are multiple architectures that you can do around that. One would be to have a secondary, like per application sequencing set. You could rotate those out or have some other mechanism there. The other is if your transactions are like more UTXO based, there's maybe not as strong of a need for it to be sequenced in that way, and you can use it more like a mempool transaction selection.
Okay, and then the second question was like, what happens if the party they're not equivocating, they're just not doing anything?
Yeah. So if you don't have, if somebody is not sequencing for your application at all, and you're not seeing any progress, you would see, I guess this is also at a high level for people who are maybe approaching some of these things for the first time, is largely for these systems, there are fundamental impossibility results that you can't really do better than. So you want to, there's some great papers by a lot of MIT professors actually on these topics, but inherently you need like a 2/3 majority, consensus for these systems. That has an implication that like 1/3 can block progress if they withhold. In our system, the main mitigation against that is that we're not a static configuration. So if the network becomes unlive, you can have an outage. What you can do as an alternative to that is you can add more stake. Now, another important aspect of how our protocol works is that, and I'm not advocating for this necessarily directly or implementing this as a feature, but we are trying to be dumb pipe with regards to it. One thing that an application can also do is it can have these applications themselves process the certificates. They could use a certificate weighting algorithm to like discard stakers that they think are bad to lower the threshold by ignoring certain stakers. But we're not baking that into our base layer, if that makes sense. You would be free to select a subcommittee of our network and say that we're working just with this stake, but then what other stakers are doing wouldn't necessarily impact your consensus anymore. So you could break global consensus if you're looking at the global consensus, but for your app, it wouldn't matter if you've done some sort of filtering. So an example of something you might do would be to say, if it's okay that I semi-dox you, you work for Alpin, you might say, look, we are going to apply a 10x, maybe not 10x, but like a 5x premium on Alpin's staked bonds, and these count 5x more for consensus when we're looking at our proofs. In the result that, we also sign explicitly that we're not seeing liveness. So that would be a way that you could, at the app level, but not in the char layer directly, you could express some biasing to allow for a liveness recovery, but we don't handle it natively. I see. Makes sense.
Okay, thank you.
Anyone else? All right, thank you very much.
Thanks. No, thank you.
What are we waiting for? Starting 5 minutes late, yeah. Okay, amazing.
Oh, we're ready? No.
Yeah, we're slightly late, but yeah. Cool.
All right, thank you guys. Definitely looking forward to reading that paper, Jeremy. Thank you. And we will move quickly for the sake of time. And next up, we are having Clara moderate a panel on quantum. And so despite Nick Carter's adversarial work in saying that nothing is going on, I believe we're going to have a discussion here and take a look at what is going on behind the scenes. So thank you, guys.
So, hi everybody. As a person that was saying nothing is really happening in quantum, a few things did happen, but I'll let the panelists tell us a bit about this. So let's start with you guys just introducing yourself and telling us one interesting thing you're working on.
Sure, okay. I'll go first. So I'm Misha and I build quantum computers at Quera Computing. This is a neutral computing company. Before that, I founded Super Quantum and now serve as the technical advisor. And Super Quantum tries to merge together quantum and blockchain and help the development of quantum computers.
Hey everyone, I'm Alex. I'm the CEO of Project 11. Project 11 is a company that focuses on researching, designing, and implementing post-quantum cryptography for decentralized protocols, and then helping infrastructure providers that rely on those protocols integrate that cryptography as well.
Hi, I'm Ethan Heilman. I'm a cryptographer who's been doing some work on Bitcoin's post-quantum cryptography. I'm one of the co-authors of the BIP360 pay-to-Merkle route, and I've also been looking at post-quantum signatures and trying to map out a plan for how we move to a quantum-safe Bitcoin.
Okay, cool. So we have that. Let's just dig in. What, in your view, is the most realistic risk for Bitcoin? Maybe not the biggest or so on. What is the realistic risk when it comes to quantum that is looming above Bitcoin?
I think it's probably all of you know. It's related to breaking at least starting from like elliptic curve cryptography.
Yeah, I mean, maybe what I would say to add on to that is, so it breaks the fundamental, these cryptographic guarantees of this public key cryptography that Bitcoin relies upon. And kind of philosophically, what that means is, ownership in the Bitcoin network is really conferred by this ability, the unique ability of whoever has the private key. Only they should be able to produce a signature in a world where a quantum computer that is cryptographically relevant exists. That entity could produce potentially signatures for anyone with an exposed public key. And so there's a philosophical question of who owns the digital assets. I think kind of goes to the very heart of Bitcoin. Bitcoin was obviously designed to be self-sovereign in opposition to the existing financial system. And I think that's really the dagger at the heart here. I guess I would say, in my view, so that's the biggest technical risk. I think the biggest realistic risk is the reverse bystander problem, where everyone looks at everyone else assumes that progress is being done. I think there is certainly things that are being done. These guys are working on stuff, but I think in general there are too many, specifically very large stakeholders who have a lot of skin in the game, that are too content to sit on the sidelines and wait. And in my view, the risk is that it's potentially too late, because once a quantum computer is out there, then it makes life a lot more difficult if you want to migrate a system like Bitcoin.
Yeah, I just want to add to that idea that because quantum computers represent a threat to Bitcoin's digital signatures, if we prepare for it and have post-quantum recovery paths, it shouldn't be that bad, and I'm very optimistic we'll get to that. But if in the low probability event we do nothing, and then the signature algorithms are broken, it's really, really hard to do anything meaningful after that fact. It's like everyone owns everyone's Bitcoin. Enormous number of the coins are just like stolen, but even from like the thief's perspective, they like steal the coins and then someone just steals them from them. It really strikes at the heart of the value of what Bitcoin provides, which is the ability to like own and transfer coins. And it could deeply, deeply undermine that ownership. I think an additional risk is that that miners might be incentivized not to mine transactions that are stolen, that they perceive to be stolen by a quantum computer, because they think they might get a quantum computer later and then they might want to steal them. So I think there also are these incentive problems with the protocol, if we were not to prepare for this. There are incentive problems. No one can predict what miners will do in that situation, but that also does keep me up at night. But I do think we're going to solve this problem, and I think that there's some pretty reasonable solutions out there.
Maybe I can add some disclaimer. So I see like in general in this community, like quantum computing is seen as like a major threat. But overall, I think any new technology brings like its pros and cons. So from my perspective, quantum is good overall, but we need to upgrade, review like the previous protocols to keep up with the technology so it's not abused. And I think that's what we're here to solve this problem, or at least do like the first steps.
So I want to dig in for a second into the optimistic path or the pessimistic path. So just on a scale of 1 to 10, how optimistic are you that Bitcoin will be able to weather Q-Day whenever it comes? And then if you could explain why are you very optimistic or very pessimistic? And we can start, from time to time, we'll switch things up and do it the other way around. So let's start with Ethan.
Sure. So I would say that I'm, with 10 being the most optimistic, I'm like 9.9. I do think that when Q-Day comes out, there will be a bunch of problems. There will be conceivably coins that have not upgraded, and there may be a soft fork that someone proposes to freeze those coins. That might be contentious. So I don't want to say that Q-Day will just be like easy sailing, but I am optimistic that we will do the work to prepare for this, and that when it occurs, there will obviously be problems, but Bitcoin will weather the storm.
Yeah, I think I am a 10 out of 10 that Bitcoin in some form will survive. I think the question is, how chaotic that transition is. And I'm maybe a 5 out of 10 that it will, maybe even a 3 out of 10, that it will be smooth on the current trajectory that we have. I mean, these digital signature algorithms are baked so deeply into this protocol. The dependencies on them are very widespread that any effort to change the system, which is, like I said, there are undergoing efforts, I mean, it is just going to be long and, it needs to be long and rigorous. I think, the best example of a protocol upgrade I can think of in recent history involving Bitcoin was Taproot. I think Taproot, in terms of its controversy, was relatively low. Obviously, it did add a whole bunch of new cryptography, so that was complex, but that took 4 years. There was no issue. There was no need for people to kind of migrate existing assets. So, I think if you look at that as a lower bound, and then you start looking at when a quantum computer might realistically appear on the scene, I think, within 5 years seems unlikely, but I don't think you can necessarily rule it out, and you certainly can't within 10, I don't think. And so, should we reach consensus before that point, then I think there's just a risk that there's quite a chaotic transition.
Yeah, I'm also positive in general that Bitcoin and other established like cryptocurrencies should sustain. First of all, so far you can already see who are like the main players in the quantum machine building. So it's not going to come out of nowhere. So the progress is kind of being tracked. And then in order to build a quantum computer of the scale, which was, for example, covered by the Google paper or the Oratomic paper, it requires a lot of energy, a lot of equipment. I would say it takes the world to build this quantum computer. Sometimes I would even compare it to these more sophisticated ASML machines. So it's not like, it's not going to be unnoticed. And then even when it starts appearing, sure, there will be like some hype from these big companies, maybe like, I don't know. Then there is questions on like a legislation side. Like, sure, they can open some of the wallets, but then is it just like a crime, or what do we do with it? Like digital asset salvage. So that needs to be decided as well. But overall, and you could also see like from the papers, once the quantum computers would start scaling up to like tens of thousands of qubits, they would say like estimate would be for like neutral atom computers, for example, it's going to take something like a year or like several years. So they need to kind of move forward. Yeah, and it's not only just about the number of qubits. There are like a lot of other parameters which needs to be taken into account, like number of gates, especially, which are difficult to make, the error correcting codes, how they implement it, how fast you can do that, the decoding. So there's like a whole stack which needs to be taken into account. And overall, I think it's good. I hope that there shouldn't be a panic, but it's good to be aware that we have these tools.
That's great. It's maybe not surprising that the three people sitting with me here are the optimistic bunch. I would just to test the temperature, if they're all in the 9 and 10 on the optimism, is anybody sitting here feels below 7? Okay, we have below 7. Below 5? Okay. So we'll have a Q&A portion. I would really, really love to hear a bit more on the pessimistic side, because I think it is a notion that exists, but I'm also optimistic. So I'll let the Q&A people bring that viewpoint. We talked about migration, and so you're optimistic about the existence of the solution, but how do you envision this big change in Bitcoin, the migration of UTXOs, all the works around it concerning people that have their private keys are considered lost, just people being lazy and waiting for the last minute? How will this process look like?
Should I start this one?
Yeah.
Yeah. Look, so I consider myself less of a theorist and more of a practitioner, and I think, I mean, in this area specifically, I think there are theoretical solutions to how to make migration easier or how to enable migration after Q-Day, potentially using zero-knowledge proofs or other things. I would just say that this is an aspect of this overall complex problem that theory alone is not sufficient in solving. Like, these things have to get built. Like, so, you know, it's like migration pathways. Even if you're doing it before Q-Day, you have to have, you know, basically some pathway to migrate to a new UTXO, and you need to make sure all that cryptography is audited and secured, and you need to make sure wallets support whatever interface that you're going to be using and with whatever signature algorithm you choose. So there's just a lot that goes into implementing these systems even once we come up with them. And so this is actually, you know, I'm very happy to see a lot of interesting research being done by Blockstream and others. I think recently there was a paper by Starkware that was very, I would say, creative in the approach of a potential migration strategy using some kind of older techniques. But you know, it's one thing to write it in a paper. It's another thing to actually implement it in practice. And there have been numerous times in Bitcoin's history and in cryptography where something that was theoretically possible turned out to be impractical. And so I think, for me, that is the primary consideration with migration, is that it is dependent on all of this cryptography that's kind of going on underneath the protocol level, which is one more reason to move as fast as we possibly think we can on that, and to prioritize that above every other issue in the Bitcoin network, to ensure that, you know, we actually are able to get the full suite of you know, post-quantum readiness you know, tasks done in time.
So how far, you described the process in lots of steps. How far down the process are we, do you think?
My view is the beginning. I think I would describe everything at this point as research. And research is great, but even after you select research, once research ends, things need to be engineered, then they need to be rigorously tested in multiple settings. And then again, every dependency on top of wherever that is implemented, you know, if you're implementing this in the protocol, every dependency on top, think about, just to make it tangible, every Bitcoin wallet, every institution that supports Bitcoin, ETF holders have to figure out what they're doing, and then individuals who are, you know, ledgers. Let me just take one very, very specific example. If you hold your Bitcoin on a ledger, and it's an older ledger, depending on the signature algorithm that's ultimately chosen to be post-quantum secure, your ledger might simply not have the resources on it to be able to sign a message. So you just literally have to throw that ledger away and buy a new ledger, right? So I think that the throwing away the ledger is a good way to think about this. I mean, this is a very fundamental change, and the change is potentially very big in terms of the difference from existing ECSA signatures. So I think we're at the very beginning of this process, personally.
Yeah, Ethan, I think
I wanted to add a little bit to this because almost all problems end up being usability problems, and you have to have like a lot of compassion and understanding for the user, and I think that will be the hardest part. So in my head, I always have this argument when I'm thinking about how to design this, where there is someone who believes that in like 3 years there will be a 1% chance their funds are stolen with a quantum computer, but 99% chance that there won't. And how do you design a system that they can adopt to protect themselves today, which is so, which is like usable and does not incur any real significant costs on them, such that they're like, okay, I'm cool with that like 1%. Like if you're Coinbase, that 1%, okay, they'll do a lot of usability stuff because there's such a massive cost of loss. But like, you know, someone that has like half a Bitcoin, it's like, well, are they gonna like how much work are they gonna do? If they're paying like 10 times as much in fees and a quantum computer hasn't arrived yet, are they gonna adopt that transaction output? Probably not. So I think a really important thing of this is how to get people to adopt something which has like a quantum safe recovery path so they can switch to using quantum safety, but they're hedging their risk and they don't actually incur any cost until Q-Day happens. And I think winning that argument with like the 1% risk, a small holder, is really important when thinking about this design space.
Yeah. So again, my background is more on the quantum computing side, but I think it was very valuable yesterday, especially like talking to some of the guys who are deep in Bitcoin, just to get a better understanding, because before I was like, oh, I mean, you have to keep up the technologies. You know, we have Moore's law, the network's capacity increases every year, the compute power increases. You have to somehow keep up with that. I mean, sure, there was like the protocols, like since Satoshi's time, I assume there was like some upgrades, but we need to keep up with the computers, computer development. But then I realized that even changing the block size, there was a big issue, right?
There's a whole book and everything.
Yeah, so I think for Bitcoin, it seems like in general, they need to come up with a solution how to integrate this new upgrade so that the system, I understand that it was designed not to be changed, but still, like we need to do the changes because otherwise it will ultimately become obsolete like in 100 years or so, for sure. But in the short term, I think it's like I would say like for myself, don't put all eggs into one basket, so kind of distribute it into multiple wallets. If sure, for quantum computer, it's going to take a while to break one of them. It may take something, but you still have all the other wallets. And then exposing the public key. So are there any ways to kind of protect or exposing the public keys? I know some of the inactive wallets have been already exposed, which there need to be a consensus done. Okay, what do we do with those kind of dead wallets or not used wallets? And I understand there is like private mempools direction, like so you can send it to miners but not exposing to the network. Anyway, it's probably a question for you guys. What could be done in the near term?
I'm trying to keep neutrality. So
I see.
Yes, there is. Yeah. You know what? Let's get into concrete things. So let's jump a bit into the process and the progress you're expecting to see in the next like 3 to let's say 5 years in quantum computing and Bitcoin readiness, and what things we might be worried about, like trends or ideas that we like more or like less. What do you expect to see and what do you hope to see in the next, let's say, 3 years on this front?
Okay. So for quantum computing side, there's a clear path for fault-tolerant quantum computing and how to scale it up. So you could see the papers from Google, from or Atomic, not like advertising them specifically, but at least there are some papers in the air that there is a plan. Like each company has its own plan how to scale it up, publicize it or not. But anyway, so the state of the art, based on the publications, is that it has been demonstrated that we can do a single logical qubit So the main fight in the quantum computing industry was like, can we fight the error rates? And there are two sides. On one side, you can use redundancy, like you cannot just take one atom or one superconducting element and run the computations on them because they can get errors pretty quickly comparing to the classical hardware. Then the solution is like, we can use the redundancy, sure, but then for leverage this redundancy, we need to have the physical error rates really low. Otherwise, the errors will just spread faster in this group. So anyway, that milestone has been demonstrated. Next is, okay, how do we scale up from a single logical qubit to more of them? How do we build the whole architecture where there is like a processing area, there's a storage area. Here we produce, do like the Clifford gates, like non-Clifford gates, which are very expensive. So there's a lot of tune-ups which are going to happen, a lot of engineering decisions. So I think that's what we foresee in the coming 5 to 10 years, what's going to happen. And I mean, I'm sure there will be also interesting like surprises, scientific discoveries, but overall, that's kind of the main trend.
I guess for the two of you is what Bitcoin is going to do about all of this.
So actually, I'll give my version a little bit of how I view quantum development quickly, and then I'll talk about Bitcoin, and I think an aspect not a lot of people are considering. So I'm not a physicist, and so I kind of have a framework that I'll share with you guys for how I kind of think about it. Hopefully it may be useful. Demonstrating exponential suppression of errors, demonstrating this thing called the threshold theorem is what kind of enables you to realize something called a logical qubit. And so that has been realized in an instant, effectively. So you have a logical qubit that's been realized in kind of a moment in time. The next milestone is to effectively have continuous operation of said logical qubit, right? So you got to do more than just like show it can be made. It has to be made and then maintained, right? Because Shor's algorithm, this thing that you're going to run, has to last for whatever depth, right? Depending on your choice of architecture. So you've got one, now you've got to make the thing run as far as you need it to run, and then it's a question of, by the way, so that's kind of where I think the field is currently, is my view, is the field is basically, it's like we've demonstrated we can make a logical qubit, now can we continuously operate it? Then the next question is, how do you scale up those qubits in terms of you need them, enough of them in terms of being able to handle whatever the hardest step in the computation, you need to have enough logical qubits to do that. And then all of those logical qubits need to just stay together and run together all the way to the end of the computation. So those are kind of the 4 steps. Once you're there, you have enough logical qubits that can run the full computation. That's SKU-day. You're there, right? So we're definitely not there, right? So just again, in case anyone missed the upshot of the papers last week, there is no quantum computer today, okay? But it's a question of how quickly we can run up this curve. I think the one thing that I would maybe say, and then I'll let Ethan comment on the preparation piece, but the one thing I would say with regard to quantum computing is I maybe disagree somewhat that progress will be public. It's possible, but I think it's also possible that not all progress is made public. I think notably in Google's paper, they did not publish the circuit that they were using. They actually published the zero-knowledge proof of the circuit explicitly because they were concerned that someone with that knowledge, without the best of intentions, might win the race to building a fault-tolerant quantum computer and then do things with it that they wouldn't approve of. And look, the closer you get to the point of cryptographic relevance, I think there will be greater and greater pressure potentially upon the physicist community to not necessarily reveal the latest and greatest. It is possible that research may still get published, but I just don't know that we can count on it. I'll let you talk about the preparation piece.
So I very much agree with the idea that we may not get all the warnings. The Google paper and some of the recent papers may be the final warnings. Maybe there'll be some more, but it seems like the closer we get to the date of Q-Day, the more the incentives create a picture of people playing their cards close to the chest. So I think we shouldn't bet on having a series of warnings all the way up to Q-Day. Maybe we'll get that. I would like that, but I don't think we can count on it. In terms of progress that's being made, there's a number of people that are looking at this problem in Bitcoin. I can speak to some of the work that I've been involved with. We spend a lot of time thinking about how to make a painless way of adopting, of moving your coins to a Bitcoin output that could have a quantum spend, but could just be spent like regular, like a regular transaction. The first part of that was pay to Merkle root, or BIP 360. I know there's several groups now working on looking at how to put a post-quantum checksig opcode so we can get post-quantum signatures. This is my pay to Merkle root with a post-quantum opcode is my preferred route of doing this. And I think one of the advantages is that if people were to start using these if these transactions were activated and people were to start using them, and wallets were to start enforcing no Schnorr key reuse, at a cost of maybe about 11% larger transactions, those outputs that started using that would be like quantum safe because they could, after Q-Day, be spent in a quantum safe manner.
Very cool. So with this overview of the future and so on, whether we'll know that a quantum computer is here or we won't, it's very clear that Bitcoin will need to make some very serious decisions. So what do you think is going to be the hardest decision to make as a community?
That's an excellent question. I'm probably in the minority in this view, but I think that the consensus changes to add something like post-quantum signatures and pay to Merkle root are actually going to be the least contentious. I think the most contentious is likely to be questions over freezing quantum vulnerable coins. And the reason for this is that every time I talk about post-quantum signatures, which you need in the freeze world and you also need in the non-freeze world, it almost always turns into a debate between the freeze side and the non-freeze sides. So I have strategically not have an opinion on either one of those, but just going by how talks often turn into two camps there, that's the biggest that for me is what I think will likely be the most contentious, because even if we go down one path, there will be the people that didn't want to go down that path that regret it. I offer no solutions there, but I think Bitcoin will survive that contention.
I mean, the Satoshi coins question is a great one for, it's like, having a beer or having a coffee and debating with someone about what you think. I mean, that's like just classic parlor discussion, but it will be very controversial for sure. And, I think everyone probably has an opinion. And I guess the reason it's hard is because there's sort of two different ways that are not mutually compatible. Like one way is like, Bitcoin is digital gold and it should, the supply of digital gold should be kind of inviolable. And, if the supply isn't really going to change. On the other hand, you have this concept of property rights. And hey, any individual should not have their funds confiscated by any other individual, right? And so this is kind of like what to do with the lost or stolen coins kind of gets to this. I would say though, for me, look, the biggest risk in my opinion is being able to arrive as a community on a consensus that something needs to be urgently done. And in my opinion, other priorities probably need to be reevaluated in light of this work. I mean, I'll just give an example. I was at a meetup yesterday at the Presidio Bitcoin office, and there's talk about, doing work around cluster mempool optimizations. Look, in a world where you're putting in post-quantum signatures, you're gonna have to redesign the whole mempool anyway, right? There's a lot of protocols, like some of them have presented up here, that use various aspects of elliptic curve cryptography. I mean, that is probably gonna be obsolete. So I think it's, for me, I think it's just how quickly can the community at large and all of its biggest stakeholders come together and, maybe this is like a little bit of an exaggeration, but not much of one. It's like a Project Hail Mary. Let's all focus on this biggest and most existential issue and try and solve it to make sure Bitcoin can exist into the future beyond Q-Day, getting urgency around getting to that point, I see as the biggest challenge, because there's been a lot of pushback in dialogue around whether or not quantum computing even exists, whether or not it can ever be possible. And look, there are real questions about whether or not you can scale a quantum computer, but I just don't think anyone has the definitive answer that you can't. And so to me, it feels very risky and actually antithetical to Bitcoin's conservative security ethos to just pretend like we know better. And so I think the urgency among the community to come together to solve this problem is actually, to me, I think the biggest challenge.
Yeah. Overall, yeah, I don't see like any fundamental physics limiting not building a quantum computer. So earlier or later, it's going to happen. So I think in general, the actions needs to be taken to do something. I don't know. Maybe I have like a crazy idea that maybe like Bitcoin community has also like plenty of the resources. Maybe there is a way to start building some decentralized quantum computers. In addition to just having only like a few parties having hands on them.
Future Bitmain founder right here.
Yeah.
Bitmain V2 is quantum miner. Pre-order now. No, we should.
So before they head out and start a new company for decentralized quantum computers, I'll ask one more question, but then we'll open to a Q&A. So have your thoughts out there if you want to. But on my end, I think my last question is, what is one concrete action you think that Bitcoin developers or holders or whoever they are can do and should do in the next year?
I'll start. Have an opinion. Have an opinion. Think about these issues. They're hard issues. And this is a community of, like, we pride ourselves on the fact that this is a decentralized community, but decentralization doesn't absolve any individual from being a stakeholder. So I think learn about this issue, understand it, have an opinion one way or the other around a migration timeline, about what to do with Satoshi's coins, and I think advocate in whatever form is appropriate for you for what you believe. That to me would be what I would say for everyone in this room.
I would advocate a openness to some of these existential risks. I know they're quite frightening. One of the ways that that I became involved in this process was I was saying, and I used to say to people like, well, if the digital signatures in Bitcoin are broken, like Bitcoin's over, and then I would that would terminate my thought on that. I'd be like, so I don't have to think about that problem because it's over for Bitcoin. So good, I can move that to the problems I'm not going to work on. And then one day I heard myself say that, and I felt like a sense of sadness, and I was like, that should actually be a problem that I do work on. How do we ensure that if Bitcoin's signature algorithm is broken, either classically or with a quantum computer, that Bitcoin survives? And so that was a bit of a change in perspective for me. And I'm not saying everyone has to have that change of perspective, but I think that openness to, if Bitcoin is going to be around in 100 years, maybe a quantum computer is actually farther off than most people think. But if you think Bitcoin is a good thing for the world, and if people are using this as a savings account, they should care about Bitcoin being around in 100 years, and the sort of thoughts that one has about that. How do you overcome these existential risks and build additional resilience and redundancy into Bitcoin, I think are really worthwhile. So I think I would just advocate for a openness to thinking about some of these more doomy questions so that we can find solutions. And I'm a big believer in solutions being able to be found.
Yeah, I mean, I concur. I would just add, I see the fundamental challenge is how to make Bitcoin evolvable, if it's possible. I don't know. It's like a philosophical question.
Okay, that's very cool. I think we have a few minutes for questions. I would especially love to hear a bit more from the pessimistic people in the audience. Although, yeah.
1 in 1,000, 1 in 100, black swan event. When do you think that's going to be coming?
Are you talking about for like Q Day? Like
Yeah,
when? Okay,
yeah.
yeah. But this is always the question. You try and talk around and avoid giving dates, and then everybody's like, well, actually, though, when? Look, I will answer tangibly, but let me just first add this intangible qualifier. There's a lot of uncertainty, okay? So I'll give you my estimate and why I believe it. I think it's at even chances that a quantum computer arrives by 2034. I think I arrive at that conclusion because A, there are expert surveys out there of cryptographers and physicists that say about that many of them think that it's within 10 years. 40%, I think, is the number. You can look at the roadmaps that are published of the various companies that obviously skew much more bullish. Some of those point to the early 2030s of being at the scale at which this would be cryptographically possible. And then I think you can do some napkin math and basically assume some level of improvement on qubit fidelity, some level of improvement on error correction, some level of improvement on the basically overhead and the resources required, and you can just do some napkin math and plug in your own assumptions, and I think you kind of end up around the 10-year mark, assuming things can continue on the trajectory that they're on. Now, obviously, all models are wrong, some are useful. That may be wrong, but I think for me, I think there's even chances as not that a quantum computer exists by 2034.
So that's 50-50. The question is, what's the 1% or the 0.1%?
Oh, the 1%. I mean, the 1%, I think I think it's a 5% by 2029 would be what I would say.
Excellent, thank you.
Yeah.
Anybody else? I'm just curious to hear.
Not today, not next week.
I think there are some resources that look at what various experts have said. I think there was one from 2022 that had the minimum experts gave something like a 17% by 2032, and that was prior to the 20x speed up that Google had. The biggest one for me, and the reason I switched from like quantum computers are probably going to happen, but like they're going to happen in a long time, to being more concerned about it, was Scott Aronson, who used to teach here, has this excellent blog on quantum computing. He's a quantum computer scientist, and his blog was always very skeptical of industry timelines and a lot of the industry players. He was the people the media go to when they want to deflate hype about quantum computers. And I started to see a change of him being from like, quantum computers probably physically possible, but like these people are doing lots of hype, to no, like actually it's a realistic thing on a short term. So him switching from a skeptic to not a skeptic, just based on his expert opinion, is one of the things that. But famously, he has not given any timeline. He said the Google paper moved the timeline 1 year closer to an unknown number of years. Was his response?
He did say in a comment in a blog post that you could not rule out that a cryptographically relevant quantum computer might exist by 2030. He qualified by saying it would be a Herculean engineering effort, but he then went on to say that people have done Herculean engineering efforts before, and he referenced the Manhattan Project. I think it was his only ever reference to any kind of timeline.
Actually, here I would like to maybe quote Seth Lloyd. He says, 5 years plus minus infinity.
And then this one I think is more for Mikhail, but do you think we'll be mining Bitcoin with quantum computers before we start breaking the keys, or will we be breaking the keys first?
Mining Bitcoins, I don't think it's, there's a big advantage at this point. Like the hashing is still, it's probably easier to do with ASICs than with quantum computers. There is like a specific set of problems you can solve, but that I don't think mining, specifically Bitcoin, would be. I mean, I know there's maybe some companies that are like trying to find the solutions, so we should try to hear from them at some point soon.
Hello. So I have 2 questions, but one will supersede the other, kind of depending on your guys' response. How does the landscape change if it's one company that's able to develop quantum computing, by themselves, and then there's kind of a timeline where there's a lag where they then come slowly, or if they all fall as dominoes very quickly in a manner that it becomes threatening, which is tied into also the question of what is the timeline or what does it look like in your guys' mind if we can just kind of come over that barrier and we stay in it, there's slow progress versus if there's a very quick progress either from one entity or multiple entities to have more compute available very quickly.
Sorry, just maybe like to summarize your question.
What does the landscape look like if it is only a single company that is able to solve this problem versus many companies very quickly come to a conclusion?
Yeah, I think overall the competition helps in the sense because different systems, different architectures, they learn from each other.
Sure.
So competitive environment, I think, is definitely helpful. So it's good to have multiple companies in the field.
I think one thing about quantum computing that not everyone may be aware of is that you have a quantum computer is just kind of it's an abstraction in the same way that a classical computer is an abstraction. It can be realized in a number of ways, and so neutral atoms is one way. Google or I guess Google's doing neutral atoms now too. But traditionally they focused on semiconductor quantum computing, and there's other kind of more exotic approaches using photons or using spin silicon qubits. All these are kind of different tech trees. I mean, it's all working on the same problem, but kind of the bottleneck, the engineering requirements for each are kind of distinct, not totally, but so I think I guess for me, there's a real question on which tech tree gets there first and who has it. Is it a company? Is it a government? That's an open question. If it's a government, look, are they going to focus on something like Bitcoin? Maybe not. If it's a company, I mean, if they're economically incentivized, maybe they will. I think the other piece, and this is something that the Google paper brought up that I think is important to note, the Google paper actually highlighted that if you had a superconducting architecture that you assumed could run in 1 microsecond cycle times, then with their circuit that they compiled, you could actually run Shor's algorithm within 9 minutes, which obviously if that were to happen, that would have big implications for the network because then you could basically you'd run short range attacks on anyone in the mempool. And therefore you don't get the same kind of preparation that you thought you might get by being like, all right, it's just the exposed keys first. I mean, that's obviously already a huge problem, but I think, how quickly these fast clock architectures emerge, and the superconducting is obviously the most well-studied. People are excited, and I'm not qualified to comment on the viability of spin silicon qubits or photonic qubits, but I think people are excited about them because they could potentially be stable and fast clock and maybe jump ahead of what kind of I consider like the current generation of quantum computers. There's just another dimension of unknowns that, again, to me means that we need to hedge our bets and prepare.
Actually, I would like to also add, so there is, one is like the stack of the software for quantum computer, it's pretty tall. So there is like at the bottom, close to, for example, for neutral atoms, what kind of laser pulses you send and what kind of the sequence is. So there's like lower level compilers, but then there's a whole stack. And how do you optimize? There is quantum error correction protocols, and they could be more or less generic for both of these kind of material platforms or architectures. Then there is also compilation. How do you optimize the circuits, the logical circuits? How do you reduce the number of T-gates? How do you implement some of the like architectural structure and alignment of the quantum computer? So, so I think there is a place for like generic development down to a specific architecture.
I want to answer your question in a very different way from a Bitcoin protocol incentive perspective. If I could plan how this would happen, I would really prefer that only one company have a quantum computer, because even if they're going to steal the coins,
you know who did it.
Even if they're going to steal the coins, the miners will like just have to make peace with that. But if there were like three competing companies, like two of them could side with miners to prevent the other one from being able to mine it. And now you have the situation where like miners are orphaning each other's blocks to steal money, and like it really, really hurts the consensus of Bitcoin. And so I think that there's like it would be wonderful if it was just one. And the more that happen at the same time, the more these really weird like game theory incentive problems can arise. So hopefully we have like a period of like a monopoly on quantum computers for like at least 6 months.
Wonderful. Thank you guys so much.
Actually, I have some afterthought to the person who asked the question before about mining Bitcoin with quantum computing. Yeah. Yeah, I have some just afterthought. So actually, before joining Cohere, building neutral atom computers, so me and my friend, we looked into this problem. We were like, okay, how can we flooding maybe money into quantum computing, like building essentially as an ASIC type of system. And that turned out later, so we try to optimize, like take the Bitcoin protocol, like proof of work, and then update it as a quantum proof of work, so that the quantum hardware have an advantage, because you need to pay like extra, so you need the quantum computer, like the proof of work needs to be aligned to the strengths of the quantum computer. Anyway, that was led to like several pivots, and then it turned out later into introducing this quantum proof of work into the qubit coin. It's more like, I would say, a minor network for trying to develop, speed up the development of quantum computers.
That's cool. I think we have time for one quick last question.
Okay, Alex, you said earlier that the mempool, presumably the Bitcoin mempool, would need to be completely redesigned with post-quantum signatures. I don't really see why that's the case.
I think
mempool doesn't store post-quantum signatures.
Yeah, well, but I mean, the way these like node implementations work and the way that the network is designed is, you know, certainly among the miners, right? Like if you think about the miners and how they share transactions or blocks between each other, it's highly optimized for the current system. So I think if you change what the signature scheme is, you need to revisit that potentially. And so, you know, I don't think, I'm of the belief that if you change the signatures, which is really the kind of one of the most fundamental parts of this network, that it has a lot of impact all the way, all over the protocol, at the networking layer, at the client, on the client side, you know, in various different places, I think, practically speaking. Yeah, that's my view. I think, again, the mempool, I mean, just, again, there's like a simple, how much memory does a node allocate to the mempool? I mean, like, if you had some amount before, well, now you have less capacity for transactions, right? So, and that's like just a simple, just to me, it's just a very simple framing. Now, whether or not that's the most important first thing to think about, it doesn't, I don't know if I would make that claim, but I think for me, what the point that I was trying to make is really that this is not like an isolated thing that we can just like slide in the post-quantum signatures and then it's like over. There's like a bunch of impacts all the way up the stack that have to be considered. And then also outside of the core protocol, all along, at every point of dependency of anyone who's actually using the Bitcoin network, all of those dependencies have to get considered as well.
Cool. So I think we can discuss all these interesting things over lunch. And I want to thank the speakers.
Thank you, Clara.
Yeah.
We will be back at 1:25, getting back in the room. So enjoy lunch. Thank you.
Welcome back, everyone, to the MIT Bitcoin Expo Freedom for All. To begin our afternoon sessions, please join me in welcoming Neha Narula and Frank Korba for a fireside chat.
Hello, everybody. How we feeling? Post-lunch, we're feeling good? A little bit of coffee, maybe? Get pumped up here?
Tell your friends to come back in the room. We're starting.
That's it.
Yeah. I don't know what's going on. But,
It's going to be a lot of spicy takes, tell them. We're going to get real spicy up here. Yeah.
Frank and I are going to have a great conversation.
Yeah.
It'll be fun. I know you're tired. I promise there won't be any slides with complicated cryptographic protocols, so at least you will not have to deal with that. But also, just really quickly before we get started, I just wanted to say thank you to the Bitcoin Club organizers. So you might not know this. Sometimes people think I run the digital currency initiative here at MIT. We do not put this on. We try to help and support them. We contribute, but we do not organize this conference. This is the student club at MIT, the MIT Bitcoin Club. So just really quickly, just want to thank them for doing this since, I think, 2013. It's amazing. So long. So we were just talking about that.
Yeah.
So anyway.
And on my part, I want to say it's an honor to be sitting next to you for the work that you've done here with the Digital Currency Initiative, and to be here in a room like this with someone like yourself is an honor for me. So thank you very much. And also, I come from teaching in academia for a while. I didn't complete a PhD, many different parts of master's degrees, did a lot of dropping out of school at the graduate level, but ended up teaching at the college level for about 7 years. And one thing that I've come to very much appreciate about Neha is that in the very, very, very good ways, she is like, I appreciate your academic nature and that you constantly question things. The first time I met you, I think it was at an HRF event, and I'm like, this is the head of the Digital Currency Initiative? All this girl has is like a bunch of skepticism about what we're building. And I think it's worth diving into that, because oftentimes in the Bitcoin space, we see cheerleading and we see Bitcoin fixes this and we see the world is getting better. And I think that there's truth to that, but there's obviously some nuance involved with this. I want to start a little bit with what happened. We did a little kind of a mini conference in the room next door. We talked a little bit about some research you did at, I think it's Makerere University, if I'm not mistaken, in Uganda. And I think you did get some takeaways from what was actually happening. I'm kind of curious, maybe we'll start there. You're curious about what's happening on the ground. What did you see in that particular study? Was it what you expected?
Yeah, so just to set a little bit of context, what happened yesterday and what we're doing. So we it was actually like kudos to HRF for, I met so many amazing people and like yourself and connected with so many people, and it really came at an important time for me actually in Bitcoin. Can I just tell this story really quickly? So this was like a little bit after the ETFs had gotten approved and were getting really big, and I was just super disenchanted. I was like, what are we doing here? This is not why I started working on Bitcoin. This is not why I got excited about Bitcoin. It wasn't so that a bunch of large traditional incumbent asset managers could build these financial instruments just to profit off of Bitcoin. That wasn't why I got excited about the technology. And to see how many people were cheerleading this and acting like we had, gotten to a point of success because of this was just really demotivating for me. I was like, I don't understand. I feel like I'm in a completely different frame of mind than all of these people. That was like the predominant narrative on Twitter. And so that was really meaningful for me. And then I went to Oslo for the Freedom Forum and met all these people who were actually using Bitcoin and, to be fair, stable coins, and who were saying like, I need this. This is something that has made my life materially better in certain ways. Not that it fixes everything, and we'll get into that, but like makes my life better. So that was incredibly empowering for me. I don't know if any of you have had that experience before, but if you came to this conference last year, you might have, because we brought a lot of that into the room. And I think, what came from that was me saying, okay, this is amazing. I'm hearing these stories, right? And you tell so many of these stories, which is so important. I'm hearing about, Farida in Tongo and Roya in Afghanistan and all of these stories, but I need data. I need to know what's actually happening at scale. And so we decided to try to bring together people around the world using the name MIT to get universities in all of these different places where this technology is actually making a difference, where people don't have any other option, right? Like, where is that? That's the global South. That's Africa, Latin America, certain places in Asia. But we're sitting here in Cambridge, Massachusetts right now, which is a super special place, but also very privileged. How do we go and connect with those places where people are using this and better understand and get data about how people are using this? And so that's what we set up, and really building off of the work that we found. First of all, when you just work with universities and professors, it's really hard to get anything done. They just
I have to really hold myself back there.
yeah,
as you're saying
it's
that.
hard. It's really hard. We are a university, but it's really hard to get anything done. So we started working with local on the ground nonprofit organizations. And so for Macarena, it was Bitcoin Innovation Hub. Hi, Palos. Hi, Ryan.
Yeah.
And so they were the ones who really led these workshops in Kampala in Uganda. It was super interesting. We learned a lot. We hope to replicate it. Next up on the list is Mexico, maybe Monterrey. They're really excited about it. It's workshops, and then it's classes, and then it's longer term research, and then it's getting at this data and the stuff that we want to learn.
Appreciate all that. We're going to dive into a little bit of the reality here. There's also some skepticism around, do we have the proper tools to scale Bitcoin in ways that's going to make it both easy for people to use on the ground, but also in a manner that's non-custodial, the way Bitcoin is supposed to be used, so that it offers people that sovereignty. Where do you think we're at in terms of scaling Bitcoin and the options that the different layers that exist provide?
Yeah, really great question, really complicated. And in some ways, there's two ways to look at this, right? So one way is theoretically, okay, could Bitcoin actually work for everybody in the world? What if we wanted to make this actually global internet money? From a theoretical perspective, all right, we got 8 billion people in the world. We know how big a transaction is. 10 minutes, a block. What can we actually fit? And you're like, wow, we cannot fit everyone in the world. Okay, we've got layer twos. We've got things like the Lightning Network. That's got some serious liquidity limitations when you start to set things up, right? And all right, cool. Well, there are all of these new layer twos, which are really fascinating and interesting. We've got things like Arc. We've got things that make some security compromises like Spark. We've got, and Spark chains. We've got things that make maybe even more further down away from self-custody, but still really interesting, things like eCash. So how do we think about all these things? How do we put all those things together? That's something that I've been thinking about and looking at, trying to systematize this. Talked about it here last year a little bit, talked about it in Bitcoin Vegas. And the answer is unclear. Unclear we can get 8 billion people on Bitcoin in a self-custodial, strongest security assumptions possible manner. So from a theoretical perspective, not sure. From a practical perspective, if you actually look at fee rates on the blockchain today, they are extremely low.
Not having a problem.
We don't have any issues in terms of demand and use. And so that made me kind of, wonder, all right, it's important to, and this is something that I think academics are really good at. You can look at things from a theoretical perspective. You've got to marry that with practice. What is actually happening in reality? Are blocks full right now? Are we having trouble in terms of fitting all the transaction demand that we have right now on the blockchain or in Lightning? No, these are not actual problems today. Might they become problems? Maybe. Maybe people aren't putting traffic on Bitcoin. Maybe they're turning to other choices there's a lot of new chains coming out. Maybe they're using custodial Bitcoin instead, or custodial wallets. So maybe because there have been high fee rates in the past, people are not choosing to do that. Maybe if we showed that there was a lot of capacity and they wouldn't have high fees, they'd come back. All of these are really interesting kind of hypothetical questions. But yeah, it's made me think that, okay, I do think that this is a super interesting question. I think it's important to handle. I don't know if it's the top one right now, but if you're interested in the whole world using Bitcoin as money, you should want to engage with these questions.
Could I comment on this?
Yeah,
if
yeah,
you don't
please
mind?
do.
So I think what comes to mind here, just this week, I think it was on Friday, I had a conversation with Heilman, who was one of the co-founders of Bitcoin. For those unfamiliar, Bitcoin is one of the first, what gets termed Bitcoin circular economies in the world. It's in Mossel Bay, South Africa. It's based primarily in a township there, and it works in conjunction with a nonprofit that teaches some underprivileged kids from that area how to surf as a means of empowerment. And I had a conversation with Heilman specifically about Fedi, so I do work with Fedi for full disclosure. And what he said was really interesting. He said, one, there's plenty of people in this community that not only not only do they not want to take self-custody, we are never going to force them into taking self-custody. That is not going to happen. And then we talked about custodial tools, whether that's Blink Wallet or Wallet of Satoshi, which I know there's a non-custodial version of, but which many people in that community use a custodial version of. So those are fine for now. They can onboard. We never advise anyone to hold any significant amount of money within a wallet like that. They said, we haven't figured it out, but we're now experimenting with Fedi. So we've created a federation here. It's a distributed group of people who are doing it. And this idea of community custody does seem like it fits this idea of being decentralized on some level. It's still a custodial tool. But I think the other thing, and I'm curious to hear what you think about this, is that when he described everything that he's been doing in that community now for 4 or 5 years and sort of the evolution of the technology that he's teaching people to use, a lot of it ends up coming as either a reaction to what's happening, like, okay, well, these people don't want to take self-custody, so what is now our option here? They're still a part of the community, we still want them to use Bitcoin. So in your mind, I'm curious, as someone that's watched the technology in this space develop for longer than I have, do we need to maybe hit certain thresholds to see which needs actually then need to get met versus building all this stuff and then hoping that people start using it because it's the best option?
Yeah, I think the point you're making is so important. This idea that you need to meet users where they are, and that we need to, like, part of saying, I care about self-sovereignty, I care about individual rights, I care about these values, is saying, like, not trying to force a user into a certain way of custodying their money or not, or a certain coin or not. You let them make the choice that's best for them. That's part of the values, I think, that come from this technology, is that each individual gets the right to make their own choice. You can inform them, you can explain to them the best you know about how everything works, give them information, but you gotta trust they know what's best for themselves, right? We're not here to tell people what to use. And sometimes I think people get confused that the idea of providing people the option to self-custody their funds, incredibly important. Forcing everyone to self-custody their funds, not the right thing to do, right? And we don't know where that's gonna end up. But the optionality of it is critical, and I think that's what we're doing. And it's so important to build a system that gives people the ability to experiment with different points in the trade-off space, right? Like, maybe this federation is the right answer for this community. Maybe a custodial wallet that's like super low latency, super like trusted, but really easy recovery. Maybe that's the right answer, right? I am on the board of Block, and one of the things they came out with was BitKey. And BitKey is a super cool 2 out of 3 multi-sig hardware wallet that really focuses on UX and usability. And they got so much crap.
It's hard out of the gate.
Right, from people who were like, no, this isn't totally self-custodial. How dare you not put like a screen on this thing? And they were like, Block has spent a lot of time. They're people from like Apple. They have a lot of hardware experience. They thought like really carefully about UX, how to make this device like in a costful way, like not cost too much. Yeah, it doesn't have a screen on it. Honestly, is a screen on it the most important thing, for security? I don't know. I think they picked an interesting point in the trade-off space. And we got to allow that experimentation to happen. That's what's going to get, that's how we're going to solve real users' problems, is meeting them where they are.
I think 100% enforcing people. I think we've all learned also, where a lot of people in the Bitcoin space who are super enthusiasts or nerds, we've learned the hard way when it comes to explaining Bitcoin that we often didn't do a great job of meeting people where they're at when we hit them over the head with Austrian economics or how a blockchain works or something along those lines. But I think now we're going to start seeing really interesting things. Another thing that comes to mind are things like bolt cards. So Herman brought this up as well, and I've heard this from other people, particularly in Africa. If someone doesn't even have a phone, and I love things like Machankura, which allow people to send Bitcoin in a custodial manner using a non-smartphone, but then what happens for the person who doesn't even have it? So you can give out bolt cards, and you have this example. I think the one thing about this space that excites me, and I say this also now working with a company like Fedi, and I'm not shilling for them, I say this because I see the amount of responsiveness we have to what's not working and what is working, and even if that's just in software design, and I've had that conversation with people in other companies in the space as well, there's a lot of listening to okay, what do you need? What do you need us to build? And I don't know, it doesn't mean that one day there still won't be a sort of certain threshold that we really struggle to get around. But I think at the same time, the feedback and the constant dialogue with communities, I think, has to be at the center of it. And I think that has to be a part of the business plan that's built in. You need to be able to speak with people because it's the people, it's not only that, it's a new technology, it's a very sensitive subject. It's money. You're talking to people about money, a new form of money that is not issued by a government. So it's a subject that's very, very difficult, and without paying attention and sort of having the care necessary. And shout out to someone like Mogashini Naidu, who does work with helping design user interfaces for this across the world. I think it's incredibly important, but I don't know, given all of your experience, I have to ask this question, I don't know why. I feel like with open source, I remain optimistic because you just never know who's going to get involved, the way they see something, and especially given that this is global, you might get some developer, whether they're in Southeast Asia somewhere or Nigeria or somewhere in the world, who comes to a problem and says, you know what, I'm gonna solve it for what's happening in my situation, and then that ends up solving it for a bunch of other situations as well. Have you seen this in your time doing this? Do you feel like you've seen people come to this, or is that more kind of a theoretical take on it?
Yeah, I mean, I don't think I'm looking at the same, like you're very focused on like non-technical user groups in these communities, right? And I'm coming at it from the point of view of the technology. But definitely something that has been incredible is seeing like these like really smart anonymous people who just show up in like the repo or on the mailing list or writing a blog post or whatever, and like, I don't know, man, woman, whatever, non-binary. I have no idea who they are. I have no idea what their real names are. I don't know what country they're in. I don't know what languages they speak. But it's incredible to like read their ideas and be like, yes, like I have, like like to connect with people in this way intellectually about system design, about cryptography, about you know how to solve that kind of problem is incredible. And I'm imagining you're seeing that with like the user problems, right? And that is just like the coolest thing ever. And that's what comes from permissionless open systems.
Yeah, and I think that's the part that's exciting to me, because it's not like, well, the head of this company is really smart and he's hired other smart people, they'll figure it out. It's that anonymous person who might come in with the idea or might see it from an angle that everybody else was missing. I think that remains a big part of it. But I do want to ask this: what has you, after voicing your skepticism, what you're worried about, you're paying attention to all this, what has you optimistic though about what you're looking at? Because I think it's important to note that. What would you, even not even in terms of something that's been perfected, but like what feels like it's moving in the right direction for you?
Yeah, I mean, I guess it is that like open permissionless thing, right? Because sometimes, okay, sorry, I am a very skeptical person. I'm like, I'm
a healthy skepticism.
I'm just like, I'm a critical person. That's who I am. Like everyone in my life has to deal with that. It's not fun for them. But you know, and sometimes you get really frustrated. Like we've talked about the dialogue on crypto Twitter, like the extreme ends, the black and white thinking, you know, all of this stuff. It's really frustrating. And then you get frustrated at a meta level because you're like, why are these people who I know are smarter than this paying attention to this? Why are you not just ignoring all of that? Why are you getting caught up in it and letting that influence you? But I think what is you know, we were talking about doubt and we were talking about criticism. And before I started grad school, there's this poet, Rainer Maria Rilke.
Sure.
And I read this quote by Rilke, and it was about doubt. And it was about taking your doubt and reframing it as a tool. So your doubt is now something like you start to doubt yourself. You start to doubt what you're capable of doing. You start to doubt, am I ever going to finish this project? Are we ever going to solve this problem? Use your doubt to doubt your doubt. Okay, this is going to get a little weird and meta, okay?
I'm into it.
If you have to take that skepticism and that criticism and apply it in the other direction. So you're like, oh my God, how are we going to solve these problems? Bitcoin usability, this is so hard. Like, how are we ever going to get there? Can you say we will never solve these problems? Can you say it is impossible to solve these problems? Can you say that actually no one will ever figure anything out to get us to where we need to go? Like, is it truly like never going to work? No, you can't say that either, right? And that starts to create the seeds of opportunity. It starts to create the seeds of hope and direction, and you start to get more excited. And this is the only way I made it through grad school. I'm going to be honest. I probably would have dropped out. I should have dropped out. Actually, it's a smart thing to drop out. But this, like, this technique. And so when someone is like, you know, what's the current debate du jour of the day? Quantum computing, right?
Oh, we're gonna bring it up. We're gonna
Yeah.
do it. All right.
Well, it's just
yeah.
such a great example for this, right? Is like, oh, well, a quantum computer's never gonna exist. Are you sure? Are you sure a quantum computer's never gonna exist? Do you want to bet the future of Bitcoin on that fact? Or, you know, saying like, we're never gonna figure out how to upgrade. Well, really? Is there really no way? Like, no one's going to come out of nowhere and like you really want to bet against the, you know, the intelligence and the work of like all these people in the world, or like we'll never find a way to upgrade that still leaves Bitcoin as Bitcoin. Really? Are you sure? Are you sure we can't like make it through this? So you start to like kind of play this game, and I found that I hope that wasn't too weird of a tangent, but I found that very constructive. Yeah.
I think your post about this, so you talked, let's get back into quantum, and we'll talk about dialogue as well. So there's been all of this fight over quantum, and I read your post, you posted something about it, and we talked a little bit about this yesterday, and you made some, I thought, just very basic, easy. So you said something yesterday, you said, and this is beyond your post, just, well, what if there is a 5% chance that we're not ready for this when quantum comes around? That's too big of a chance. And I say that wholeheartedly, and I'm gonna talk about it in my talk later. When I work, if I'm in a vulnerable community somewhere in the world, and in the back of my mind, I know there's a 5% chance, I lose sleep at night.
100%.
That's not a good feeling. So I think what you did is you injected some nuanced thought into a conversation on X, which oftentimes these things don't even come close to resembling anything that have nuance. And I think that there were some pretty rational responses to it. I think you really did a good job of people coming to it and saying like, I think she's right. I think we should be at least thinking about this in case it ever happens. That's it. She's not saying it's coming tomorrow. She's not saying it's coming over a certain time frame. So I'm curious, what was it that got you to a point where you feel like you needed to articulate all of that? And maybe just a quick summary of it for people who haven't read it, if you don't mind.
Yeah. I mean, really, it's the people that I work with here at DCI. So one of them being Ethan, who's already like given a talk and been on a panel, but just hearing him talk about it and talking with him about it, it was something I didn't really want to think about. I don't work on quantum computing. I'm not like a hardware person. I didn't really want to deal with it. But just hearing how he thought about it, and then seeing the discourse and just realizing how unproductive the discourse was, and just being like, I actually like kind of got enraged, and then just like wrote a very snarky version of that post that was like really mean, because I was just so mad about the discourse. I was like, how could you? Why are people coming at it this way? And then you know, Ethan was like, maybe you should tone it down a little, but also just saying like, hey, yeah, this is all obvious to you, but just say the obvious thing. Like sometimes we don't need someone to invent a whole new way of doing things. Sometimes we don't need like a new signature algorithm or a new like, you know, like we don't need a brand new software idea or a brand new BIP. What we just need is someone to create clarity out of the chaos. And so I think people should spend maybe a bit more time on that. Like just say the thing that you think is obvious, but say it in like a measured, logical way, which considers both sides. Don't try to sell your thing, and you know, but makes a point. And I think that there's a real opportunity for that. And anyone who's listening to this, I hope there's a lot of people who can contribute in that way. So
I would love to piggyback on this point if you don't mind. Oftentimes, because we're in a bubble with each other, and sometimes we're in a bubble in our own minds about what we're thinking about, and maybe the way we think we're articulating something, or our knowledge or our experience, and that's not necessarily coming across to people. So oftentimes, I think, at least in my mind, I'll speak for myself, but I'm imagining maybe you've gone through this as someone with a PhD from MIT. We go through this big thing where we're all these steps ahead in our mind, but this one thing that we're very clear on, that we feel really good on, we put a lot of time thinking about, we kind of think this is already understood by everybody. Yes. And instead of just articulating that well, because we've put time into that, people don't do it. And then what happens is that you're kind of having a conversation based on these 3 steps ahead that you're at with this other person over here, and then this little thing called the human ego gets involved, yes. And it turns into a forest fire, and everybody's angry. And in reality, what needed to be said was maybe before we create a BIP or before we do this. Maybe these thoughts all just need to be stated very clearly so we have the proper inputs for this discussion. Do you find yourself and maybe people you work with often struggle with this?
Oh, 100%, 100%, 100%. And engineers just kind of want to get to like the solution, right? And it's like, no, you need to actually spend a lot of time articulating the problem and making sure everyone's on board with what the problem is, because otherwise we're going to be like, we don't understand the trade-off space. We don't understand what you're trying to solve. So yes, 100%. And yeah, just really want to encourage everybody to do that.
Do you often, I'm curious, when you have something to say or to write, do you often run it through like a trusted group of people for that exact reason? And do you have the same, do you feel like in the open source community, it's the nature of obviously people are publishing something that's public, but before they publish anything, even when it comes to thought process, establishing a problem, is that same process there?
Yes, yeah, 100%. And there's like different levels, right? You know, maybe like the least, you know, the lowest level is like shooting off a post on Twitter. Like, I have this idea, here's this thing I did, whatever, like writing up some notes, sticking it out there. And then maybe at the top level is like peer-reviewed, like extremely prestigious journal paper or something like that, right? And you know, you've got a lot of steps along the way that you can ask for feedback, that you can frame your ideas. And so, you know, all very super valuable things to do and quite common in the open source community.
Okay, appreciate it. I just want to double check on time. This was 30 minutes, right? That's what I thought, 5 minutes, perfect, appreciate that. Okay, so with everything that you're seeing, you're about to move over potentially into Monterey. When it comes to material, let's say you read a story that I write.
Yeah.
When you're looking at that, or other journalists in the space who cover what's happening in circular economies or the messaging coming out of circular economies, what are some of the first things that you think? Is it like, well, maybe something's going on there, but maybe everyone's just using a custodial wallet, or maybe they don't have the resources they need to do the proper education? In your mind, what does the skepticism look like when you see Bitcoin is working in Zambia, or Bitcoin is working on the border of Togo and Ghana or something like that? Where does your skepticism start?
Well, I think I start with curiosity.
Okay.
Like, what's going on here, and why did people, you know, see something here that they thought could solve their problems? What are their problems? What do they see in it? How are they using it? And coming to that, not with like preconceived judgments about how they should be using it. That's super important. I think maybe one example to talk about, I'm curious to hear what you think about this, was like Bitcoin in El Salvador, right? So like, you know, a few years ago, that was like all the rage, right? Bitcoin's, you know, I saw that and I was like, it sounds like they're saying people have to use, it sounds like they're telling merchants they have to accept Bitcoin, who might not want to accept Bitcoin.
At one point, I think that was the case.
Yeah, they have a government-produced wallet that really unclear exactly how it works. Is it custodial? Is it not custodial? You know, can the government see all the transactions going through this wallet? Like, there were a lot of questions that I had about what was going on there, right? Sure. So that was like an example of like, this, you know, you don't just want to, that was where my skepticism came into play there, was like, what is going on here? Is this something that people are voluntarily adopting because they want to and they think it solves their problems? Or is this something being imposed on them? So that's, you know, that's immediately what happens. Always look for the incentives. There are so many places around the world, in Africa, in Latin America, where some chain has come in with a bunch of tokens and they've given them a bunch of tokens and they're trying to bootstrap adoption. Fortunately, you don't see that much in the Bitcoin world because, you know, they don't have a bunch of like meaningless money they've manufactured out of nowhere to like try to incentivize.
And we're good at calling people names, those people who do that sort of thing.
Yeah, but I've seen this numerous times. They'll go to a university, they'll go to a group, they'll go to a whatever, and they'll try to incentivize something to kick off. So I always look for that. Is it organic? Are people adopting this themselves, or is some, you know, is some chain trying to like kick something off? So those are like a couple of things. Yeah, curious to hear what you think.
Yeah, I had very mixed feelings about El Salvador. To the last point you just made, I will say that I think Stacy, in particular, who runs the Bitcoin office, did a very, very good job in making sure that other chains didn't come in and start saying we're the next Bitcoin or this. I think, you know, they work with Bitfinex, and Bitfinex has other chains and securities and everything else on their thing, and that's fine, but I think they did a good job in messaging that Bitcoin is something different. The way it was rolled out with a government wallet, as you said, for people who were skeptical of government, they inherently then became skeptical of Bitcoin because they felt that Bitcoin was an extension of the government, which we all know it's not. So I think that that part was kind of rough. But in El Salvador, I often say this to people, Bukele is a polarizing figure, and I have very mixed feelings about what he's done. I'm happy on a certain level that El Salvador is safe, or safer than it's been in recent years. the way that they got there. Obviously, that can very much be debated, and there's a lot of ethical issues there. But I think about El Salvador, and what comes to mind first for me is the story of Mi Primer Bitcoin, my first Bitcoin, which is now the biggest sort of educational platform for Bitcoin that can be, it's been translated into many languages, that can be adopted in ways that fit local context. That was born out of, John Dennehy and a bunch of people from El Salvador working together to create something, and that happened because they made the announcement, we're Bitcoin country, and I speak with someone named Reina Chicas. Shout out to Reina if she's listening. She's the BTC of My Premier Bitcoin, the Bitcoin Training Coordinator. I love the title. But I think of that story because that is what Bitcoin is. It's people educating people about what this is, teaching them how to use it, teaching them the trade-offs, teaching them the different wallets, some of the theory behind what Bitcoin is. So I think with what I do, I'm always a bit skeptical of what the government's take on it is or what their approach to it is. At the same time, I don't think that should be ignored or we should just poo-poo that. We just sort of have to take it into account. But I think the story of El Salvador and the way that Mi Premier Bitcoin is now basically the go-to training platform for most of the circular economies. And in my experience, I have not found circular economies that I think are doing good work who don't have a substantial and robust educational dimension, whether it's Trezor Academy or Mi Premier Bitcoin. So I think with El Salvador, anything that has that level of hype, it's always something that we have to be skeptical of. But I would say look more at sort of the interpersonal. There was this platform that got created. There were people across the country. They were in public schools at one point, completely independent. They weren't getting paid by the government. Unfortunately, the government didn't want that to be the case anymore. But you had this independent entity that's come out of it. And also the Bitcoin office, they do very good work with training developers and helping to train developers. And some of that is public-private partnership work. But I think that all of the stuff needs to be looked at with nuance. And it's a suggestion I'll make to everyone here. And I don't think anyone here needs to hear this, but less cheerleading, more critical thinking, and more sort of like, okay, what is maybe more how to help? Because I think the cheerleading part, I have my issues with Bitcoin slogans. Bitcoin fixes this, probably being at the top of that list. Oftentimes, the people saying that come from extremely privileged situations. When you actually go onto the ground, if you were to go into a village in Ghana, Bitcoin Dua I visited a few years ago, and just come in and say, hey guys, Bitcoin fixes this, everything is gonna be fine here, you'd be like, okay, thanks, please leave now. So I think that approaching things with nuance and approaching things with the healthy skepticism that you do approach things with is necessary. And I think it's actually how we move forward, because if we're just cheerleading, we're not actually addressing what the next steps are. We're just saying Bitcoin has won and it's over. I don't think we're anywhere near that sort of place. Your skepticism actually, which I kind of absorbed after first meeting you, I really do think that way a lot more myself, so I want to thank you for that. I think it's really important that we approach things and we're saying, is this really working, or have we just convinced ourselves that these things are working or that they're going to work the way we think they're going to work? I think a lot of that story is still untold, and a lot of it's going to depend on the work that everyone here does and the work that you continue to do at DCI. So.
Yeah, and what I've learned from you is about listening to people on the ground, really engaging with them, really talking to them, learning their stories, how powerful that is.
Appreciate that.
Come to Frank's talk later this afternoon. You can hear a lot more about that.
I will be talking about that. Please give Neha a round of applause. Thank you guys, much appreciated.
Thank you, Neha and Frank, for a fascinating chat. Now, please welcome Kevin Kai with his talk, Agents Want Bitcoin, the Lightning-Powered AI Toolkit.
All right, perfect. So, today's talk that I'm going to be giving is regarding the rising star of AI and cutting through the fluff, right? I think everyone that has ever used Twitter knows just how low of a signal-to-noise ratio source of information it really is, and it can be hard to cut through all of that cruft. So I've distilled some of my findings, things that I've learned over time, and hopefully this will be useful to you. Here's a roadmap for my presentation. We'll start with defining what an agent is, then we'll transition to talking about some of the trends that we've observed in workflows, how people have adapted to using agents. Then we'll sort of talk a little bit about why Bitcoin is such a good fit for agentic commerce and why it's the optimal money for an autonomous agent, with a bonus section on fine-tuning local models if we have time. So first, what's an agent? I think almost every person in this room, being technologically oriented, has probably tried out ChatGPT, Claude, maybe even Grok. What's the difference between using one of those models in your web browser and having an agent? I would say that fundamentally, it's all about having access to tools. Moving from a very synchronous loop where you're writing a prompt, entering, waiting for a response, writing another prompt. An agent is more about asynchronous work. You're specifying what it is that you want the agent to accomplish, you're coming back later, and you're checking up on its progress. Some examples of agents, especially well-known ones, are Claude Code and Codex. I'm sure a lot of you have even used this. OpenClaw or Hermes, and Abacus. I'll be talking about some of these. Abacus is actually one of my side projects that I created that allows the Gemini LLM to take control of a Lightning node and manage liquidity, something that's been somewhat of a pain point. This diagram, while crude, I think gets to the point of what the structure of an agent typically is. You have a prompt that kicks off the activity, you have an LLM that's making decisions autonomously, and you have a series of tools that are able to mutate and change the environment that it's running within. Here's an example of a very common agent topology, which is called the swarm or sub-agent topology. In this design, you've got a user that's kicking off the activity, they're defining some series of requirements, and then the goal agent is taking that and enriching it to a point where you have something more structured, akin to a to-do list. At that point, you spin up multiple copies of agents, which then independently work on different chunks and pieces of this problem. As you can imagine, there's a lot of problems out there in coding that may not necessarily be tightly coupled. You might want to refactor one part of your website while having your agent tighten security in another. In that scenario, having parallel agents really empowers you to move at a higher degree of velocity relative to having a single session. Another type of topology is a team topology. In this example, we've got Grok serving as a captain with multiple sub-agents that are communicating with each other, debating on ideas before finally coming to a solution that they essentially came to collectively. Now that we've defined what an agent is, let's talk about some of the developments and evolutions that have occurred. In the beginning, we had something called the Ralph loop. This was when Claude Code had been just freshly launched and didn't have a lot of autonomous functionality. There was a developer who came up with this idea to essentially have a while loop in Bash to run repeatedly until a task was completed. The main innovation here was having stateful progress check-ins. So you had a progress.txt, you had a tool that allowed you to check Git history, and the key innovation was moving away from the weaknesses of a stateless application like an LLM. What a lot of people don't realize is that an LLM is actually sending the entire context of your messaging history every time you're inferencing a new message. It doesn't have any state. Claude Code and Claude Cowork, of course, besides being the foundational basis of most agentic coding today, was an innovation in terms of being able to target development and having essentially a coding buddy. The latter was more meant for non-technical use cases like working on PowerPoint slides or doing data analysis, but they were both equally powerful, and companies began to adopt them. One of the reasons why people had such a good time using these tools was due to skills. So in coding, we often have libraries. We'll write out some critical code like a cryptographic hash function. Then we'll be able to use that library in multiple places for our downstream projects. The same is true for skills. Rather than engineering a new prompt every time you want to accomplish some series of tasks, you can instead break it into pieces that then you can reuse in other sessions. We'll talk about that a little bit more. Here's a screenshot of Boris, which was the engineer who was responsible for launching Claude Code. This began as just a side project at Anthropic and blossomed into an actual product once they found some market fit. In the beginning, Claude Code did little more than just be able to read interfaces off of your computer. So it could tell if you're listening to a particular song, but it couldn't actually do anything. Then another Anthropic engineer expanded its capability set. It gave it access to the file system. It could read files, write files, edit them. They started realizing internally that this was going to be a lot more powerful than having a web UI where you could simply paste in a piece of code and have it refactor it. Moreover, it meant that you could be more context efficient. Rather than having the LLM ingest the entirety of your code base every time and have to search for where things were, it could build up an index of sorts, and that could be used to speed up lookups later on. A few months later, OpenClaw hits the scene. It became one of the most popular projects on GitHub. It brought a more structured type of usage for these LLMs. For the first time, you had prompts that were specifically engineered to allow behaviors to emerge. Rather than just writing a one-off prompt, you would have these reusable segments and cron jobs that would allow you to institute the specific kinds of behavior that you would want. To give you an example, imagine being able to go to sleep at night, having defined 2 or 3 issues that you found in your code base, waking up the next morning to have PRs to review. This is the kind of thing that OpenClaw was designed to accomplish. Another advantage was having multi-repo context. For Claude Code and Codex, you would often open up a session for your project, but if you had a project that interfaced with another or was used as a component in another, you wouldn't be able to share context across repositories. Since OpenClaw didn't have this limitation, it was useful if you had many, many repos that you wanted to work on in parallel. It also began to show people that the CLI was sort of the optimal interface for agents to use. You didn't need to build out complex MCP servers and functions that were clearly defined in what data types they would take. Instead, you could make a CLI that was intuitive to use, give the agent an instruction manual, and have it start using it in just 10 minutes. Another thing that I think was really interesting about OpenClaw was taking on the Linux philosophy of everything is a file. So in the Linux kernel, it doesn't matter what you're trying to grab from the kernel interface. You can just interface with it as if it was a file. You can use cat, right? With OpenClaw, it was very similar to this. You had a sol.md file which specified the base behavior of what you wanted out of your agent, and additional agent persona files that would allow you to constrain the behavior even further. Something that people don't realize very often is that LLMs are a jack of all trades. If you want them to do well on a particular subdomain, often you need to cut off certain avenues of where it might inference. The way to do this in OpenClaw is to have these personas. Interconnectivity was also an important takeaway for OpenClaw, as it had native gateways, which allowed you to give it access to Telegram or iMessage. So rather than having to open up a CLI and interact with your agent that way, you could have a much more friendly user interface, using tools and apps that you're already familiar with. However, this wasn't perfect, especially from a security standpoint. In just 2 weeks, when ClawHub started becoming inundated with skills, it was located and identified by security researchers to have tons and tons of malware. The top 4 skills that were on ClawHub were malware that essentially resulted in you executing arbitrary code. We'll talk about why this is a problem that has been worked on, but first I want to talk about Hermes. Hermes is an alternative agent put out by the news research team, and its main advantage over OpenClaw is having more autonomy. I think you'll see that as an ongoing theme. Hermes, unlike OpenClaw, does not require the user to prompt it to create a skill. Instead, it identifies when you're doing repetitive tasks and will automatically create a skill for you in the background, meaning that over time, the agent should become more and more efficient at accomplishing the tasks that you want it to. Additionally, there was full-text searching capabilities, as well as reinforcement learning, specifically through a company called Thinking Machines. They have hosted GPU resources, and Hermes has the capability of spinning up this reinforcement learning harness on the user's behalf. There were also security improvements like hardening. You had a read-only root file system. You weren't just YOLOing access to the entirety of your computer. There was namespace isolation, so skills couldn't necessarily interact with other skills. And pre-execution command scanning meant that if you had a command that was just pulling in base64 encoded text from a random arbitrary website and trying to execute it, that you would at least be given a warning and a chance to stop the execution instead of plowing right through. Now we've identified how agents came to exist, what people use them for. Where does Bitcoin fit into all of this? So the Bitcoin Policy Institute did a study, and they wanted to know if you don't use any sort of leading language, if you just give a neutral prompt, what do AI agents identify as a useful form of money? And across those 9,072 controlled experiments and 36 frontier models, the results were a convergence on 2 specific tiers. The first tier was being able to use Bitcoin as a form of savings, and the second tier was doing everyday payments. The statistics speak for themselves. 48.3% of responses were happy to use Bitcoin for everything, and 33.2% of responses were happy to use stablecoins for everything. In 86 responses, more interestingly, theory crafted the concept of an energy or compute-based token, or credit, without being prompted about Bitcoin. So I think this is interesting. It means that there's essentially parametric knowledge biases baked into these models that make them aware of the shortcomings of fiat payment rails. It also means that existing projects like the Lightning Network and Tapper Assets can fill both of these niches. If we consider fiat rails, I think there are a few problems for agent use cases. The first is that there's an impossibility for there to be no human in the loop. You cannot open a bank account for an agent. You can merely adopt one of them that you're using into a bank account that you're setting up on its behalf. There's no way for you to set a unified budget either. And if you ever get a fraud alert, then you have to manually intervene. Let's talk about a case study from Salesforce in regards to consumer behavior. So in Salesforce's study, they wanted to find out why consumers were getting cold feet, the last mile problem. And what they found was that 3 specific behaviors were shaping this consumer hesitancy. First was cart abandonment. The consumer was getting to the point at which they were ready to check out, but for whatever reason, they backed out. The second was multiple site visits without action, implying that they were looking at multiple sources of information, maybe different manufacturers for the same product, trying to weigh the pros and cons. And the third is very similar to that, which is tie-breaking seeking behavior. So maybe you add both of those products to your cart, you spend a significant time looking at it, but you don't actually go through with the checkout. Enter agents as a shopping assistant. This is what I consider to be the phase 1 of agentic commerce. Something along the lines of having like an extension in your browser that seeks out coupon codes and makes your life easier. It's more about being an assistant and a tool rather than being autonomous. In this paradigm, we've got an LLM that's got a browser MCP tool, and it can go to these websites for you on your behalf, visiting them as a human would, and gather information and help you evaluate for your purchase, right? So that could mean compiling reviews data across multiple websites. That could mean chatting with the users to get feedback. Is product A better than product B? Why? What are your opinions on these products and why do you believe this? Customers are able to stay within one interface. They don't have to hop across all of these different sites. And that's all fine and good, and even seems like a useful addition to the average person who wants to do these types of transactions. But where do we go from here? What's the bigger picture? I think the most likely outcome is that we will have agents that are transacting with other agents. That is to say, instead of a human driving the loop, the human will run a buyer agent and sellers will run a seller agent. What does that mean? First, I think we should think in broad strokes. If you have an agent and it has the ability to make payments, you probably want to constrain that a bit. You don't want it to just blow through all of the money that you have. To that end, at least in my experiments, I found that the best solution was to use LitD or Lightning Terminal's account-based feature. It allows you to carve out a macaroon that constrains the agent to only being able to spend a certain amount of Satoshis before it's cut off. But let's also think more deeply about what agent-to-agent transactions actually would look like. In the traditional e-commerce method, you might have the user searching across multiple websites. In an agent-to-agent sort of paradigm, it's more likely that you would simply identify what it is that you want to accomplish. For example, I want to buy a pinstripe suit that fits my dimensions and isn't more than $400. And once you've identified these requirements, allow the agent to autonomously seek out a seller agent, probably negotiate on price, finalize the order details, and then send you a notification. By the time you're all done, all you have to do is wait for it to show up on your doorstep. But again, these are all conceptual ideas. What is the mechanical basis of encompassing such a system? How do you actually achieve this with Bitcoin? L402, I think, is the best solution. It makes use of a non-standard HTTP status code, 402, as the name would suggest. The idea behind it is that you, as an unauthenticated client, will send a request to a server. The server will identify that you haven't paid yet, send back a header with an invoice and a macaroon. The client pays that invoice, in the process obtaining the pre-image, and then the server verifies the proof. That's a little bit of jargon, but I think this diagram makes it clearer. You have the HTTP request, you have client credentials that don't exist yet, you generate a challenge, then you have a response once you've done your payment, and then the server makes a very small amount of work to verify the credentials as well as the proof of completion. Then you're able to send the actual response from the server. So as you can imagine, this is very useful for APIs, for example. If you have a paid source of information like real-time sports data, putting L402 in front of it would be an easy way to get paid to provide that information. while a majority of the internet's information and data today is free, I don't think that's a trend that will last in the long run. So paying for the resources that are required to generate a piece of data is most likely where we're going to converge. Now, I mentioned macaroons earlier. I just wanted to have a quick explanation for what those are. They're similar to a JWT, that is to say they're a bearer token for authorization. You can place what are called caveats, which are restrictions. This can be anything from expiry to having a limited set of resources that you're actually able to access. And with the power of third-party caveats, you can actually constrain behavior even further. My favorite example for this is if you imagine there is a government L402 identity server, you get your ID back, but that ID is only really there to prove that you are who you say you are. If there's a store that's vending alcohol, they want to verify that you're over the age of 21, so a third-party verifier server with a database of everybody's birth dates can mint a discharge macaroon that is cryptographically tied to your L402 identity. Then, all you have to do is present your L402 ID as well as your discharge macaroon, and you have incontrovertible proof that not only you are who you say you are, but you're over the age of 21, and the alcohol store can safely vend you the product that you're trying to purchase. Aperture is another piece of this puzzle. It's a reverse proxy implementation, not unlike Nginx, and the point of it is to be able to have a highly configurable piece of software that allows you to put up a paywall in just minutes. It's also very agent-friendly. There's a dynamic pricing API in case the resource that you're selling doesn't just have a static cost. This is particularly useful if you're not just trying to sell CDs or images that you've painted, and instead are securing resources that are more dynamic in pricing. An example of that could be a Llama CPP endpoint where you're selling inference, right? That's going to be a dynamic price based on the length of the output that you've inferenced. Having this in place means that an agent can drive the process of setting up a paywall, setting prices, and also determining behavior based on input signals. And of course, it is compatible with the Tempo machine payments protocol, but I'm not going to really talk about that. That's a bit out of scope. So what are some possible applications for Aperture? I think we've already talked about pay-per-use API calls, and to that end, I think the tools that make the most sense to give to agents are lnget and Lightning Agent tools. So lnget is very analogous to wget or curl. It's a CLI-based application that handles the retry portion of the L402 protocol. It makes it so that rather than having to re-implement the L402 protocol every single time for an agent through a skill or writing a custom bespoke code, instead you're able to just say, here is this CLI command. Learn how to use it, and then you can access any L402 protected endpoint. It's very simple to get started with this. It's also low deployment friction. So if you have LND node running already, you don't need to use gRPC to connect it. You can just use LNC, which is the same mechanism that many of our users use to connect their Zeus wallet to their node at home. Some other possible interesting applications include having a compute credit. So in this example, Alice is a GPU host. She's got a data center. She mints 100 compute credits that's meant to correspond to how much compute capacity her data center has. Bob then purchases 100,000 sats worth of those credits, receives an L402 identity, and let's say that Bob didn't actually need that much compute. He only spent about 50,000 of those sats worth of compute. He's able to then offload that to Carol and provide her the L402, and she's able to take over his account. So with a little bit of imagination, I think you could see how this could turn into a futures market where the compute credit provider and minter is a separate isolated entity from those who are transacting in this compute credit. So what are the future improvements that I see? I think that one area of pain right now is that a lot of people rely on centralized indexes in order to discover L402 compatible endpoints. There's no clear signal that a given API supports it. So what if we instead had a .well-known URL? This is not dissimilar to a Lightning address, and having an identifier like this would make it easy for agents to build up such an index by crawling locally. Lots of ideas to mine there. Another improvement would be around streaming payments. Today, there's no native support for this. Instead, everything is on a request-by-request basis, but lots of use cases are actually more well-suited to having streaming payments. For example, let's say that you've got a Tesla and you're charging it. Wouldn't it make more sense, instead of loading up on credits and then prepaying, to instead send a small amount of Bitcoin, which would then allow you to charge for the next 30 seconds, send a small amount of Bitcoin again, charge for 30 seconds more, and when you want to stop charging, just stop sending payments. Bull 12 also represents an interesting incremental upgrade because it allows you to have reusable offers instead of having to create invoices every time. So all of this is very interesting. I think most people can think of use cases for how they could automate portions of their work, but maybe your threat model is incompatible, right? This tweet by Jack Capital mentions how any proxy like OpenRouter sits between you and the provider, and they have plain text access to your requests. A lot of people who are a little bit hands-off with their security may not realize that their agent's working with sensitive API keys or maybe seed phrases. If that's your security model, and you don't want to send all of this to the cloud because, again, the cloud doesn't exist, it's just someone else's computer, then these slides should be particularly relevant to you. So in today's AI ecosystem, local models typically lag behind anywhere between 6 months to a year versus the closed source models that are put out by Anthropic, OpenAI, and the like. However, parameter count isn't everything. A lot of people believe that in order to accomplish anything of value, you must have trillions of parameters. This isn't the case. With proper adaptation, a 9 billion parameter model can punch significantly above its weight class, and in my experimentation, I was able to do this with distillation from frontier models. SFT is one particularly useful type of fine-tuning. It takes labeled input data, so that would be assistant user turns that you then label and train by putting the gradients into the model and then fine-tuning the logits or the probability of a particular token being output. Essentially, there's a lot of fancy math behind this, but you can think of it as teaching the language model to speak your language. So if you're trying to adapt the model for a more medical context, this would allow it to learn things that are more related to diagnoses, specific illnesses, etc. It is cheap, but it does not teach why, only how. It teaches a style of communication, but it doesn't actually teach the process of reasoning. That's actually more suited towards reinforcement learning. My favorite variant of this is GRPO, which essentially runs the model through 4 to 8 instances, and then uses a reward function, which you can think of as a rubric, to grade each one of those outputs, and then nudges the model over thousands of steps to be more like the model version that output the most optimal output. It can be quite expensive, however, because you end up having to do tons and tons of inference in addition to doing the training, which is just using gradients to adjust weights. All right, that's the presentation. If all of this was exciting and interesting to you, and you think you've got what it takes to use frontier intelligence to deliver on higher developer velocity, please see me after this talk or scan the QR code. Lightning Labs is hiring, and we're specifically looking for somebody who's extremely talented with using these AI tools. And if you would like to follow me on Twitter, there's my handle and profile picture. I post a lot about AI things there, and I try my best to respond to DMs. And we'll go ahead and open up the Q&A.
You mentioned fine-tuning. Are there certain tasks that you think this still isn't appropriate for? I'm thinking like, can we fine-tune something and get like a decent Bitcoin core reviewer? But maybe that's just way too hard, and there's like other tasks this makes more sense for.
No, I think that actually is an idea that Soars, one of the core maintainers, was talking about, and I've discussed this at length with him. In my experiments, I've been doing a lot of work more on the L&D side, and one of the projects that I've had is using PRs, specifically the diff that's generated in the PR to train the model. But I think building a PR reviewer is very orthogonal to this, and in my experience, it's not something that would necessarily suffer too much from just doing SFT. It's more about the degree of training data that you have. So if you only got 50,000 examples, that's probably not going to cut it. If you have over 100,000 examples plus synthetic versions of it to pad out the total count of training rows, I think it's very much within grasp to be able to tune a 27 billion parameter model for this task, to be a very ornery, picky reviewer. All right, great. If there are no other questions, that'll be all.
Thank you for the great presentation, Kevin. Next, we have our panel, The State of cryptovc. Please welcome Boris Revsin, Hale Huang, Mario Mena, and Waikit Lau. We will have a short 5-minute break. Welcome back, everyone. Next, we have our panel, The State of Crypto BC. Please welcome Boris Revsin, Haley Huang, Mario Mena, and Waikid Lap.
Hi, everyone. Thank you for joining the State of Crypto VC panel. We're also supposed to be joined by Boris Revsin, but last minute complication, he was not able to make it. So we have Haley, Mario, and Wykit. I'll let each of you introduce yourselves. We can start with Haley.
Yeah, thanks for sharing. Yeah, I'm Haley. I'm from Easy Labs. So we just got rebranded from Binance Labs to Easy Labs a year ago, and we are a 10 billion investment vehicle. And also we're investing across AI, Web3, and biotech.
Cool. Hi, I'm Mario. I sit on the venture team at DCG. Digital Currency Group is a conglomerate of digital asset holding companies founded by Barry Silbert. So we invest off our own balance sheet. We're not managing third-party capital. And then the most prominent company within our operating companies is Grayscale, largest crypto asset manager, crypto native asset manager managing 300 bill. And like I said, I'm sitting on the venture team. We focus on equity and pre-token deals. We do have a liquid team. That's a separate sort of situation, and we are a prominent LP, and so we're in more than 50 GPs in the crypto venture space.
Hi, I'm Wykit Lau. I run a firm called Brightwing Capital, which is essentially our own capital for early stage investments into crypto, deep tech, software, and LPs in a bunch of funds.
Great, thank you all. So starting kind of high level, how would you each, in just a few sentences, describe the current state of crypto VC? We can start with you, Haley.
Yeah, sure. Yeah, just as I mentioned, so previously we just got rebranded to Easy Labs. It's kind of like a very comprehensive like investment vehicle across different sectors. But in terms of like crypto side, like Web3 side, we've seen a lot of like changes, especially in the native like crypto space. We've seen right now like on the venture side, like it's very hard to get adding like a mid cap valuation around like, for example, like C round or Series A, Series B. We've seen that a lot of like companies, they're kind of like separated into like very beginning, like very, very early stages, and also very later stage with tracking records for some strategic investments or pre-IPO round. So it's going to be very separated. That's why we have our investment thesis, like we build up within the Easy Labs. We do have our incubation program launching a year ago. It's called Easy Residency. And so far, we have like incubated over 30 to 40 projects. And for example, some like April, like the leading oracle like within BNB ecosystem, and also incubate Pruden.fund, which is right now like 1/10 of the poly market trading volume, and it's like the top one on BNB chain for the prediction market side. So I think from the incubation stages, we believe that especially within the Web3 side, we wanted to choose the founders like with the right PMF. From the VC side, we know which sector that we wanted to incubate, and we find the best founder with the best founder market fit into this sector. Yes, I think that's a very great strategy. And also from Easy Lab side, we also do some later stages. For example, because we stand on like in front of the BNB ecosystem, so we might see some potential strategic acquisitions across different like banking licenses or some on-ramp solutions, payment, etc., to kind of like better kind of like develop the ecosystem. And also we see some later stages like pre-IPO round. For example, we are the kind of like largest investor within like the big goal like pre-IPO round. And we will see like more companies going to have like IPO in the next like 1 to 2 years. Yeah, that's how we wanted to kind of like invest, where we see these kind of changes kind of evolve with the crypto investment side over the past 2 years. Yeah.
Cool. So I guess I'll just start with the elephant in the room. Obviously, crypto prices are down 50 to 80%. So I think from a broader market perspective, everyone is sort of negative. But I think the demise of crypto VC has been overstated. If we take a step back and look at the actual funding that went into startups in 2025, it was 23 billion. In 2024, it was 13, so we're up 80%. And that's not even factoring in the capital that went into crypto startups from IPOs and M&A. That brings it up to 50. In 2024, it was 15. So I think the capital markets for crypto startups are actually really healthy. And then the trends that we're starting to see is a maturation of the industry. Capital is starting to aggregate around a handful of startups in sectors that investors consider important around stablecoins, prediction market, perps. And so, yeah, we're in this place where the line between crypto VC and traditional VC is starting to blur because the non-crypto native tier one firms are starting to lead crypto rounds, whether it's Sequoia, Founders Fund, Ribbit, et cetera. And then we're seeing the crypto native firms start to diversify a little bit. Pantera just announced, $1.5 billion fund. It's going to do crypto, but it's going to do AI and it's going to do robotics. And so I think the line between crypto VC and traditional VC is blurring. And this is all, of course, in the context of a token bear market where crypto VCs can't accept or can't expect quick DPI from punting a token. And so when you move into competing into equity across categories that everybody's excited about, it's much more competitive. But generally, I think we're in a healthier state than people think.
Yeah, I mean, I agree with a lot of what they say. I think we talked about being spicy. I'll be spicier. I think when we think about crypto VC historically, it's the tokens, right? That's dead, right? If you need tax loss harvesting, that's where you go and invest. I think the token piece, there's so many historically problems with incentives, and it's so easy to break rules. I think that one is done. I think crypto VC now looks like fintech VC, right? People are investing. What do people care about? They care about revenues. They care about profits. They care about building equity value. I think that's going to continue. I think it's going to, like Mario said, it's going to look more and more like traditional VC, but with a very deep focus around this new rails that is rewiring Wall Street, right? So it's essentially Wall Street 2.0. I think it's going to be where the action is going to be.
Great, and you kind of led us to one of our next questions, which was, how do you think about tokens versus equity today? Are tokens done? Are they just a funding mechanism disguised as governance? So I guess, Waike, you expressed your thoughts there, but we can hear from
I mean, yeah, I think there's always sort of the meme-ish tokens, right? I mean, let's take the sort of the token du jour that's I think people think has is doing well, Hype, right? Hyperliquid's token, right? Arguably, Hyperliquid is probably the most successful outside of Binance, successful play in the entire crypto industry so far. Just like any other tokens, right? It doesn't really gives you a claim on the revenue or anything, so people just still trade it, right? And it goes up and down depending on sort of the sentiments of like how Hyperliquid is doing. Would it stay that way? Who knows? So I think, to me, that's still a meme, right? It doesn't, I don't get a dividend. They may buy back the token, so it kind of acts as a quasi-dividend until the next Democratic administration comes in and quashes it, and then, it loses 80% of its value, right? So I think there's a lot of risk around that people don't think about. So yeah, I'm not super bullish.
Yeah, so I think about the bids that come in for tokens, and I think to a large extent, actually, prediction markets have been negative for the altcoin bid, just because it gives people a more direct view to sort of gamble and entertain themselves and take the place of tokens. And so if I look back at 2025, we had 50 billion in inflows to the ETFs from mostly institutions. And so if tokens are going to survive, the next 10 years, I think we do need an institutional bid, and institutions just underwrite, investments in ways that retail does not. So, they invest in equities, they structure credit, and those agreements give you protections for, what happens when there's a wind down, who owns the IP, who has a claim on cash, and that's not a question that tokens can answer across the board. So we have this setup with the Labs Co that helps develop the protocol, and then the protocol provides the service, and the foundation supposedly manages the treasury, but we actually don't know who's entitled to cash flows and who owns the IP. And we're seeing super public fights going on, whether it's Zcash or Aave, about who owns what, and institutional investors are standing on the sideline I don't want to get involved with any of that clusterfuck. And so I don't think that they will get involved until we can bring some clarity to the property rights related to tokens. And so the Band-Aid solutions in the near term are you could self-govern, you could do what Uniswap did and build a fee switch into the protocol from day one and be very explicit. But I think the real solution comes from getting the market structure bill passed so we can get some property rights established for these tokens.
Yeah, I think that's a very great question. Actually, I think a few years ago, we haven't saw, or right now, we haven't seen a very successful company who have both launched tokens or go to the equity IPO round. But recently, some companies actually came to us. They are thinking about how can I just launch the token, have TG, and then I wanted to do both within the IPO round. So the question is not about if you can do both. It's more about how to satisfy both your equity investors or token investors, your community, because the question is more kind of if you have your revenues or you do have your fees, how do you going to kind of make your fees distribute to your equity investors or token side? So we haven't seen a very successful case, but I think in the short near future, that will be more and more successful case study will be kind of happening. Yeah.
Can I add one more thing?
Sure.
So this is on the spicy side, right? I mean, my colleagues here, we invest in a lot of early stage companies, right? I think what's happening beneath the surface a lot of times with tokens, because there's no legal precedent on a lot of this stuff. You have no claim, right? We or I have seen a lot of bad behaviors, even by good researchers, right? So what happens is that token launches, they are the only ones who actually know where the token is going. So there's a lot of insider information. Their stuff is locked for 4 years. I mean, I've seen founders, and these are very credible founders that some of you guys may know. They would go to market makers, they would dump majority of their locked tokens. They'll do a deal, they'll take a 50% discount, and they're done. And then they've essentially quiet quit for the next 2 years. It happens a lot more than you think. There's no law against this. They can't get sued. No one wants to sue them. So it happens so much that it doesn't see the light of day. So I think the incentive is broken because it's legal and no one calls them out. So I think that's the crux of it.
Yeah, I think we see a lot of this. A common example is Curve. I mean, there's controversy.
That's the least of it. I've seen worse stuff than Curve.
Yeah, locking up or taking loans out on locked capital. So, and then speaking about kind of equity versus tokens. So I want to hear your thoughts on what exits look like now. Are we moving more towards kind of acquisitions, M&A style, and IPOs? That seems to be the direction. We can start with you, Haley.
Yeah, I think for the acquisitions, I think for general VC and Easy Labs is kind of different because we do have our own ecosystem. So we do we own kind of very large distribution channels. So so in terms of some strategic investments, sometimes we'll check out some banking solutions or some on-off ramp or some kind of license issues. So, and also for the payment stack, we've seen some, like payment industry is very fragmented. Not only the fintech side, but also like the Web3 side. And also it's like very related to local rails or relationships, some government relationship, etc. So we do see some very boutique business company in this space that maybe have some synergy with our like products. For example, we do have our Binance Web3 wallets, we have Trust wallets, and also the Binance.com side, and also the BNB chain. And also within the BNB chain, we have a lot of like DeFi protocols involving. So there's a lot of like potential strategic investment or acquisitions opportunities across this space that we are very interested in. But also like for the IPO, like pre-IPO companies, it's also like very strategic. For example, like when we invest in Bigo, we see like Bigo very successful like protocol that have a lot of initiatives across the ETF. Because BNB previously, we don't have a lot of like US exposure. Most of holders, they're like primarily like across the APAC. So starting with this year, we've seen like the US exposure to the BNB is increasing. And also BNB ETF, BNB DAT launching will kind of like increase the whole exposure to the United States audience and also across Europe. That's kind of like a very exciting like direction we are checking as well. And also some IPO opportunity that we see maybe have like some long-term like developing opportunity. Especially within the 1 or 2 years. I think like DCG is a parent company at Grayscale. I think they're going to have like IPO soon. Yeah.
Not allowed to comment on that.
Yeah. So yeah, maybe you can.
Yeah. So I think it's funny how the the flip switches between being interested in tokens versus equity. I was at this fund called Liberty City Ventures the past 6 years before I joined DCG, and we only did equity investments in blockchain companies. And everybody thought we were crazy because before 2025, the public markets were essentially closed to any blockchain equity outside of Coinbase or mining companies here or there. And now the data on the field for 2025 shows that M&A went from 1 billion to 20 billion, and IPOs went from essentially 0 to 5 billion. And so we had 26 million in exits in 2025. And I think that's going to remain the same until we get some clarity on the digital property rights for tokens that we talked about earlier.
And Waiki, did you have any additional thoughts? Or okay. So moving on, I wanted to speak about another kind of controversial point in crypto venture capital: digital asset treasuries, DATs. So what do you each think went wrong, and what would it look like if they were correctly structured? Waiki, we can start with you. I know we were looking at some of these deals over the summer.
Yeah. Where did it go wrong? I think inherently, what worked at MicroStrategy is a unique set of ingredients. I think not the least of which is it is Bitcoin and there's a Michael Saylor attached to it. It's really hard to say how much a Michael Saylor in this case actually kind of proved the crucial difference. But I will say one thing, we have looked at a bunch of these things, right, in the last year. I think what I'll say is the inverse, which is there's always a way to find a DAT that will absolutely fail. And the way to see it, the first tell is the guys who are doing it, the lead guys, they're part-timers. They have real jobs elsewhere. And so this is their I wouldn't even say their lottery ticket. This is essentially their side gig. Those, so we've seen a lot of those, right, in the last 9 months. Those will absolutely not succeed. And they've proven to be. So, last thing I'll say is that, kind of that in ETH, for example, or Solana, match a micro strategy ultimately. Maybe if done right. I don't think the book is fully closed yet. We'll see what happened to Forward and Bitminer.
Yeah, I think what actually happened is really simple. Prices went down, and these are very reflexive vehicles. And so, when times are good, you can issue equity at a premium to NAV, and you can issue cheap debt, and you keep the party going. But when prices go down, the exact opposite happens, and prices went down in a big way, and then people discovered they weren't Michael Saylor able to issue cheap debt even in a bear market. And so that's number one. Number two is that we just completely oversaturated the market. I don't think we need like the seventh DAT for Bitcoin unless you're employing a like novel geo arbitrage strategy like Metaplanet did in Japan. And I don't think you need a DAT for like the 28th asset in market cap or for a token that's pre-launch. And so I think we just completely oversaturated the market. And then what could fix this? I'd say like, since right now it's like DATs are completely synthetic exposure to the underlying with no actual like business model in the DAT for the most part. Maybe like say you're creating a DAT for a decentralized compute network that provides raw compute. Maybe you want to, as a DAT, offer some value-added services that are accretive to the network, like model hosting or fine-tuned services that drive value to the network, drive value to the token, which you are, leverage synthetic exposure to. So I don't know, maybe.
Yeah, I think like MicroStrategy is more kind of a leverage product that we're seeing like prices dropping. It's kind of like a double kill at this moment. So the MNAV is dropping because the Bitcoin price is dropping. Actually, Bitcoin price like dropped like 30 to 40%. And also like MicroStrategy is down like kind of like 70, which makes sense. And also people's kind of like expectation, like, and also like the it's also like kind of like double kill on this stage. But we think that MicroStrategy is actually doing a lot of like innovative stuff in this at this moment. For example, Stretch STRC product is kind of like an iPhone moment for Bitcoin credit. I think the company is doing something like very meaningful, like actually bridging between the traditional finance space and DeFi space. For example, it provides like the portfolio managers with a very great product for them to kind of having a kind of like risk-free product for them to have access to Bitcoin yield up to like 11%. And so we've seen, we've incubated a project called Saturn on like over our last season, like season 2. They're building a DeFi product which bring STRC product on chain. So we think this kind of like innovative solution actually will kind of like bring MicroStrategy in a more sustainable way, because actually a lot of like DAT company we think like makes sense will be those like blue chips and also the top one player in this market. So for otherwise it's kind of like I would call it traditional memes or something. Like previously over the like a year ago, it's like becoming really like competitive and very vibrant. But right now it's like all going down. But I think fundamentally, if like the product is going to launch within the traditional side, and we've seen a lot of traction for STRC products. So in the future, when those companies are going to build like the intersection on chain and bring more liquidity between the on chain side and also the the traditional finance side, I think that will be a very exciting like sector we've seen in the short near future.
Yeah, I'm fascinated by some of these STRC style products where they're like perpetual fixed income offered as an equity, but I think I definitely have some concerns as well. And then I wanted to see with each of you, where do you hold the most conviction right now, and are there areas you're actively avoiding? We can start with you, Market.
You mean what?
What kind of products, protocols?
Yeah.
Pretty specific.
Oh, that's a good question. So I think one of the best quiet things, relatively speaking, that's kind of happened in the last year or 2 years is, which I think is a huge value add to everyone sort of in the markets, right? Crypto or TradFi is the ability for traditional assets to trade 24/7, right? So what Hyperliquid has introduced with some of the indices, with Brent oil, crude oil, WTI, and stuff like that, right? It allows for sort of price discovery. It's far from perfect, right? I was just checking on the price this morning because of the Iran talks fell apart last night. There's no other place on Saturday morning or afternoon to actually see how the market reaction is. You gotta wait until tonight, right? So a lot of people use this to kind of figure out on the weekend. So I think that's a huge revolutionary shift. So I'm a big fan of areas where crypto rails can actually bring some of these quiet but big changes to TradFi assets, right? And kind of push the envelope. So I'll give you a more specific answer. So there's a company out west called Pax Markets. So they're building something that's really interesting. Essentially, it's an exchange on a chip. They build it on an FPGA chip. So what that means is that if you want really, really fast transactions, as in like HFT type transactions, this is the only way to do it. And if you're running some very algorithmic automated trades, this is the only way you can actually get the best edge. And it's really interesting because they have the market networks, they have the market effects. You've got a lot of the market makers and funds would be like, well, if my competitors are going there, I have to go there as well. I thought it was really interesting dynamics, but these are some examples.
And is there anything you're actively avoiding? Maybe things you think are overhyped, overfunded?
Yeah, I mean, anything token related or meme coin related.
And then just for the final responses, we only have about 3 minutes left, so we'll keep them a little more brief. We can continue.
Cool. Yeah, so I guess the Citrini paper has me thinking a lot about AI resilience and staying up late and thinking about how do I not get replaced by AI. So when I think about my thesis going forward, I think about everything in the context of, what's durable as AI starts to penetrate more and more of human capacity. And so, like, the themes I'm looking at are, one, misinformation. AI brings the marginal cost of content creation down to zero, which makes fraud and misinformation really easy to produce. And then we have social media, zero marginal cost of distribution on your misinformation. And so people are really looking for a signal of truth. And to that extent, I think information markets, prediction markets continue to be one of the best use cases of blockchain. Not only do they surface truth, but they're really easy for someone to understand. It's simply understanding a probability across time. And so I'm looking for novelty at the edges. I'm looking at horizontal layers on top and below. I'm also looking for things that can help with data integrity, using blockchain as a audit trail for data provenance. Also looking at where are differentiated sources of data that AI can't easily replicate. I think this is where deepened networks come in and create robotics data sets, precision GPS data sets that is just impossible for AI to replicate. And I guess the last thing within that theme is probabilism versus determinism. Obviously, AIs are probabilistic. Smart contracts are deterministic. And so what platforms and solutions can we build to give AI guardrails in critical industries leveraging smart contracts? And I guess what I'm staying away from for now, and I'm willing to re-underwrite this at another time, but right now I'm staying away from agentic payments just because I'm not really seeing why it makes sense for someone to beat Stripe right now if all we're doing is aggregating X402 and like all the emerging rails, especially when Stripe just came out with MPP a couple weeks ago, which could aggregate X402 as well. So I've not seen a clear reason for why any of these startups should win. And so that's sort of a space that I'm actively avoiding deploying dollars into today.
And with just a minute left, we'll finish with you, Haley.
Yeah, so I think over the past like few cycles, we've seen like very successful cases happening like stable coins and exchanges like trading infrastructure and also the chain infrastructure. So I think in the short near future that we also like seeing from our end, we've still like looking a lot into the trading side. So I think like for the Web3 infrastructure, it's more about like creating new assets, issuance new assets. For example, over the past few years, like in terms like NFT cycle, like DeFi summer, and also the meme coin seasons, it's more about like, or like you can see some Bitcoin inscriptions, something. It's more kind of like bringing like new assets generated for people to trade. And once new assets are issuance, they always like different marketplaces or trading infrastructure to provide a place for people to trade. Which we can see, different perp dexes, like AMM pools, different kinds of AMM pools or DeFi protocols embedded that. So from our end, we wanted to see more kind of like new assets. For example, if we see prediction market, mostly right now the top ones are order book based, like Polymarket, Kalshi, Opinion Labs, Party.fun. But prediction market right now is only like very regulated in the States, like got the CFTC license. But a lot of like countries, actually, they will kind of like label it as a gambling. So for example, largest users, like Chinese users, they cannot play prediction market because it's like strictly banned from the government. So we've seen some new kind of sort of places for people to trade. So some protocols are building bounding curve AMM-based prediction markets, which can generate event means for people to trade, actually like meme coins, but actually it has like resolution in the end for people to like acting as a prediction market. So that's something we can see it's like a new assets and it can bring like more people to experience the new product. Yeah, so I think in terms of like the building the next financial trading engine, we've seen technology is evolving. For example, like BNB ecosystem, we also wanted to see more infrastructure protocol that will help to bring this like trading infrastructure to the next level. That's why we also see potential invest opportunities across prop AMM, and also some dark pool embedded solution for people to better trade, and also some better trading terminal. For example, we just invested like Genius terminal, and also like to be like more broadly, like more and more like application can be built within the new infrastructure, like different payment solution. Like I think agentic payment right now, and also AI, and also across the crypto space is going to be a next narrative we've seen for the next cycle. And also for not only within the AI payment side, but also we've seen some new tokenized like on RWA, like tokenized equities. We've seen that every like big institutions or big players are gonna to build it in-house. We've seen ICE just is strategically invested on Polymarket and OKX, and also together they are building some tokenized equities. And we've seen like Binance.com maybe like building some in-house and bring more like, I think like a lot of like big whales, they're holding like stable coins, and also they wanted to have a place to directly buy tokenized equities. That's one of the biggest application that we've seen. And also like trade.xyz, they're bringing commodity and some gold perps, like bring more people to better trades. So I think in the short future, there will be more and more kind of like very interesting applications building on the new infrastructure that we are very excited to see. Yeah.
Great, thank you. We'll wrap there, and then if there are any questions, we have a few minutes.
Hey, how's it going?
I'm curious in your thoughts about like investing into AI agent companies, kind of like DAOs around these AI agents that provide services.
Yeah, I think I can start. Yeah, so are you more referring to some like AI DeFi agent or something, like help people to better trade, or like, yeah, so I think from our end, actually, it's kind of like a very difficult case that we wanted to invest because we've been talking to different like DeFi agent helping people to trade or gain very great like quantitative trading strategies or something that we found most of the very talented like trading companies, if they have very alpha strategies, they wouldn't share this kind of like to retail users actually. Because more and more people, if they're using these agents, using their strategy to trade, the lucrative, like those kind of benefits will kind of like disappearing. So if in terms of like providing a like better strategy to help people to trade, we think that's kind of like dilemma. But I think with AI like embedded, we are more checking about agentic payments because that will like make more sense. For example, a lot of like agents or they're gonna to call from the web, like web to web payment, and also some X402. They can help with the settlement, and we've seen some Perkel also building the risk layer to help the know your agent sort of that stuff. That will like make it more sense. Yeah.
Yeah, I guess maybe I can provide a little bit more color on why I'm avoiding agentic payments for now. I've looked at all the companies that are on the leaderboard for X402, and the go-to-market motion seems to build to provide access to X402 in an easy way, and then wholesale access to proprietary centralized models to get the flywheel going. I've also talked to some of the companies that have raised tens of millions of dollars to aggregate the payment rails. They're also having problems with adoption, and so they're trying to build marketing agents or ops agents on top of the payment rails to drive volume. And so I think we'll see a lot of these companies pivot into sort of application companies. And I do still continue to think that the winner of aggregating the rails is probably going to be Stripe. So it's still a segment that we're avoiding, but continuing to map out.
Yeah, we can take the next question now.
I was curious, are you noticing that capital is largely flowing between AI, crypto, and biotech and robotics to some extent? I know you guys mentioned, or are you noticing that there is new capital coming into one location that's displacing capital moving from one to another, if that makes sense?
I'm sorry, can you repeat the last part?
Are you noticing that capital is flowing between robotics, AI, biotech, crypto, kind of these bleeding edge tech areas, or are you noticing that one is having new capital come in as capital is moving out of that location to another?
Are the capital sloshing between these buckets, or are they new capital coming in? It's the question, right?
Yes.
It's definitely a lot of, I think there's a lot of retail money. I think there's a lot of hot retail money that that does the rotation. I think the net new money, the institutional money, I think you see a lot of private credit going into data center bills. You see a lot of Middle Eastern or sovereign funds going into a lot of the big data center as well as the big foundational labs and some of the infra guys. Yeah, but I think definitely for the hot money, the rotation between meme coins, AI trades, I think those exist, and there's quite a bit of it, right? That's my take.
And then we have about 30 seconds left for the last question.
I'll try to make it quick. Stablecoin has made a lot of inroads in industry the past few years. Would you say the ship has sailed, I guess? Is there anything that you're interested in there, given the success of Paxos and the failure of Fortress and all that?
Maybe we can take a response from Mario on this one.
Yeah, so we're in a place with stablecoins where there's technical maturity. You can move a dollar for less than a penny in less than a second. And there's also regulatory maturity here in the US. Now we have a federal framework for moving money along these rails. And so what's left when you can't really differentiate on technology and you can't do regulatory arbitrage is distribution. So I do think that the advantage is to the incumbents in stablecoin specifically, but I'm seeing lots of experienced Web2 fintech founders enter the space, recognizing that a lot of the infrastructure has been built and are going to market with a maniacal focus on distribution and accessing it. So whether that's something in like payroll or private payments, recognizing that blockchain payments are transparent by nature, and so I see novelty around the edges that I think is still investable.
Great. Thank you all for joining. Appreciate it.
Okay. Thank you to all our panelists. And now we will have a short break and return in 5 minutes. Welcome back, everyone. Sorry, we're about to start. Welcome back, everyone. Please welcome Nadav Kohen with his talk, Nested Signatures on Bitcoin from Music 2 to Iceberg. Welcome, Nadav.
All right. Hi, everyone. I'm Nadav. I'm a cryptographer at Chaincode Labs, and I'm going to talk a bit about the research I've been doing for the past few months, specifically about nested signatures. So first of all, just kind of to give an outline, last summer I helped run a little educational program for open source Bitcoin developers to teach cryptography. It was also secretly my excuse to learn cryptography in a lot more depth. I had just finished my math PhD, and that led into my first bit of work, which I'll talk a bit about today, on nesting Musig inside of Musig. For those of you who might not remember, Musig is a key aggregation protocol where many people having their own keys can come together and compute one aggregate key for the group, and it allows them to produce signatures for that aggregate key if everyone cooperates. And then nested Musig is, what if one of those participants, one of those keys itself is actually multiple people? So you kind of have this property that any key, hopefully, ideally, kind of represents any policy and actually is indistinguishable from just a single person. You don't know if it's more underneath. And then there are two more pieces of work I'll mention today, which involve threshold signatures and nested threshold signatures inside of Musig, which unlike Musig, everyone has to participate. It's only for n of n's, whereas threshold signatures are the thing we're more used to calling multi-sig in Bitcoin, which is your 2 of 3s, your 3 of 5s, your t of n's. So first of all, just wanted to shill CryptoCamp because the documents are publicly available on GitHub. It's a little unpolished, it was a bit rushed, but if you are kind of more technically minded and you wanted kind of an introduction to cryptography that is a bit more suited to like someone who's a Bitcoin developer type, then we have these documents here. You've got these PDFs that I wrote that also link to other readings. We start by just talking a bit about like some encryption schemes and what security looks like. And by week 5, we're talking about Sigma protocols and digital signatures. And at the end, you can see that there's like a little reference Musig stuff and some other kind of more advanced things. And this led to kind of preparing people for this workbook that Jonas Nick over at Blockstream Research produced that kind of is a bit more structured, a bit more rigorous, but maybe you want to spend many weeks ahead of time preparing for such a feat as working on that workbook. But anyway, if you go to GitHub, you can find, if you search cryptography-camp, that's the organization, the pre-work, and the workbook. Just figured that this might be a crowd that's interested in this kind of thing. So just so you know it's out there. I have plans on maybe working a bit more on the pre-work to improve it in the future. So if you have feedback, let me know. But OK, let's talk a bit about nested signatures, kind of zooming out. So aggregate signatures kind of ask the question, what if a public key was actually the aggregation of multiple keys? And then multiple people can work together to produce signatures for that key. And this kind of looks like this. You have these participants. They have their own keys. There's some aggregate key. They work together to generate messages for the aggregate key. And then nested signatures asks the question, what if a public key was actually the aggregation of multiple keys aggregated from multiple keys, aggregated from multiple keys, aggregated from multiple keys? Anyway, so kind of these individual keys, unbeknownst maybe to each other, are made up of multiple participants. This is what I mean when I say nested signatures. So why would you want to do this? One use case is that, say this top level, I know it's 3 keys in this picture, but imagine that it was 2 at that second level. Say that it's a lightning channel, or maybe this is a channel factory or something like that, or some other Bitcoin contract, which oftentimes get executed as some multi-sig with a bunch of people and a tree of pre-signed transactions. So imagine that this is some kind of lightning channel-like construction, but it kind of forces the individual participants to have these online keys that store potentially large amounts of money, and it's kind of difficult without introducing a bunch of complexity into those protocols to enable the kinds of key management that we're used to having in Bitcoin. So what nested signatures let you do is you could say have a 2 of 3 actually representing your 1 key in this multi-party protocol. But you know, it's not too hard to write down a scheme that lets you do this, and it's significantly harder to write one down that is secure and doesn't have any attacks. So this is kind of the work I've been working on. And the question is, how do we sign such that it's secure? So what are some new challenges that we don't have in just the normal signature setting? Well, for one, we aren't just generating partial signatures. We need to generate all of the protocol messages for the top level. So like if we went back here, there's a protocol at this level for how these people interact to construct signatures at the top level. But people 1 level down here, they don't just need to produce partial signatures at the end. They need to produce every message that this person is actually emitting. So MuSig is a 2-round protocol. That means they have to produce kind of more things, but if you wanted to nest inside of a more complicated thing, you have to generate more than just partial signatures. You also need to embed your nonce hashes somehow inside of the upper level nonce hash, which is kind of one of the bigger challenges on a technical level. You need to be compatible with top level parameters and optimizations. So if the top level is hyper-optimized, makes a bunch of design decisions, you have to live with those at the bottom level, and it can constrain you quite a bit. You can't just add more nonces, for example. And you also want to avoid things at the top level that are hard for a group of people to emulate a single person. So proof of work type constructions, that kind of thing that might work if it was an individual, don't work so well if you want to have nesting enabled. So this is the part of the talk where I'm about to flash some scary math on the board. Don't let your brain react too quickly. We're going to be ignoring most of it. I just wanted kind of a prop to point at, so I stole some figures from some papers. That's your trigger warning. Okay, so this here is the figure of the MuSig protocol that I stole from their paper. And I will kind of highlight the important parts, how to read this. You can ignore everything up here. Here, the first round, what you do is you just generate a nonce. It's actually a list of these nonces, and that's what the first round is. You just generate a bunch of randomness, R for randomness. Then that stuff gets aggregated, and then in the second round, you have this nonce hash, which includes all of that randomness, the aggregate key, and the message. And then that is used to compute your aggregate randomness, and then you use that to sign. Okay, to highlight the differences, over here on the side, I have nested MuSig. So almost all of it is the same, was the main thing I wanted to point out. We don't have to go through all the things that it does that are the same, but it does a bunch of things that are the same. I've kind of highlighted the differences. You'll notice this is like exactly the same. Nothing's changed yet. The first difference is up here. After you're done with the first round, you don't just take this kind of list of lists. You have to aggregate them so that you look like a single list for a single person. And that involves the nonce hash for the lower level. So this is what I was talking about earlier, where the main technical challenge is that we have to embed the lower level nonce hash into the higher level. That is where this happens, and annoyingly, this happens during the first round in the nested level. And this is kind of a problem because if you look at a signature scheme like Frost, for example, and most threshold signature schemes, have to commit to the set of people who are going to sign in the second round. So in the first round, you can pre-compute a bunch of stuff, and only in the second round do you need to know who's signing, because they don't need the nonce hash yet. But when you're nesting, you need the nonce hash in the first round, and this becomes a problem because you have to guess who the signer set is going to be and fail everything if some of those people are offline later in the second round. Yeah, and then basically how nested musig works is you just take the product of your nonce hash, the level above you's nonce hash, so on and so forth. And since you embedded your nonce already, nonce hash, everyone else also computes the same product, even though they don't know that that's what they're doing. That was all very technical, and I'm going to skip that thing. But just to kind of reiterate at a higher level, what this kind of implies is it is possible to write down what it would look like to nest something like Frost, which is fast round optimized Schnorr threshold signatures. So again, that's just a fancy way of saying I have many keys, I'm aggregating them, and it's a threshold that's required. So not necessarily everybody needs to be involved. So you can nest that inside of musig, but the nonce hash commits to the signer set inside of Frost, and so that causes a problem because that means that it basically is not a pre-computed first round anymore, and even worse, because musig has a pre-computed first round, actual protocols in the wild like Lightning, which are going to be using musig, treat it as a pre-computed first round. So you can't actually nest Frost reliably without having restarts mechanisms inside of something like Lightning. So this led me to ask the question, is there a Schnorr threshold signature scheme that does not commit to the signer set? And there is. There's this lovely paper. It's actually the same exact authors as the Frost paper, the original Frost paper. And it's called Arctic, so it's on theme. And it also produces Schnorr threshold signatures, but it uses kind of a different mechanism. So Frost uses Shamir secret sharing, of course, you may have heard of it, for the keys. But for the nonces, it just has everybody generate randomness in the first round. And then in the second round, once you know who is going to sign, you take only those people's randomness contributions and add them together. And the idea in Arctic is that actually I want the randomness to be a shared value in the same way that the keys are. So I want some mechanism where the threshold, if I have some threshold of people, I can compute the same nonce. So I have some fixed nonce that is secret shared amongst the participants. And this means that I know what my aggregate nonce is ahead of time in the first round, which is not true in something like Frost, where the aggregate nonce actually changes depending on who participates in the second round. But okay, so yeah, the pros, it's still a two-round signing scheme, so that's good for latency. It actually has quite a bit of deterministic stuff going on with pseudo-random functions, and so it's stateless after key generation, which is also just really nice. And one of the primary kind of barriers to implementing Frost in practice is that you have to keep those first message randomness pieces around. And they're also like kind of toxic material. They're secret. If someone learns that information, then you could be leaking your private key. So that is avoided in Arctic. You don't commit to the signing set, so that makes it kind of optimal for nesting, which is what I was interested in. And their kind of structure of it, it almost looks in terms of how it actually functions inside of Arctic like I'm creating a bunch of secrets, distributing them amongst my signers in a replicated fashion. So for example, if I have Alice, Bob, and Carol, I create one secret that I don't want Alice to know, so I give it to Bob and Carol. I create one secret I don't want Bob to know, so I give it to Alice and Carol. And I create one secret that I don't want Carol to know, so I give it to Alice and Bob. I now have 3 secrets. Each individual is missing at least one of the secrets, and any 2 of them together know all 3 secrets. So what I could do is I could imagine doing something like doing a musig, which is an n of n, on these 3 secrets, And I've functionally created a threshold signature scheme because any two of them know all three of the secrets, so they can kind of generate what you need for MuSig. Now, this isn't exactly how Arctic works, and the scheme I just described actually turns out to be insecure, so be careful when playing around with these kinds of things. But it's like almost right, so I kind of was like, it almost looks like I can reduce the security to MuSig. So that'll come back up later as a pro. Cons, it only works for a small number of signers. So the way that Arctic works that I just mentioned, where you generate a bunch of secrets, it actually requires more and more secrets the more people you have. If I have 3 people, I only need these 3 secrets. But if I have like 10 people, I start to need like hundreds of secrets in order to get the policy correct that any 5 of them say know all of the secrets, but any 4 of them are missing at least 1 secret. So the combinatorial explosion that you get there kind of only makes it good for a small number of signers. Luckily, I mostly care about situations with not that many signers. Most key management kind of protocols in Bitcoin don't require more than 10 signers. So anything like less than 20 is practical. Anything less than 10, I think, is perfectly fine. But this is kind of one of the major drawbacks of Arctic. And then the real major drawback of Arctic, the previous work that I mentioned, is that it requires an honest majority. So you can't do 2 of 5. It has to be like higher threshold. You need more honest parties than dishonest parties participating at any given time, which is a major drawback. You also, it is stateless after keygen, but there is this less toxic than secret material kind of session identifier you have to keep track of if you want to use Arctic without knowing what the message is in the first round. We don't have to talk about that too much. But okay, I set out to kind of pursue this idea that what if I got something that I actually could just reduce to MuSig, because I've already just shown you that I worked on nested MuSig, and I have a security proof for nesting MuSig inside of MuSig. What if I could just do a nested MuSig, but at the bottom level, it's actually this replicated threshold idea? And maybe I could also get rid of this honest majority assumption. And so the way that the honest majority assumption is required inside of the original Arctic scheme is it's required for verifying that your randomness was included in the nonce generation for the aggregate nonce. And there's this cool thing about MuSig that you don't actually do this step. There's no kind of analogous thing. The way that nonces get computed inside of MuSig and inside of Frost, they kind of use the same mechanism that was invented to prevent these other things called Wagner attacks and Ross attacks. But it just so happens that when you do things this other way that these other signature schemes use, you don't have to verify nonces. You are secure even if you are given adversarially constructed randomness, because you still kind of are using hash functions and protecting yourself. And it's a little complicated exactly how this works out, but it does. And so as I mentioned, what if we did kind of a replicated secret sharing on top of MuSig? This maybe wouldn't require an honest majority because MuSig doesn't have to verify the nonces. So basically the idea is, what if we took Arctic, but rather than just generating one nonce and doing all of this verification using an honest majority, we instead made Arctic look a lot more like MuSig 2 and try and get a security reduction to just MuSig 2, or in the nesting case, to nested MuSig 2. This would both give us something that works in the nested setting and something that doesn't require an honest majority because we got rid of these verification steps. And getting rid of the verification steps also means that it's faster to actually execute because you don't have to do these verifications. The downside is that it does require more nonces. And this is not actually practically an issue for just using it as a threshold scheme. But if you want to nest inside of MuSig, you don't get to choose how many nonces you have. You have to use the same number as above. So currently, there's a BIP 327, which specifies MuSig 2, like a full implementation. And there's an implementation in libsec P256K1 that you can use for MuSig today. And it uses 2 nonces, which is not enough to actually run this version of Arctic that I'm thinking of calling Arctic 2 in a nested fashion. So it would require like a change to use Arctic in this way. Now, I'm calling nested Arctic Iceberg. I haven't published the preprint, so if people don't like it, let me know. But I figured I'd stay on theme with Frost and with Arctic, and it's nested, so you can't see everything below, so it's the tip of the iceberg. So iceberg is if you have an honest majority inside of specifically a 2 of 2, and you have a state agreement protocol, so this is basically, I'm thinking about Lightning Network specifically, then I have this nice solution where you can nest the original Arctic work inside of the MuSig implementation people are actually using. This is great for Lightning channels. Otherwise, if you don't have all of these things, you can still do nested Arctic 2, but it requires that at the top level, they're actually using more nonces. That is kind of the trade-off for how the research is going so far. But to my knowledge, this is the state of the art for what we can actually accomplish in terms of nesting threshold signatures inside of multi-signatures. And that is my talk. I guess really quickly, I am I'm helping organize Bitcoin Research Day this year, which happens later this year at Chaincode. And we are looking for nominations for the Bitcoin Research Prize, the Bitcoin Research Prize. So there's a Google form where you can nominate a piece of work. It has the criteria and stuff there. But if anybody has any suggestions for our consideration, please feel free to look at that. But that's the end of my talk. Thanks. And if there are any questions, I just spoke a bunch about some kind of technical stuff, but happy to, yeah.
In a signer said you always know what nonces should use. Like, how does your scheme prevent nonces?
Sorry, so you're asking, I missed the beginning of the question.
You mentioned in Arctic, even a signer said you always know what nonces use, but how do you prevent nonce reuse?
Yes, great question. It's kind of complicated, but yeah, it's a little complicated. The preprint should be out next month. The short answer is like, we limit the amount of functional nonce reuse that the adversary creates, and since no individual person is reusing nonces, we can make sure that the adversary doesn't learn any information from the thing that looks like reuse that they can cause. So it's not a very straightforward answer. But that is the primary problem that needs to be solved compared to the kind of naive approach that I described.
Do you have a use case in mind for threshold lightning channels? That sounds cool.
Yeah, I think the main use case I had in mind was just like key management. Like, it's kind of scary if you're running a bigger lightning channel that you just have this hot wallet. And it would be great if you could have like 3 of 5 where some of the devices are offline and like, in a safe somewhere or something like this. And don't have to come online except for in emergencies kinds of situations for backing up secret material for lightning channels, for signing specifically. That was kind of the main motivating example that I had in mind. But I imagine that it's also interesting maybe for like, I don't know, a corporate governance type of structure for a lightning node operation, or maybe there's some kind of LSP that can help you run your lightning node or something like this, but I haven't delved too much into it quite yet.
Does this work inform PTLCs in any way?
Say that one more time.
Does this work inform or interact with PTLCs?
Does this interact with PTLCs? Yes. So our end goal is to also kind of give an analysis for what this looks like with adapter signatures. We have a path forward for how that will work. We're confident that it should enable, or because right, since Lightning was our motivating use case, and I'm a big proponent of using PTLCs on Lightning in the future, we definitely designed it with security with adapter signatures for PTLCs in mind. So the individual side of the channel will be able to produce adapter signatures.
Sick.
Yeah. Yeah. Cool. Well, thanks so much, everybody.
Thank you, Nadav. Now, please welcome Frank Korba with his talk, Why Advocating for Bitcoin and Freedom Tech Matters. Welcome, Frank.
Maybe start mirroring. Okay, and slideshow. Quit. Okay. No. Oh yeah, I think it works. Let's see. I think. Oh yeah, there you go. Can I check if the? Okay, there we go. I don't want to give away my first slide there.
All right. Thank you to everybody who's still here. I know that towards the end of these conferences, we can get tired. For someone like me who's not super technical, I get tired towards like the first 20% of these because I'm trying to process information that my brain normally doesn't process. But before I get started here, I want to extend a deep thank you to all of you who are still here, to Neha, to the team here. I'm not a very technologically minded person. I'm about to give a talk at MIT on Bitcoin. It's not really a great way to preface a talk, but I say it because I have great admiration for the people who are technically minded. I write features on them frequently. I do the best I can to understand things. I luckily had a good colleague named Shinobi at Bitcoin Magazine who helped me to understand things and to distill things. So first, just want to say thank you to anyone here in the audience and to all the people involved who are technical and who are facilitating this technology and building this technology that people around the world are depending on, some of the technology that I'll talk about here today. I also want to contextualize what I'm going to talk about. I saw this tweet from Rene Picard, who I believe works on Lightning. The sad truth, we don't want to hear. Bitcoin is far from being perfect. Yet, after 3 months of sabbatical and seeing some stuff, I believe more than ever that Bitcoin is the best shot we currently have to fix some of the mess in the world. I thought that captured things pretty well. Bitcoin is not a magical wand that we wave over things and they automatically get better. Bitcoin itself needs improvements. We need different layers. We need changes to the base layer and different things to help make it better and more usable. But I agree with Rene. Because of my background, which I'll talk about in a second, I've worked for major institutions like the United Nations, major universities, things like that, and I've never found something like Bitcoin that I've seen have such a catalytic effect on communities around the globe. So if you don't know me, my former position, I was the White House correspondent for Bitcoin Magazine, as well as their political correspondent, so I corresponded both with the Trump administration and with other world leaders. I also covered the samurai. I wish I had a better picture of myself. Not looking too good there. That's a screenshot from a video that I took this summer in front of the courthouse in the Southern District of New York. I covered both the tornado and samurai cases because I think it's what's going on right now with privacy, whether or not we're permitted to have privacy as we transact, which I believe we should, and luckily, which Hester Pierce, I think, also mentioned we should. I believe it's really important that we show up and advocate all the way up to the federal government level, which I did, but also that we're there for the developers, physically there for them. And I know not everybody can do that, so I'm going to talk about advocacy kind of a step beyond that. But if you do want to follow some of the advocacy I do, I will share some of my socials and all that kind of stuff afterwards. So I want to go back a little bit before I found Bitcoin. A lot of my work was humanitarian work, everything from working with the UNICEF in Namibia and their Ministry of Education, working around the world. I would say there's two things I'm going to highlight here. I feel like the world prepped me for Bitcoin before I knew that it was prepping me for Bitcoin. I ended up living in Ghana because I was the waiter for the person who invented mortgage-backed securities. Do we all know what mortgage-backed securities are? The instrument that collapsed the global economy. I had left an old job, I didn't have any money. I started waiting tables. I became the waiter for Lou Ranieri. He's featured in the beginning of The Big Short. and he said, I need someone to go to Ghana to help build a trade school for me. Couldn't make that up in a quadrillion years. This was while the financial collapse was happening. So I ended up working for one of the people who helped collapse the global economy, our traditional financial system. From there, I moved to Venezuela, where I lived there at the beginning of hyperinflation and under the Chavez regime. So when people talk about Bitcoin and hyperinflation and under authoritarian regimes, I've lived it, I've seen it myself. I've lived in those environments. I didn't know what Bitcoin was back then. So when I found Bitcoin as an antidote to some of these things in the world, I was like, oh yeah, I've experienced those things. I've seen those things up close. So it made a lot of sense to me. So a little bit of background, just to understand where I'm coming from. So Dr. Adam Back, not Satoshi, sorry New York Times. Dr. Adam Back said there's 2 ways that we have to protect Bitcoin. Build secure technology, which of course is important, but we also have to advocate on the regulatory and legal fronts. And a lot of this was informed by what happened in the 1990s, the PGP wars, the pretty good privacy wars. The government was trying to say that cryptography was a munition. People pushed back. Luckily, because of that, we still are here having a conversation about Bitcoin and freedom tech, much of which is governed by cryptography. But I want to add a third dimension to what I think we need to do, and it's more of a little bit of nuance that I want to add to this advocacy part, this advocating on behalf of the legal and regulatory fronts. So I think there's a different dimension to advocacy, and I think what our job is right now, and this is something that I thought of on my own, but someone that I work with articulated it better than me. Our job includes winning hearts and minds and also raising the moral cost of going after Bitcoin and freedom tech. This is what we now have to do, because some of this is going to be a battle in the media, and right now there's plenty of stuff that's happening. There's all different sorts of crypto scams and other things that can bring negative attention to, I'll say, the broader crypto space, because Bitcoin often gets lumped in with that. But a lot of the work that I think we have to do, and it's the work that I personally do, is making sure that people understand the stories around the world, things that are happening where people need this tech, where it's life or death. And I've worked with some of those people, and I've been in some of those communities. So I'm going to share some of those stories today that have not been shared before. But before we get to that, I want to talk about some of the work that I did do in the space with the government. And I think it's really important that people internalize this. The government is not a monolith. It is not this thing. It's not us versus them. We have to interact with people, because not everyone there thinks, feels, does the same thing. We even see there are certain people in the government that won't follow the talking points, that will step out and do their own thing. And it's important that we connect with those people. And the reason I'm saying that to you here is not to have you guys go out and start getting a job where you have to go day in, day out speaking with government officials, though I know some people do that work here in this room, and I'll shout them out without saying their name, saying that I appreciate that, educating people behind the scenes, and they're doing this all the way down from a local level. We've had people at a Harlem Bitcoin meeting I go to, meetup in Harlem in New York. We've had local politicians come. We've showed them how to use Bitcoin wallets. We've done things like that. And I've personally spoken with the President of the United States about this, and I've watched them sit there and respond and say, okay, I get where you're coming from. I see it, and it's a real thing. I'm not saying they're going to act on it or we're going to get perfect legislation the day after, but a little bit of education, and maybe not thinking that what we're often attributing to malice might actually be a lack of education or a lack of understanding on the matter. So it's how we approach these things that I think really matter. 2 quick examples of that. Representative Keith Ammann in New Hampshire, New Hampshire is the first state that got a strategic Bitcoin reserve for the state across the line, something I'm actually in favor of. He learned about Bitcoin in 2010 at an anarchist meeting. So this isn't like Captain Politics. I profiled him for Bitcoin Magazine. I've become good friends with him. This is like a hardcore freedom maximalist. And even when I spoke with him about the samurai trial, he's like, they should not be on trial. And this is a state-level congressman. Nick Begich was buying Bitcoin on Mt. Gox in 2011. And when I talked with him about privacy and other things, he was serious about that. And Nick proposed the sister act to Senator Lummis's Bitcoin Act in the House. And he hasn't gotten it across the line or anything yet, but I think it's important that people like Nick exist at the federal level, because he doesn't have that same profile as like a Senator Lummis or something like that, people we really associate with Bitcoin, but he is having conversations about why it's strategically important. It's funny, I actually had a conversation, Tim Massad, former CFTC chair, was here last year, and I spoke with him for Bitcoin Magazine. We did an interview over there. Nick said, well, the United States should hold some Bitcoin in case this whole fiat regime falls apart. Tim was like, Nick shouldn't be talking like that. But we know that that's how Nick Begich feels, and it's good to know that there are people at the federal level submitting federal bills that may get passed, that truly understand Bitcoin and, again, have been buying it since 2 years into its existence. Hester Pierce spoke here. I saw her, she had a talk with Ross Stevens, the head of NIDIG in New York, and she started the talk by saying this: I sometimes wonder what Harriet Tubman would have done with Bitcoin. And I thought it was one of the most moving things I'd heard a figure in the space say. And out of all politicians, regulators, et cetera, Hester Pierce, I do get a deep sense of authenticity from. And she said this in the context of the necessity for privacy. She said this is why you need privacy, because if we did have Bitcoin in that time and all transactions could be traced back to activists, people like Harriet Tubman, that would put them in danger. She understood that, and this is somebody that's working in our one of the most major regulatory bodies within the United States. So again, the government is not a monolith. There are people here who genuinely believe in this technology, and it is very important that we engage with them. A quick overview of what we're fighting for, some things that I'm personally fighting for. We want to protect open source developers. We don't want to see any more of this samurai tornado cash stuff happening. It's not good. It creates a chilling effect on technology that we need. We also want to establish a de minimis exemption for spending Bitcoin. So long as people are afraid to spend Bitcoin because of the tax implications, I was just having a conversation with a gentleman outside talking about how we've sort of been coaxed into believing we should just hold our Bitcoin, right? And I think that's part of how Bitcoin fails if it doesn't actually become money that we use in the wild. So I think the de minimis exemption is really big, and I think especially right now, as Block makes this move to have more merchants accept Bitcoin. We want to minimize regulation around open source development, or at least what we see in the Clarity Act with possibly anyone who's not touching keys or creating open source technology that doesn't touch keys. These people should not be subject to any of these laws or regulations or any sort of penalty as a result of people misusing the tech that they create. I think also, generally speaking, we want to normalize Bitcoin. Ideally, 10 years from now, 15 years from now, we're not having Bitcoin conferences. There's no WhatsApp conference. There's no, we just want it to be technology that proliferates and that becomes ubiquitous. But we need to foster environments in which this can work, which is why I think it's also important that we do get it right in the United States, as I don't think, in terms of world powers, China and Russia is going to get it right. But another part to this is that we're protecting Bitcoin and we're advocating for Bitcoin for people who have historically been disenfranchised to have a shot. That could be women in East Africa who are not allowed to inherit property because of whatever traditional rules exist. I work with those women in a program called Bitcoin Data. In Bitcoin, I've seen it not just be a way for them to save, but it has a catalytic effect on their lives. But there's one story that I want to tell on this note. There's an informal settlement in Africa called Kibera. Has anyone here ever heard of Kibera? Okay, one gentleman, okay. Kibera is the largest informal settlement on the whole continent of Africa. Another word for informal settlement is slum. I don't like using that word because I don't like calling people's home a slum, but it's an informal settlement in Africa. I was at the Africa Bitcoin Conference in 2024. A good friend of mine said, Frank, I need you to go into this place to see this with your own two eyes. So I went there. When I lived in Venezuela, I lived in what's called a barrio, which is their equivalent of like a favela in Brazil, like one of the poorer areas. I lived and taught in that area. So I had been to these areas before, but this area was quite intense. So I wrote this piece for Forbes, talking about the Bitcoin circular economy that had formed there. It's called AfriBit. And it's run by a gentleman who has been a community organizer and someone who's been working in that community for far longer than Bitcoin has even existed. Really, really good person. And I simply wrote this piece saying, in the back of my mind, just hoping, well, I hope somebody reads this and kind of sees that Bitcoin does have a real catalytic effect on these communities. I saw mothers talking about saving for their children's futures for the first time in their life. I saw refugees who are not allowed to use the M-Pesa system, the traditional mobile system, but can now use it because a Kenyan created an app called Tando, where you can spend from your Lightning wallet and it settles over the M-Pesa network. I used that app myself while I was there, and it was super helpful. If you're a refugee in Kenya, you're not allowed to join the M-Pesa network because it's very difficult to get a digital ID, and without a digital ID, you can't use that network, so you're sort of taken out of the digital economy. Bitcoin allows them to be included in it, even if the people they're transacting with don't accept Bitcoin. I published this article, didn't think much about it. What ended up happening, I got an email from this gentleman right here, Rani Maduida. Rani is the person I was talking about who's been doing this work for 2 decades in Kibera. one of the most saintly, sweet, decent human beings I've ever met in my entire life. And he wrote me this long email thanking me. Apparently the BBC read my Forbes piece, and then Reuters read it, and then Associated Press read it. Now, who here thinks the Reuters, Associated Press, BBC likes Bitcoin? Yeah, we have some laughter. That's good. That's what I was going for. That's not how it goes. The BBC traditionally hates Bitcoin. I think the first positive Bitcoin piece they ever wrote was on Gridless. Use that or on Ethiopia, mining in Ethiopia. But what was funny, I ended up speaking with Eric Herzman from Gridless, one of the founders of Gridless, and I said to him, I was like, how did you get the BBC to do that? He said, if you're going to write a negative piece, the only thing I ask is that you come here first and see what we're doing with your own two eyes. And what ended up happening is that the BBC had a correspondent in Kenya. They said that correspondent went into Kibera, went to Afrobit, went to see what they were doing, and they published a 4-minute piece. This piece right here, you could Google it yourself, 3 minutes and 42 seconds of saying, no, Bitcoin is solving a problem here. This is actually happening. This speaks to the point I was making earlier. Not only is the government not a monolith, mainstream media, the MSM, that's not a monolith. There are still people within these organizations that we can get to. The problem is, and I think we all have to work on this, is because we've all been told by friends, family, colleagues that we're insane, right? Oh, this Bitcoin, you're insane, you're a scammer, you're this, you're that. People in my life who I love and respect have said those things to me. It hurts. So what is our emotional reaction? We become antagonistic. We don't believe anyone who has, whether it's Senator Warren, Elizabeth Warren, or whether it's the BBC, or whether it's whatever, Joe Biden and his administration, we don't even want to engage because we're so angry that people don't see what we see. Luckily here, it's not that I went into writing that piece for Forbes to have the BBC do this, but I did go into it hoping that somebody would see it and say, you know what? I want to look into that a little bit deeper. I want to learn a little bit more. And this is to the point that I'm making about what I think comes next. It's what I want to encourage everyone here to do. We are Bitcoin on a certain level. Who we are, we represent it because we care about this network. So the way that we show up for it is going to have an impact on the people, whether or not people adopt it. Personally, I think Bitcoin is sort of an all or nothing protocol. It has to win as the protocol for money for it to fully succeed. So we do need to get to a point where people come to appreciate and understand what it is. And I think stories like Ronnie's story, the Afrobit story, are really important. I'm going to talk a little bit more about Afrobit, 2 other stories before I wrap up, just to maybe give you a little bit of something to think about when it comes to maybe examples to point to next time you have a conversation with someone about Bitcoin and why it's important. I work with a company called called FediNow, and we're working on a project called Satinet. So in this phase, I couldn't make this up. That's Ronnie, the guy that I just had in that slide, and now Ronnie works with my boss. That's Obi in the middle there. What we're doing now in Kibera, in this area, is we're creating something called Satinet, which is going to be a physical structure that helps beam into this neighborhood high-speed internet via Starlink. And the way that you would pay for that internet is via the Fedi app, through the app Satinet, and you would pay in sats. You can pay in fiat as well, but I think you get a 60% discount for paying in sats. So now people are incentivized, not only they're going to get cheaper internet because of what we're building, this physical infrastructure. It's about a $9,000 investment on our part, and there's 3,000 people that will be serving immediately, $3 per person. It's a pretty good investment. So each of these people will now have cheaper internet. They'll be able to pay for it in sats, which means if they were paying for it in fiat, they'd be paying more. Now they're getting to pay for it in this currency that's allowing them to pay less, so they're saving more of those sats. They not only are incentivized to spend those sats, but they're saving more of those sats because of what this is. I'm not going to go into details about this because this isn't a talk on Satinet, but I think it does speak to the fact that Bitcoin is now integrating itself into the real world. It's going to be a way that people get internet in this community. Why is that important? Well, I just went over some of these points. You can get internet for cheaper, but this 4th point here, the data shows that access to broadband internet improves quality of life, improved education, labor force participation, healthcare delivery, all of these things, but there's still billions of people around the world who can't afford it. We're rolling out Satinet in 4 different places. Those are just going to be the starter ones, but the idea is to make sure more people can do this, and Bitcoin is going to be a huge part of this equation. So again, some stories for you to maybe repeat next time people say Bitcoin doesn't have any value or it's worthless. One of the other places we're rolling out here is in Bitcoin Akazi. Another really beautiful story that I think is really worth noting. Bitcoin has a lifeline in Jamaica. As everyone from Jamaica had a huge hurricane that came through there in November. This gentleman right here, a wonderful human being, goes by the name of Dread. what he's done since, so what happened when Jamaica got hit by that hurricane is all of the traditional infrastructure went down. When that traditional infrastructure went down, the banking infrastructure went down as well. So aid was coming into the country, but it wasn't getting distributed for a bunch of different reasons. So what they ended up using was a bunch of different freedom tech, including Signal, Nostr, and then also to coordinate in terms of where funds needed to go, they ended up using 15,000 worth of donations that Bitcoiners gave them to basically say, this was all donations from the Bitcoin community, and said, okay, use this money to get, so Bitcoin became the money of first resort in Jamaica during this hurricane. This was done via the Flash app, which is an app that Dread created. Flash app also has a bunch of different functionalities I'll not going to get into here too much. But we also had, in terms of freedom tech, BitChat also became communication tech that people relied on. Just for the sake of time, I'm not going to get too much into that. The big story here is that what Dread has now created is something called Project Island Resilience. He knows that another hurricane, or everyone knows at some point another hurricane is going to come through Jamaica. So now he's integrating Bitcoin into the island as community, as emergency tech. We use the term freedom tech, but I think this term emergency tech is now emerging. Community centers are going to have solar power generators that gets them internet, Bitcoin nodes, and then they'll be communicating via Nostr when all other channels fail. So again, another story. This is what we're advocating for. We're advocating for Jamaicans who will get resources more quickly because of this technology, because of what people like Dread are building. How many people here have heard of Dread? Okay, that's actually more than I thought. I'm happy to hear that. I love Dread, but part of what I do, that what you just saw here, is it's a podcast that I do where I tried to just highlight these stories. I'm not going to show my podcast right now. At the end, I'll give you a link. But there are so many people doing this work kind of very quietly below the radar. I think it is up to us as part of our advocacy efforts to shine a light on what they're doing, because I can't imagine somebody looking at Project Island Resilience and still saying, oh man, this Bitcoin thing, it has no use. What's the point of this thing? So I think it's important. Stories, someone once told me this, didn't plan to say this, but one of the reasons that people write about, when they write about the Holocaust, one of the reasons that many of the writers who write about it focus more on stories than statistics is because we can't really internalize statistics. We don't really, when we see that 6 million people have died, that doesn't really register, but when you read the story of 1 or 2 people and how something helped them or someone was kind to them and aided them, it tends to have more of an impact. So again, I'll talk about that at the end, but leading with stories I think is important. I just want to quickly shout these two out. In Cuba right now, they're dealing with rolling blackouts. And I saw this tweet right before I was done making these slides, and I had to continue it. I just had these 2 people from Cuba Bitcoin on my podcast, and they have done work that Exemplary doesn't even really begin to touch on what they've done. They realized that people were struggling to use the different Lightning wallets, so they built their own Lightning wallet. They realized people were struggling to use Cashew, what Kale was up here talking about yesterday, so they built their own thing called Kahu. Not only that, but the 2 of them, who are both very technologically proficient, I think this gentleman here has a PhD, are also the same people that were doing the in-person Bitcoin education work, where members of the Communist Party in Cuba would show up, and they had their whole spiel ready about how they were cryptography professionals teaching the people in the audience about cryptography. It had nothing to do with Bitcoin or self-sovereignty or anything like that. So they're putting their own sort of lives on the line. They unfortunately had to flee Cuba. They live elsewhere now, but if you want a story that will just completely blow your mind, I think it's important. But that line right here, this is my second or third to last slide. The reason I kept this tweet in here is because we're sitting here in a well-lit auditorium in the northeast of the United States, immense privilege, learning from some of the most brilliant human beings in the world. And here we have a Cuban, this was translated from Spanish, talking about how I'm figuring out something here. I think he was using Nostr, a bunch of other tools, I think from Libreria de Satoshi. I don't care if the lights go out, we're not going to stop teaching Bitcoin. This is what some people in the world, this is how much they care about this, and this is what it means to them. So hopefully these things are a bit of a reminder to you. And I say this also because all of us, whether we work on the tech side or whether we do what I do on the advocacy side, Twitter is a thing, we have egos, we tend to sort of siphon our energy sometimes into these fights that we shouldn't be a part of. So I'm asking you maybe to do like a 1, 2, 3 and then a deep breath and think like, okay, do I need to pour my energy into this or back into something that's productive that could potentially be helping people that are in scenarios like this in the world? Last 2 things here, I appreciate it. Please keep an eye on what Bitcoin mining is going to do in these countries here, Kenya, Malawi, Zambia, and Venezuela. What we're seeing is that because Bitcoiners are buying hydroelectric power, they're now also being incentivized to help build out the power grid in these countries. Particularly in these African countries, what ends up happening is that Africans, the people living in these small villages along the rivers where gridless operates, they do all hydroelectric Bitcoin mining. They're not sitting in front of paraffin lamps to do homework. They have cheaper, more sustainable electricity as a result of the fact that gridless becomes the buyer of last resort for all of their electricity, meaning, oh, you have extra electricity? Great, I'll buy that from you. It has the effect of subsidizing the electricity rate, which again further electrifies rural Africa, and again has that effect of, there's immense statistics on what it means for a different part of a country to have power to be electrified and how that benefits quality of life in those places. This gentleman is about to go back to Venezuela to help incentivize Bitcoin miners to come there as a means to get access to the cheap energy. They will be required to help repair the power grid in Venezuela. Venezuela produces enough energy for its people, but because of the regime that's been in charge, it doesn't distribute that energy well enough. So now the stipulation or the regulations are going to include that companies that come into Venezuela to mine Bitcoin are going to have to give something back to Venezuela, or they're going to have to help extend the energy system there or repair the energy system there. So I'm going to stop here. So just some quick points on advocating. Another really important part when it comes to like really being a part of that government sort of advocacy, even small donations to the Bitcoin Policy Institute, because of the way that the nonprofit is run, smaller donations allow for the bigger people who make donations to make bigger and more donations. So your $10 donation really will be amplified by the fact that it enables, because you can't have just like 5 mega donors to your nonprofit, you have to have a certain amount of donors. That amount of donors allows for more bigger donors, and those bigger donors to offer more money. Bitcoin Policy Institute, Bitcoin Policy UK, Coin Center, Peter von Valkenburg does great work. Invite local politicians to meetups. I know that doesn't sound fun or sexy. You can all call me. You can call me names and everything else, but again, it was hard. I remember that moment in Harlem Bitcoin, kind of seeing a local politician have an aha moment, having a conversation with that person, having him realize, oh, you guys aren't that crazy. You guys aren't like these Bitcoin people I read about. Leading with stories, obviously immensely important. One last thing too, in that same interview I did with Tim Massad, I gave a talk last year here on the Samurai trial. And when I was in the room with Tim, he's just like, well, I don't know why you said this or that. Like, it's dangerous for people to have that level of privacy. And I put it back on him. I said, well, if we do move to a world where we're using Bitcoin or maybe other open blockchains, do you want me to see how much money you have based on a coffee that you bought for me to trace back your transaction? He said, no. I said, well, then what's the answer to that? He's like, it's a good point. He's like, and I don't have a cohesive answer to that yet. I said, well, hopefully we can continue this conversation. And that was fine, right? It wasn't antagonistic. It was simply saying, like, we're only asking for the sort of privacy that you, a government regulator, would want, or that anybody would want. Antagonism, again, as I said, it's hard not to be antagonistic sometimes. When I started writing about Bitcoin, I was way too antagonistic because I was totally tired of being called a crazy person. I may be a crazy person, I just don't like being called a crazy person. But meeting people where they're at is far more powerful than antagonism. It might take 7, 8, 14, 28, 45 touch points for someone to fully understand what Bitcoin is. Maybe they never get it in your lifetime. I don't know what that is, but there is something to be said about the fact that you're not trying to like seemingly absorb them into a cult. To simply say, something that someone said to me about like, how could you talk to the Trump administration? A friend of mine in New York, he's a terrible guy, blah, blah, blah. I'm not saying that's my opinion, but that was that person's opinion. So I speak with the Trump administration because I believe that on some level, the United States getting this right, this very niche thing, getting Bitcoin right, getting freedom tech right, is going to have something of an impact on the women that I work with in Africa. It's going to have something of an impact on whether or not some other authoritarian regime feels that it's just totally okay to point to the United States and see they banned it too. They're no better. We're doing the same thing as them. We have to be better here, and we have to be better here because as far as superpowers go, what we do here is going to ripple out, whether you like that or not. Ideally, when Bitcoin becomes more ubiquitous, countries, people, everyone becomes more empowered, more self-sovereign, and the United States doesn't have that influence anymore. Probably shouldn't say that out loud, but whatever. But my idea is that we do see a decentralized future where we have more people with more power in their hands, more power at local jurisdictions. But for the time being, we have to get that right here. I know for a fact that if you've had the time to be here with us through this conference, you have a large degree of power, probably more than you even realize. So please keep that in mind. The way that we show up for this, the way we advocate for it on a day-to-day basis really, really, really matters. And I just wouldn't underestimate that. I think I'll leave it there. The podcast that I run is called New Renaissance Capital. I know it sounds like a hedge fund. You can make fun of it, whatever. I'll get into it another day. I do all of this. I basically cover a whole bunch of stories that otherwise we don't do. Number go up talks. We don't talk macro. We talk actually micro. We talk what's happening on the ground in countries like Venezuela, Argentina, Cuba, and how Bitcoin is or isn't making a difference in those places. I included isn't because it's not a cheerleading Bitcoin podcast. It's a realistic look at what's happening. Substack, you could follow me there, Frank on X, and then please use Primal. I'm a big Nostr fan, so check me out on Primal. I probably went a few minutes over. Just wanted to say a sincere thanks again. This was an honor, so thank you very much.
All right, very good evening, everybody. The time that we've all been waiting for. Hackathon 2026, Freedom for All. So after a grueling 36 hours, we had 47 teams who came all over the country, all over the world, started on Friday night, and they've been hacking 36 hours since Friday. And we saw some really interesting projects this year. The hackathon has been ongoing since 2014 and has been running every year since. And this year, we saw a record number of participants and registrants. So today, after last couple of hours where our judges actually sat in a room, went through the list of participants, we have finally come out with our top 3 prizes. So a bit about the hackathon. The prize pool this year is $20,000, and the top prize goes to Lazarus, $3,000. The second place is $2,000, which goes to Voice Pay. Third place is $1,000 going to Liquidity Load, L-Cube, and we have a People's Choice Award as well, which goes to the team that has the highest numbers of likes. And this year, that prize goes to Crisis Chain. The remaining 22 teams, 70% of the 70% of the prize pool will be distributed to the finalists or the qualifying teams, which are 22 teams. Those teams include Butter, BitLego, Cluster Mempool, BitVoice, Pay, Aegis Wallet, Nobel, Tribunal, and Future Coin. So this year, in terms of the finalists, we saw some really interesting products. Some using some using Lightning Labs projects across various different tools, and yeah, we really saw some super interesting projects this year. So we'll get the teams to present, and we'll start off with the People's Choice Awards.
I'm Patrick.
I'm David.
This is Bishru. This is Khan. And this is Isaac. And we built Crisis Chain.
Okay. So first, the problem that we were solving. The number of crises in the world is growing. Threats of war in the Middle East, conflict in Africa, the war in Ukraine has been going on for over 4 years now. The humanitarian aid system is under serious strain right now. Around 300 million people needed aid last year, and not even half those people received it. And that gap is getting worse, not better. The US, historically the largest donor, cut its share sharply in 2025, and no other major economy has stepped in to fill it. The trust problem makes it worse. The Red Cross raised nearly $500 million after the Haiti earthquake and built 6 homes. Stories like that are why donors pull back, which means less money reaches the people who actually need it. NGOs have misappropriated aid for Gaza, Liberia. No NGO is safe from scandals. So you have a funding crisis on top of a transparency crisis, and that's the problem we're solving.
All right, so basically, to put it simply, what we built is a unified dashboard and unified platform for NGOs and donors. For donors, they can go on the globe and see all the crises which we identified through APIs like the ACLED and HTX index, and they can click on a region and donate to the specific region for a cause that they believe in. And for NGOs, we give them a platform where they can see the donations, they can request specific funds for specific items, and they can see real-time data of the conflict in their own region.
Okay, so on the left, this is how aid works today. A donor sends money, it goes through banks, takes weeks, loses a chunk of fees, and eventually lands with an NGO as a lump sum. From there, no one really knows what happens. The audit comes months later, if at all. On the right is Crisis Chain. The donor connects their wallet, funds go directly into a regional pool that's publicly visible on-chain right now. The NGO submits a receipt, the smart contract verifies it, and the payout happens instantly. Every single step gets a transaction hash. It's permanent, it's public, and anyone can check it. The core difference is this. In the old system, you have to trust that the money got there and is being used correctly. In ours, you can verify it.
All right, so all of that, it's just technical jargon, it's picture jargon, you don't need to read it. Basically, why we built it, simple. There's people in need every single day, and we have the technology to change it. I mean, that's why we're all here, yeah? Because we believe in blockchain, we believe in the impact that blockchain can have, and we saw a problem. We saw people dying every single day, and we realized that with this technology that we have, we can change people's lives, we can help people, and that's why we built it. It's that simple.
Yeah, so I could talk a little bit about the technical side of this. So one of the main things that we used was a Solidity contract on the Humanity testnet. And basically what this Solidity contract does is that it holds a sort of mock wallet that holds the funds for a specific region. And then we also use an API, the HDX API. We use this to find nearby NGOs in that region, and then we send emails to them to onboard them onto our platform. From there, the Solidity contract has a donate function to take in money from donors, and also has a payout function that has a bunch of checks for different NGOs, such as cool down on payments and having a certain reserve price within the vault at all times. And then within those checks, it'll send payouts that are valid to the NGOs as needed for the receipts.
So I can talk about the blockchain stuff and the backend stuff. So we basically created our own mintable demo stablecoin through ERC20 and OpenZeppelin. We had our own contract that we deployed, and we called it MUSD, which stands for MockUSD. For gas, we use Humanity testnet. It was the only one that really gave us a good faucet. But other than that, about the backend, there's 2 parts. There's the API gateway, which just communicates with the database, records the transactions into the ledger. It's just basic stuff. And then there's the blockchain part, which actually handles the smart contracts. It leads you to the wallet, connects the wallet. It's more stuff.
And so, of course, we actually did use testnet, so there's real transfer of funds. But here's, for the best part, the actual demo. So here's the globe where this is the interface that users can see, and these are real-world events. So we can click on Darfur here, which is an active, ongoing crisis in war zone. And so if you want to donate, you press here, and you link up to your wallet, which we use this. And so if we wanted to donate, say, like 2 USDC, we first approve it here, confirm, and we can donate, and confirm, and we can see the details. And it should actually take away from there. And so this all also follows from a ledger where you can see like a real, like it's transparent and shows all the transactions, donations, and where this money is actually going. And then here we can go through what the NGOs actually see. And so it's as simple as just logging in here where you connect your wallet. You can go through like your charity number, where you service, and the places that you service. But of course, we already have one simple one signed up with our admin account. We confirm here.
We're just gonna have to wait a while. It's just kind of slow. I can get back on this later too. Oh, there you go. See, the values have got updated. The yellow to repricing action that has happened with the coins. Well, we also have one last feature we want to demonstrate, which is probably not going to happen any soon, which is basically when your alert goes to a certain amount, like when a change in a certain wallet or a mint gets decreased to a certain amount, which big price action happens, there's going to be a Discord message that's sent. Here we're running through a simulation that actually presents this information that's manually overriding our information here. And then you can check it out here in we have it connected to our Discord, which is right here, which shows everything. And for our tech stack, it's just this. If you guys were interested.
Thank you. Thank you. Thank you.
Oh, yeah. Should I plug it back in or?
Any questions from the audience?
I've got a question. It looks like a lot of your signal processing is based on time series data, so it would detect if a mint was degrading over time. My question is, what stops a mint from farming a good reputation, and then once it has a good reputation, it rugs all of the users? Would you have any sort of window of time where you could react to that, or would you pretty much just be out of luck?
Can you repeat that question one more time? I couldn't quite hear you.
I'll repeat again. So my question is, it seems like a lot of your health monitoring is based on time series data, so tracking the mint's performance over time. Is there anything that stops a mint from having a high reputation and then just rugging all of its users at once, right? Because at that point, a proportion of your portfolio would just be gone since these mints are trusted.
Well, everything is allocated. Like, it's not, you're not putting all of your eggs in one basket, that's for one. So the risk is minimized in that regard. And number two, we are calling an API like every 60 seconds. And we're basically like automatically like redistributing the mints basically. So I don't know if that really answers your question.
What happens if I shut my mint off 10 seconds after the last health check has gone through? If you have distributed your portfolio across, let's say, 5 mints, does that mean that I've lost 20% of my portfolio?
I don't believe so. I'm actually not too sure with this technology, but I don't believe so. Like,
okay.
Sorry guys. I don't know if I can give you a better answer.
Okay, thanks.
So just going off of what he was talking about, from what I understand, the way that you're actually determining allocation is proportional to some sort of like almost mean balancing around the curve of the differential between how much has been actually allocated to that mint versus the reputation score. And so if you have someone like who's got a high reputation score but lower proportional mint versus someone who's got a low reputation score, a higher proportional mint, you're actively selecting to try to balance across the network to make them more consistently mint equals reputation, right? And that's how you're doing a lot of the risk hedging. Okay, so in that context, it would not be a even split across 5 different. So if one bad actor, rolled, depending upon when you got in, you would not be losing 20%. You'd be losing, however long they've kept up their game, 10%.
That's what I was trying to say
Perfect.
earlier. Like, your eggs aren't like all in one basket. It's not like a even split. It's like maybe 5% in this mint, 10% in this. So the loss is minimized.
Just because for this demo we only did 6, but in theory this should span over like thousands of mints. So like the minimal like loss if something stopped for 10 seconds is so minimal to your actual cost of production, if that makes sense.
And also, while it's highly unlikely, if something has that good of a reputation with that long of a time, I don't really necessarily believe that it would just like be rug pulled. So. No, that is true.
Thank you so much, LQ. Yeah, so a bit of background of the judging process. So like basically teams came in on Friday, 6 p.m. They've hacked all the way. Deadline for submission was 8 a.m. this morning. And 8 a.m. basically we had a first round of technical review where esteemed judges from in the industry all came in and sat down to review every single project. At 11 o'clock, 10 finalists were selected to go around a second round of screening where 15 judges sat together in a room to rank the top 3 teams. And that's how we got the top 3 teams today. And it's based on technicality, business plan, originality, and various other metrics. Now let's take our time. Now let's take the next team onto the podium. Our second place team is Bit Voice Pay. A big round of applause to Bit Voice Pay.
So hi everyone, thank you for having us. We are Team Bitvoice. I'm Pankuri. And
So yeah, I'm Abhishek Sagar. Nice to meet you all.
And we are Team Bitvoice. So the idea behind Bitvoice, it starts with, I as a user I'm stressed with a lot of stuff, a lot of things going in my life. And I want to suddenly make a transaction right now, right away, back in India, my hometown. So, hey Abhishek, can you help me with this?
Yeah, hi Pankari. So I have an app, which is called Bitvoice. Do you wanna try it? So yeah, let's call.
Welcome back to Bitvoice. Please enter your 6-digit PIN. That PIN didn't match. You have 2 attempts left. Please try again. What would you like to do? Say balance, send, receive, history, or add contact.
Balance.
Your balance is 2 sots. That's about $0. Is there anything else I can help you with?
Yes. Send money.
What would you like to do? Say balance, send, receive, history, or add contact.
Send money.
Sorry, I didn't catch that. Try balance, send, receive, or history. What would you like to do? Say balance, send, receive, history, or add contact.
Send money.
Who would you like to send to? Please say the contact's name.
Bob.
How much would you like to send to Bob? Say something like $5 or 100 sots.
1 sat.
Sending 1 Satoshi token has been sent to your WhatsApp. Is there anything else I can help you with?
No, thanks.
So here, as you can see, so like in this, I think we need to reload the WhatsApp. So I think she needs to connect WhatsApp again. So like, however, we'll get a WhatsApp like receipt. So we'll show you, so like within a couple of minutes. And then, so this is the transaction flow. So yeah, this is basically a kind of send flow. And we also have like, so the receive flow, and then like transaction history check, and then the balance check, and etc. So this is what we have built.
Yeah, so live demos are always not trustworthy. Like even Mark Zuckerberg faces issues, so pardon us. WhatsApp is not coming yet, but I'll send an update if I get now. So yeah, we track live the backend operations, so we could see that the money was sent to the receiver Bob. In the right, we can see the operation and the conversation log, which was happening and going around. And at the below, we are also tracking the transaction log. So one start getting deducted, debited from the account of Sam and getting credited at Bob's end. And we are tracking the users as well in our database. And we have some analytics maintained based on number of daily transactions and what number of transactions happening in the day, send and receive activity, and yeah, number of users, transactions, volume, bit price, yeah.
So, but just to give you a heads up, this is a sample, like the receipt which it is gonna send in like this way, but I think there is some network issue, so the internet is not getting popped up.
Any questions? And so yeah, any questions? So yeah, the idea, why we came up with this idea, the impact was that the users who are not tech savvy or elderly users or anyone around the world who doesn't have much idea can come on our platform with just voice and commands. He could use this track, the app, and make transaction off chain to on chain. Within the Lightning network, Lightspeed network being our core, as the transactions are quicker, so we utilized this platform. That's about the bit voice pay. Thank you.
Wow, imagine a world where I can just drive in my car and send money to people I owe money to. That's amazing. All right, and now for our grand finalist. So this was a consensus among most of the judges, and it's super interesting. It's a space where I think most of us know about, but don't really think about. And so we'd like to invite Bit Lazarus on stage.
Oh, yeah, sure. Yeah. Yes. Okay.
Ladies and gentlemen, good afternoon. We are at Lazarus, where we resurrect dead torrents with Bitcoin bounties. Have you ever came across that file problem before? Familiar to you, where there's no seeds, impossible to download? In fact, research shows that more than 38% of the seeds will be disappeared in 1 month, and then more than 90% of the seeds will be disappeared in the next 12 months, and this is a big problem. This is Alice. She's a researcher in MIT, and she is this close to come across a groundbreaking finding. But then here's the little problem. Alice, she needs a file from 1998, and it's broken. There's no seeds, and it's impossible to download, so she cannot come across this groundbreaking finding. What do we do? That's why we created Lazarus, where we created a bounty marketplace that resurrects dead torrents. Pay stats, get your file back. So how does this work? Very simple. So Alice just needs to put info hash, torrents file, and bounty amount, and just click post. This is Bob the hunter, not the drawer. So Bob has a lot of collection of torrents, and very lucky for Alice, Bob has one from 1998. So Bob press join hunt, and that's where the supply and demand connects. But then how does this actually work?
I'm gonna slow down a little bit. Haven't really slept in the last 48 hours. So going into the core process, the system that makes it a trusted platform and where users can do transactions without fear of presence of a malicious actor in the transaction. So initially we thought of creating a truly trustworthy, decentralized space. We thought of some cryptographic techniques, JQV, and other some stuff as well. But that really didn't work because we had 36 hours and the on-chain competition was too high. So yeah, we came across a screw system, and the main thing about this is bonds, collateral bonds. So before involving in a transaction, both parties, the requester and the hunter, they put some bonds in our ecosystem so that later, if one of the actor acts malicious, their bonds will be snatched. I think a demo would be better than a slide, so I would like to call Sarat.
Hello. I hope you can hear me. I haven't slept the previous night, so I might have brain farts. So yeah, let's just get into the demo, and I hope this works. And it doesn't, so please bear with me while I fix this. Linux issues. Yes, okay, I think this works. Okay, perfect. So, this is the first screen the hunter or the requester sees. So we make two distinctions between the users. The first is the requester, the one who needs the torrent, and the hunter is the one who actually has the files. So the receiver puts up a bounty. Now, how does he do it? First, we log in as the requester. Okay, then we post a bounty. So for now, we'll just create a bounty for a demo torrent file. Which is, if I can see it correctly, this one. Okay, so let's just create the bounty. Cool, the bounty is created. Now, let's move on to what the hunter does once the bounty is created. Shift
And okay, so this is what the hunter sees. He logs in as the hunter, like this. Then he goes to the marketplace, like this. And then he sees the bounty that the person has posted. So let's just view the bounty. All right, here's all the information. Then the hunter decides to, well, hunt it. Okay, so now, once the hunter has showed interest, the requester has to confirm it. So this is what the requester sees. He creates a delivery contract and then pays a bond. So the bond is 30% of whatever amount was set as the bounty. The bond is paid both by the requester and the hunter. And we have run out of money. Let me just reload it. I think we should have money now. Yep, we do. Okay, cool. So now the requester has paid the bounty. Now it's time for the hunter to pay the bounty. So let's just create a register payout, pay the bond. This is what the hunter does. And yeah, and now the hunter can upload the file. Well, okay, this is the file, I believe. And then he starts seeding it. And then the requester just has to download it. Once he refreshes the screen, okay, now there are 0 peers, and here 1 peer. Then he can now download the recovered file, just like that. It's that simple. And moving on, let me just put this on again. Yeah, that was the demo.
Thank you very much. Any questions? We would love to take.
Hi, just a question about the demo. So in one of the stages when you were uploading the file, it wasn't clear to me if you're uploading the file to the platform or if it's actually being seeded. Could you clarify that?
Yeah, for sure. So when there is the screen where it asks for the hunter to upload the file, it's actually using the local browser to host like a web torrent. So the user is actually using WebTorrent in his browser, and the hunter seeds it through WebTorrent towards the receiver's WebTorrent in his browser. So that's how it works. Oh, thank you.
Per se, but one more. Not a question per se, but when Shinobi from Bitcoin Magazine heard about this, he was overjoyed. He's been waiting for years and years for someone to provide a Bitcoin incentive to resurrect old torrent trackers. So he's not in the room right now, but he'd love to talk with you.
It makes me happy to hear that.
Thank you, guys. It's just amazing how much these guys have, everyone that participated in this event has gotten through in like 36 hours. I can't even finish my text in that period of time. All right, and so we just want to give a big thank you to everyone that supported us for this hackathon. The first is MIT IHQ. So MIT is great in the sense that it's so innovative. There's so many places where it encourages entrepreneurship and innovation. And so MIT IHQ, which is right outside the T, hosted the overnight hacking for the team over here. So we're really appreciative for that. And also, very importantly, our judges, thank you so much. I know some of you guys are speaking, but you made time to come early this morning to help with the judging, and a big thank you for that. So a round of applause for everyone here. Thank you very much. And now we'll pass the time on to Thomas for the next section.
So each year at MIT Bitcoin Expo, we presented the Henok Memorial Award in memory of Henok Argol, a beloved member of the MIT Bitcoin Club. I wasn't fortunate enough to meet Henok, but he served as a club secretary and was known for his thoughtful contributions, especially in discussions at the intersection of economics and technology. He was deeply curious, self-driven, and always pushed himself to go beyond expectations. But what truly stood out about Henok was not his intellectual rigor, it was his presence. He brought energy, warmth, and a genuine sense of community to everyone around him. This award was created to honor that legacy, to recognize MIT students who reflected those same values, a strong commitment to the club and a positive impact on the community. With that, it's my honor to announce this year's recipient of the Henok Memorial Award, Michelle Call.
Hi, everyone. I hope you can hear me. I wanted to thank you all for attending the conference from Hong Kong, and it's been such an honor to receive this award, even a few thousand miles away. When Manish first told me that I had this honor, I was first surprised and then grateful because I only got into the crypto space last summer, but everyone on this team has been so welcoming since I've gotten back to campus by giving me responsibility through logistics and also leading by example as I've seen the Expo directors work day and night for the past few months to make this event a success. It has been inspirational to see the team work, and I'm just grateful that I get to be a part of this, even though I'm not physically there. So thank you so much for everyone for attending the conference again, and to the team for this honor, and it's been such an amazing time working with you all.
Thank you, Michelle. So, yeah, with that, the MIT Bitcoin Expo 2026 comes to an end. Right? But before we wrap up, I would like to thank first the audience, everybody here who attended in person, and several others that joined us online via live streams. Thank you very much for your time here. So we hosted this conference for you. Also, I would like to thank all the speakers that volunteered their times preparing presentation, traveling here, and sharing their thoughts, their insightful, promoted insightful discussions. This is a huge part of this event. Once more, I would like to thank all the sponsors that made this weekend possible. The gold sponsor, HRF, silver sponsor, Cake Wallet, Cogcoin, bronze sponsors, Alpen, Nunchuck, Bitcoin++, Hydra X, Anchorage Digital, Fidelity, Lightning Labs, Char, MIT Bitcoin Digital Currency Initiative, the community partners, System 76, MIT IHQ, Optimum, Allium, and Bitcoin Magazine. Also, a big thanks to all volunteers that helped us a lot during this weekend, helping with the registration, managing logistics, and all this work it was really, really much appreciated. And finally, I would like to thank the entire MIT Bitcoin Expo committee, So yeah, this preparation and planning work starts usually around November. This year, for this edition, it started in November last year. So it was about 5 months of hard work from several committees. And I would like to invite everybody in the committee to come here. So I will make sure that I won't forget anybody. So first, Achut, Arul, Ben, Cameron, Caris, Eduardo, Hal, Jonathan, Julie, Manish, Nemwang, Tom, Trey. Yeah, I think I didn't forget anybody. A big shout out for everybody here. Guys, I think that's all for this year. I hope to see most of you next year at the MIT Bitcoin Expo 2027. Thank you.